Esteemed colleagues, distinguished guests, and honored speakers, good morning and a very warm welcome to each one of you. It is both a privilege and an honor to open the Composites Industries National Conference and Exhibition 2024, an event that marks a significant milestone in the evolving field of composite materials and their wide-ranging applications. I, Professor Manoj Sahani from Pandit Deen Dayal Energy University, Gandhinagar, as one of the conveners of this conference, takes a privilege to welcome each one of the esteemed gathering of minds, all united by a shared passion for innovation and excellence in the composite industry. This prestigious conference is jointly organized by the Composites Excellence Center of Asia, Vadodara, Ahmedabad University, Ahmedabad, Indian Institute of Technology, Gandhinagar, Nirma University, Ahmedabad, Ahmedabad Textile Industry Research Association, ATERA, Space Society of Mechanical Engineers, ISRO, Ahmedabad, Navrachna University, Vadodara, Pandit Deen Dayal Energy University, PDEU, Gandhinagar, American Society of Metals, ASM International Gujarat Chapter, and International Automobile Center of Excellence, IACE, Gandhinagar. A special thanks to all our sponsors, that is Indore Composites, Reliance Composite, Alumina Chemicals, Nitpro Composite, Creative Fiber, and Cravel. At this time, it is an honor to invite our esteemed chief guest, Dr. Nilesh Desai sir, Director of SAC, ISRO, Ahmedabad, our guest of honor, Mr. Pawan Tyagi sir, Business Head, Reliance Industries Limited, Professor Pankaj Chandra sir, Ahmedabad University, Vice Chancellor and Chairman, Board of Management, and Mr. Pragnesh Shah sir, the Director of ATERA, to kindly grace the dais. So before we should begin, I would like to invite Professor Sunil Kale sir to welcome Pankaj Chandra sir with a bouquet.
Shake hands, Sunil. That would.
Now I would like to invite Dr. R.K. Singh sir to felicitate our chief guest, Dr. Nilesh Desai sir. Now I would like to invite Professor Vishwesh Badika sir to felicitate our guest of honor, Mr. Pragnesh Shah sir. Now I would like to invite Idil Parekh madam to felicitate our next guest. Next, please. So our gathering here today at Ahmedabad University is a testament to all the collaborative spirit and shared vision of both industry and educational institutions. In the upcoming 3 days, we will engage in an enriching exchange of knowledge, innovative ideas, and groundbreaking research that will undoubtedly propel the composite industry forward. Now, I would like to introduce our Ahmedabad University Vice Chancellor and Chairman Board of Management, Professor Pankaj Chandra sir. Professor Pankaj Chandra sir has been the Vice Chancellor and Chairman of the Board of Management at Ahmedabad University since October 2015. He holds a BTech degree from BHU Varanasi and a PhD from the Wharton School, University of Pennsylvania. Professor Chandra served as the Director of IIM Bangalore from 2007 to 2013 and was a professor at IIM Ahmedabad from 1994 to 2013. His career includes teaching position at several esteemed institutions worldwide, including the University of Geneva and the Cornell University. Professor Chandra research and teaching interests span manufacturing management, supply chain coordination, building technological capabilities, and higher education policy. He has published extensively in international journals and has been involved in several startups and consulting roles with large Indian and multinational firms. Additionally, he serves on the boards of several firms and institutions. Professor Chandra's visionary leadership and unwavering commitment to academic excellence have been instrumental in positioning his institution as a hub of innovation and research. His dedication to fostering interdisciplinary collaborations has created an environment where ideas flourish and transformative discoveries are made. So I request all of you to join hands with me in welcoming Professor.
Well, thank you. Thank you very much. And such a pleasure to be here this morning, Dr. Desai and colleagues on the dais. First and foremost, welcome to Ahmedabad University. You know, this is a unusual center in Gujarat, which is really re-looking at higher education very different. And with the leadership, under the leadership of Professor Sunil Kale at our School of Engineering and Applied Science, we're completely changing the way engineering education not only gets conceptualized but also executed. The two big challenges in many of our academic institutions have always been that on one hand you have companies that are looking for people and they can't find people with capabilities. On the other hand, you have young students who are looking for jobs, but they just don't carry the competencies. And in economics, this is a classic textbook market failure that's taking place. And it's simply taking place because much of our curricular thinking, our ways of looking at problems have not changed in a very long period of time. And I think at Ahmedabad University, we believe that we need to bring complex problems into the classroom. And complex problems don't lend themselves to single discipline solutioning. They will require multiple knowledge systems to come together. They'll require people from very different disciplines to kind of come together to apply their mind and be able to solve it. And that's really the interdisciplinarity story that's getting built here. And I hope that with our wonderful institutions that this city carries, and I think we'll be able to work together to be able to create Ahmedabad as a hub of the next generation of higher education and thinking. And within that same spirit is this world of composites. I mean, we've just, we're so delighted, Pragnesh, that with you there at Atira, which has been leading the thinking on composites for quite some time, that we built here at Ahmedabad, a path-breaking way of looking at composites-related education and also, most importantly, research. And I think with our institutions, with companies like Reliance, with Space Application Center, with PDPU, NIRMA, and others here, IIT Gandhinagar, I think we may be able to build the country's strongest cluster around composites, which is really also thinking about new materials into the future. So I'm so delighted that our Composites Excellence Center of Asia, you've decided to bring this conference here to the city of Ahmedabad. And I'm quite certain that in the way we think collectively, we should be able to probably create not only graduate programs. We're just starting a graduate program around composites here at Ahmedabad University. I'm quite sure with other institutions and companies, we might be able to create the next generation talent, which is very critical. This needs resources in terms of equipment. Most importantly, linkages with companies that are also thinking about issues and problems that can be brought into our academic environment. And if we continue to do that, I'm very certain that this pathway of new materials and particularly will be ours to take here in Gujarat. So welcome once again to this conference. Welcome to Ahmedabad University. And I'm delighted if there's anything that we could do at the university to make sure that your deliberations for the next 2-3 days are more intellectually and really and realistically stimulating. Please do let us know. Thank you and welcome.
Thank you, sir, for your inspiring words. So moving ahead, it is my great honor to introduce our next speaker, Mr. Pawan Tyagi, sir, as our guest of honor. Mr. Tyagi, sir, currently serves as the business head of Reliance Industries Limited, overseeing Reliance Composite Solution. With 27 years of global experience, he has worked across diverse geographies, including India, Japan, United Kingdom, and Malaysia. His deep understanding of diverse cultures, business practices, and opportunities has enabled him to successfully expand businesses both horizontally and vertically. Sir has evaluated organization using the Malcolm Bridge model across different regions. Drawing on its extensive expertise, his foundation in lean practices acquired in Japan has been instrumental in his ability to implement these principles in various work environments. In his roles, he has effectively managed P&L responsibilities, customer acquisitions, operations, quality control, organizational development, and leadership development. Notably, Sir has proven a track record of turning around loss-making automotive component businesses, transforming them into value-adding entities for stakeholders. He is a Six Sigma Master Black Belt and currently holds a general management role where he leads multi-locational composite manufacturing operations. His leadership and vision have been pivotal in driving growth and excellence within the industry. So please join hands with me in welcoming sir.
Good morning, and thank you for the nice introduction. I am really honored to be the part of this event today and grateful for the recipient of the guest of honor. For this, I would like to thank Dr. R.K. Singh because he very humbly invited me for this. I am amazed to see also the Ahmedabad University, Mr. Chandra, for this event, for organizing this event. When I look at Dr. R.K. Singh, I am very amazed to see that his vision and passion and silently is working for this industry, for the growth of this industry. So thank you very much. Thanks for inviting me for this. I am basically, I would like to speak only the general things, and I know that I don't have ability to speak on composite much because you people, lot of authorities from ATIRA, from various universities, from the various organizations, you people already have the more expertise in composite than me, but I can speak on some few general things. I started my career from, I was lucky to start my career from Japan. So I worked with Mitsubishi Electric Corporation in Japan for 1 year. And the exposure what I got in Japan the first year the vision was created during 1 year. That is still driving me. So whenever I like go to take some challenging assignments or to calibrate myself or look at anything, I remember my first year. Exposure what I got in first year Japan. And very frankly, I have done various roles, reached to this level in Reliance and Tata's and all. But when I evaluate myself, I looked at that only in some of the assignment I could do only 30% of what the exposure what I had, somewhere 70%, 60%. We talk about various manufacturing initiative, Industry 4 and digitizations and all. But very frankly, what I saw 30 years back, the exposure what I had, exposure 30 years back in Japan in manufacturing, is still driving me. So the composite industry, I have exposure to like 7-8 years, but the challenges what I have faced in this industry are very basic. Like my first assignment, when I went there, the customers were unhappy and they said that we want to bring some JV company from Germany to India, and someone said that we have a cost, steel is cheaper than composite. So that was our 80% of the business. If these two products moved away, so then actually there was no purpose to continue with that organization. But then problem was very simple to solve. Like quality problems the company A was facing, we could do this with general management things only like in few days. And we also were able to improve the productivity and all. So why I am saying all these things, that about my experience is this with respect to my exposure to electronics industry. If I calibrate this industry with automotive industry and composite industry, this is still, as far as system and processes are concerned, at the basic stage. Like the kinds of challenges electronics industry has faced. When I started my career, there were 250% duty on picture tube and color TV, and then we reduced it to 10%, and every year there were different challenges. Automotive, with respect to quality, delivery, it is at a different level. So this is, when I say it is at a basic stage, it means I am saying there is a lot of opportunity to, there is a lot of potential to improve and to grow, and that provides a lot of opportunities also. So like this, when I looked at my current challenges, the current challenges is raw material prices fluctuations. And second challenges is very, very surprising, that skill level of the people. The people skill, on the one side we have 130 crores people, a lot of people are not finding job. On the other hand, industries are struggling for qualified skilled people. We have a lot of government initiatives. Basically, universities wants to collaborate with the industry. Industry also speak a lot on this, and I am, as a responsible, like I am not at a junior position, but still I am saying that we have not done enough. And there is a lot of opportunity to synergize. Still we are working in a compartment, like some objective, probably industry, I would start from industry. Industry has their own objective. We talk that there has to be association and all, but the efforts are just not, sufficient. I can't talk about the university. I don't have exposure that how much they want, but I think that they want, because they want their student to be placed. So I don't find their intention, but somehow it is lacking the integration in my view. And this integration is very much required. When I was just sitting here and I looked at, organization, Composite Excellence Center of Asia, Ahmedabad University, Reliance Industry, Navrachna University, IIT Gandhinagar, Nirma, Atira, and various other. So I said, this is the theme actually. This is what the collaboration between all these four is required. So we understand that what we need, but somehow our ability to convert or ability to synergize, I don't know why we are not able to do it. I'm not saying that who is responsible for that. We collectively need to come together and see that how can we collaborate better. But this collaboration has tremendous synergy and tremendous opportunities. When I looked at the opportunity in the composite industry, this industry has potential to generate a lot of entrepreneurs, because the kinds of agility this industry requires, somehow corporate will not be able to do that because of their central approval systems and all. So it provides lots of opportunity. Like this industry will create a lot of entrepreneurs. If I looked at the national significance, we need employment. So in this industry, there is lots of employment opportunities. So lots of employment opportunities, lots of basically entrepreneurs will come from this industry, and there are a lot of opportunity. If anybody wants to become entrepreneur, this provides the best opportunity, best platform actually, in fact. Overall, but we have to improve the quality management systems. We have to improve the product development. We can't do much on the raw material fluctuations, but we can improve how fast we develop the process, how our processes are stable, how our learning and development processes are. We can improve the effectiveness of our learning and development processes. And answer is like we need to integrate knowledge partner, technical partners, universities, and so that is the solution. If I just now quantified at the end that if we have done, in my view, when I compare myself with Japan, the first year exposure, I have done only 30-40%. So I also feel that this industry has also done 20%, 25%. But if we improve 20% more, then we have a potential to become global manufacturing hub for composite. India will become the global manufacturing hub for composite. India will generate a lot of entrepreneurs in this particular field. This industry will give employment to many people. Universities like Ahmedabad University will take the lead because they have started the curriculum in this. So future is absolutely bright. Only thing is how long it will take. If we This will happen. It may happen in 10 years, 15 years, 5 years. But 5 to 15 years depends upon how fast we integrate, how fast we collaborate. But potential is there, and we will certainly become, become global manufacturing hub in composite in India. Thank you. Thank you very much.
Thank you, sir, for your insightful thoughts. Now, before we should move on, I am delighted to announce a significant milestone in this conference. We will now witness the signing of the MOU between the EPP Composites and the Ahmedabad University. This MOU marks the beginning of a promising collaboration aimed at advancing research, development, and innovation in the field of composite materials. So please join me in welcoming the representatives from EPP Composites and Ahmedabad University. Request you to please come on stage. So this partnership reflects our shared commitment to fostering academic industry collaboration, driving technological advancements, and creating new opportunities, as mentioned by Sir, for research and development in the composite sector. We are confident that this MOU will pave the way for the groundbreaking projects and fruitful cooperation between EPP Composite and Ahmedabad University. So, it is now my distinct honor to introduce our chief guest, Dr. Nilesh Desai sir, Director of the Space Application Center, SAC, ISRO, Ahmedabad. Sir, a renowned scientist, has been leading SAC since January 1st, 2021. He is a highly accomplished engineer renowned for his leadership in developing ISRO airborne and spaceborne microwave remote sensing payloads, including the RISAT-1, OceanSat-2, SCAT-1, Chandrayaan-2, and others. He has also contributed significantly to the development of real-time data processing techniques and user receivers for the indigenous NAVIC satellites. Throughout his career, Sir has served in various key roles at ISRO, including Deputy Director of the Microwave Remote Sensors Area and SATCOM and SATNAV Advanced Applications Area. As Associate Director of SAC, he demonstrated persuasive leadership and made substantial efforts to promote the usage of indigenous navigation technologies like NAVIC and Gagan. Sir is a prolific author and has presented around 175 technical papers at national and international conferences. He has received numerous accolades, including the ISRO Performance Excellence Award 2018 and the ISRO Individual Merit Award 2010. His dedication to outreach activities related to the Indian space program is commendable, as evinced by his involvement in initiatives like the Vikram Sarabhai Space Exhibition and Smart India Hackathon. So please join hands and a big round of applause in welcoming sir.
Good morning, all. Dignitaries on the dais. Dr. Chandra has just left for an important meeting. Pragnesh Shah Sahab, Tyagi ji, and all the other distinguished participants for this Composite Industry National Conference and Exhibition 2024. Since 2024, I had the good fortune of attending all your since conferences. So, although I feel I am the only non-expert among all these experience as well as the skilled people who are knowledgeable, more knowledgeable than me as far as composites are concerned. I am an electronics engineer, so you can understand my ignorance related to composites. Of course, ISRO has been a regular user of composites and a big user, and it is going to increase only. So I would like to present some of those details for the benefit of especially my friends from industry as well as academia who will feel interested in knowing what are all challenges ISRO is going to handle in next couple of years, which will help you or motivate you to contribute in a big way, especially the composite industry. And as sir was saying, Yagi was mentioning that we want to make India as a composite hub, and Singh Saab is trying that hub becomes operable in Ahmedabad or Baroda region itself. So to achieve those goals, I'm sure, and with the prospective customer like ISRO, you will definitely will go a long way in encouraging and motivating all of you, especially from industry and academia. And as Tyagiji was mentioning that this triad or quad, I will call it, is more important because we have been collaborating, we have been interacting with one another on a one-to-one basis now, but now with the emphasis more on private sector participation in many of the government initiatives as well. So this collaboration, which is, as I say, triad is anyway there, industry, research institutes and academia. And in that is added a government facilitator. So I'll come to that, especially with respect to space, how government wants that space, which has been a very closed sector till now. Since after the COVID, government has decided to open it up and in a big way. And what are all the steps have been taken? Of course, these are beginning times, so many of you may not have come across the possibilities into that, but I would like to highlight a couple of them today so that you get an idea about what is in store, and especially with some of the other things being planned by ISRO related to advanced technologies. We have seen, of course, this month we are celebrating first anniversary of our Chandrayaan 3 moon South Pole landing. And it is in a big way. Cabinet Secretary has called all the departments heads in Delhi and instructed them that all government departments should celebrate it. So ISRO is, of course, ISRO is the main torchbearer of this, but other departments are also contributing in a big way in celebrating this event so that how they can use space. The idea is that how space becomes a factor in the activities of all these other government departments also, so that governance and development can be improved. So that is with that idea. And you may be surprised that Ministry of Agriculture, Fisheries, or some of the things we cannot imagine, all those are also using space in a very big way. And lot of other things are also in store. So some of the things I would like to highlight, of course, coming to composites, as I said, I am a layman, so I will not speak much on that. But the properties like strength, stiffness, lightweightness, or tailored properties. So these go a long way in promoting many activities as far as space is concerned, because of the hostile environment which we face in space, whether it is related to temperature or vacuum or radiation. These are the three major effects which makes space very hostile when we just move away from the atmosphere, Earth atmosphere. So composite will become very handy, and especially when we are trying to do big things. Lightweightness is very important, and CFRP or GFRP or many other new things, especially things like flexible resins, then going for big telescopes, what we want to make, like and using hybrid mirrors, and of course the standard material like PMC, CMC, MMC, all these things anyway we are going to use or we are using in a big way. And the applications are concerned, all of you know, rocket stages or rocket parts anyway use many composites in a big way, various stages, big parts, so that way volume is very big. Similarly, satellite structures and components anyway use again composites in a big way, so lot of scope is there for launch vehicle and satellites. These two activities happen in our other centers in Trivandrum and Bangalore. And as far as we are concerned here at Space Application Center, mainly related to various payloads which we make, instrumentation. So their antenna is one of the basic elements, similarly telescopes. So for all our remote sensing instruments like radars as well as telescopes or camera systems, again composites are playing and are going to play again a major role as far as applications are concerned. So usage and applications. So these are again a lot of scope for various industry people. Of course, there are some requirement related to space qualification. So as such, as in the world today, I think one or two suppliers only are there who give us space qualified resins or fibers or pre-packs. But again, we are trying to adopt newer innovative ways to use quartz devices or quartz components also. So in same way, quartz material also will be utilized in space. So that we try to strengthen it in a different way by tailoring properties or doing qualification, going for product qualification instead of process qualification. Because process qualification generally takes longer time and it will increase the cost and overall turnaround time also. So all these things, how to overcome that. So a lot of scope is there for the industry to work out that, and with more number of missions going to happen, so emphasis on space qualification will naturally going to decrease. As you, all of you must have heard about Elon Musk Starlink satellite constellation. So already 6,000 satellites are in the orbit, in LEO orbit. So you can imagine, he doesn't bother about the qualification. Of course, you need basic, it has to be reliable, it has to, once you launch it, it has to work, otherwise it will anyway create debris in the space. And again, traffic problems like we see on the roads of Bangalore or Hyderabad. So same way, satellite traffic management and debris creation, all these things are real issues or real problems. So, but when you need 6,000, or his plan is to put 20,000 satellites. Similarly, there is a OneWeb satellite constellation from Sunil Mittal. He's purchased one UK constellation and then named it OneWeb. So that has around 780 satellites. So like that, many constellations are coming up for major activities. So even for communication, like Starlink is for broadband internet. So what was earlier done through geostationary satellite, where few satellites would have done the job. Now the emphasis is on using large number of satellites, but in a LEO orbit. So that, and a low-cost satellites using commercial off-the-shelf technologies. So that is another new trend. So you make instead of making a 500 crore satellite, you make a 5 crore satellite. So you don't worry about some few of them going bad also. So you remove it from your constellation and launch replacements. So that is the way, means use and throw type of thing which American society is following now, that is coming in the space sector as well. Where earlier we were very circumspect when we launch any satellite. So reliability and quality was major emphasis, but now it is, I will not say it is taking a back seat, but it is giving now lesser emphasis rather than being a major factor in launching satellites. And their usage of commercial composites is going to go in a big way in doing all these activities, especially launch vehicles, satellites. So these are the two major markets for composite. And similarly for instrumentation, where we need it for building telescope, building various antenna system for radars and communication and navigation system. Again, navigation is going to be another area which is a self-sustaining one because you need navigation. You may not be aware, but 90% of activity which you do in your daily life, when you wake up in the morning and sleep at night, is governed by navigation system. And in navigation means in world today, GPS is dominating. So GPS is controlling your life in some way or the other, every day, whole daily life. So, and recently we celebrated 25 years of Kargil war last week only. And that time our soldiers faced a lot of difficulties and our casualties were more compared to the adversary because of failure of GPS. Either we were not getting GPS signal or the accuracies were degraded from 5 to 10 meter to even hundreds of meters or kilometer. So that resulted into a lot of casualties of our soldiers. So after that government decided to have our own navigation system. And Navic is the one which we are going to hear. And navigation is one aspect where it is going to be there always. So you always go on replacing the satellites. They have life for 10 to 15 years. So like GPS has 32 satellites in orbit. Similarly, we have 7 satellites, but now we are also, because it is a regional system, but we are also going to go global in near future. So again, we will need, and these are regularly, it is not a ISRO project, it is more a national project rather than ISRO. So this opens up all these lot of possibilities as far as usage of composites is concerned. And this type of conferences are really required. And other factor what Chandra Sahab also mentioned in Tyagiji also, we are in the era of, especially India and many other countries, what we saw what happened in Bangladesh and all. So in the era of everybody's, the overall your economy is growing, but it is like a jobless growth. So either students are unemployable or even though growth is there, but jobs are not there. So all these problems, how to solve? So in that sense also development of industry like composites will go a big way in solving the major unemployment related problems in not only our country, but other countries as well. So all in all, this type of conferences have come at the right time, and I'm sure that efforts made by all these academia institutes, research institute like ISRO, as well as individual efforts, what Arki Singh Sahab and other people are making, so will go big way in making impact as far as promoting the industry is concerned, and in a way promoting economy and jobs and other things is concerned. So I wish all the best to all of you for this 3-day conference. And ISRO is always there, not only as a user and promoter, but in other sense also. And as I said, we are opening up space industry in a big way. So you give me a couple of minutes, I'll just show you some of the developments or some of the prospective area which may happen. Somebody can help me to just run this. कॉपी कर लेते भी चलो. 10-15 minutes time. Folder है.
स्क्रीन से है सर
हाँ, पहला
ये वाला
folder. And in this. सीधा करो तो कॉपी करना हो तो चलेगा. तो कॉपी करो.
कॉपी करना
कॉपी करो तो फास्ट होगा. कॉपी करो.
कॉपी कर लीजिए
ओपन नहीं किया।
कॉपी हो रहा है सर। डायरेक्ट ओपन नहीं हो जाएगा। डायरेक्ट ओपन हो रहा है,
Yeah?
इसमें से टाइम लगेगा।
खोलने का ट्राई करो।
खोलने का ट्राई कर रहा हूँ सर। ये सब हाँ मैं वही कर रहा हूँ, मैं कॉपी में यहीं से ओपन करना। हाँ दिस पेन ड्राइव ओपन हो रहा है, इसे कॉपी की तरह से। हाँ वो भी चेक कर रहा हूँ, डाउन हो जाए तो।
जल्दबाजी कर दोनों एक साथ कर।
हो गया, कॉपी हो गया। कॉपी हो गया। हाँ ठीक है, इसे ओपन कर दें सर, बस आप फटाफट जाइए सर। एक मिनट मैं इसको शेयर कर देता हूँ जूम पर, तो सब लोग देख पाएंगे इसको।
So come back again. We engineers generally believe in Murphy's law and Moore's law. These two laws that, so Murphy's law means if it can go wrong, it will. But anyway, nothing was wrong. And Moore's law means technology changes very fast, 18 months for the earlier period. Now it has become almost 3 months or so. So space program, what are the scope for composites? This I quickly try to cover because otherwise I'm notorious for exceeding my time. So this all of you know, so I don't have to tell. Space program originated from India, from Ahmedabad. So that way, Ahmedabad is the birthplace of India's space program with Dr. Vikram Sarabhai. Of course, he died very early, so afterwards, our headquarters was shifted to Bangalore because Satish Dhawan was the successor and he didn't want to leave IISc. He was then director of IISc. So that way we knew that decision, that date. But anyway, it was the right decision because Satish Dhawan handled ISRO for 13 years after that, and he was the right choice because technology was more the focus that time after going through initial period of consolidating requirements for space. Kalam Sahab, of course, all of you know, so he rose to become president of the country. Below you are seeing, gentlemen, is Professor Yashpal, who was that time, uh, again I say that everybody knows NASA. Now people have started knowing ISRO also after Chandrayaan 3 at least. But very few people know about SAC, Space Application Center, which is located in Ahmedabad. It is the second biggest center of ISRO. It is a different center compared to other ISRO centers because we are multidisciplinary. So if you see our composition, and I'll come to that. So that time SAC was distributed everywhere in this Ahmedabad. Some were sitting in some shopping complex, some people were sitting in some school, some other group was sitting in some college like that. So they were all put together as Space Application Center near satellite. And Professor Yashpal, who was a physicist, scientist at TIFR, he was invited to head this organization that time in 1972. So he just completed 50 years sometimes back. So he was our first director. I am 13th, lucky number. So, and below you see a rare picture, Dr. Sarabhai and Kalam Sahab. Both were there together at Tumba discussing something. These were the beginning initial days where Sarabhai used to insist that if you want to make satellites or use satellites for various activities, first learn how to use a satellite for various applications. So that way how TV broadcasts like site, STEP, where telecommunication, the remote sensing experiment, rocket building, all these things happened. And these were all famous pictures, everybody know that. So I will not go into that. And today this is what is ISRO. Those were the beginning days. And today we have this structure. The Space Commission under, we work as Department of Space under Prime Minister's office. So that decision making is faster. That is the basic reason why atomic energy and space are with PM. And we have 7 major centers and many other smaller centers, units, and each of them has its own ambience, as you can see right hand side, whether it is Trivandrum or Sriharikota or Bangalore, Dehradun or Hyderabad. But SAC is different. Ahmedabad center and how it is different, I'll come to that. So this is what is structure of SAC. What changed in last couple of years is in space, what you are saying that. I'll come to that specifically because that has implication for industry also. This is our ecosystem where 13,000 crore is our budget. Recently we got that approval for this year. 17,000 is our strength. It is almost static since last 10 years, but if you see activity has increased 5-fold in last 10 years. So how we are managing using subcontracting, involving more in a big way private sector. So these are the changes which have happened last few years. So we are able to cope up with the increase in activity, which is almost 5 times, as I said, but with same strength of regular employees, 17,000, but we employ more contract people now. Lot of outsourcing happens to private sector. So that way we are able to achieve good progress as far as overall things are concerned. Budget 13,000 looks big, but it is not so big compared to say Agriculture Ministry has 2 lakh crore budget. So you can see comparatively. This is our scorecard, which is again very satisfactory it looks, but we have our share of failures. And as you can see, launch vehicles, satellites, there are very few types. Launch vehicle now we have only 3 types, SSLV, PSLV and GSLV. We are yet to make our reusable launch vehicle and many other things. And satellites are of few types, 6 to 7 types, mini, micro, nano, like that, and bigger satellites for communication, navigation, remote sensing. But payloads which we make, instrumentation, they are of different varieties. So thousands of varieties of payloads exist. So what we make here in Ahmedabad is payloads. So that is large number of it. This is our Ahmedabad center. So I invite each of you, whenever occasion arises, opportunity arises, please do come and visit our center. It will give you an idea about the activity. This is the first Earth station, what you are seeing, the big antenna built by Sarabhai. NEC Japan has built this, Nippon Electric Company. And those days, 14-meter diameter. Right now we don't have any use, but we have kept it as our heritage, this thing. And that this was the only building in this whole area, from Gujarat University to Bhopal. It was all jungle, forest. And in 67, 69 time frame, this building came up. And today we have 50 buildings at this place itself, at Satellite, our campus. And we have 2 more campuses in Bhopal, opposite DPS. So that's how we have progressed or expanded. And of course, now InSpace has come up. In this, it is housed in one of our campus in Bhopal, and that is going to facilitate further the activities. We have our station in Delhi also. Prime Minister used to go to this place to address the whole country those days, late 70s, early 80s. And from that today we have come to this mobile era where sitting at your home you can do video conferencing with anybody in the world. But those days even Prime Minister has to come to this place at Delhi station to address the whole country. We have a very good exhibition, which again I invite. It is open on Saturday, Sunday also, so anybody can visit, especially students and children. And this is our new Bhopal campus, where again InSpace is how this, what you are seeing, the clean room, it is Asia's largest clean room. So what we know, of course, we don't know China, because whatever information we have, even China doesn't have such a big clean room, which can house 6 satellites at one go. So you can integrate 6 satellites together. We have a very big thermo vacuum chamber, 6-meter diameter. So all these facilities which I am showing now are available for private sector, industries, academia. Anybody who want to use that, government has opened it up by some regularization fee payment. You can use this facility for doing your activity. It need not be space related. It could be anything. If you want to promote your industry for some other activities and you want to use for thermo-vacuum testing or thermal testing or any other type of shock test, vibration shakers, anything you can use as far as industry is concerned. SAC is different, as I was mentioning, from other ISRO centers which do the very specific activity, either related to launch vehicle or propulsion or data reception or launching the satellite or making satellite. Unlike that, we do what is known as the heart of the satellite or the brain of the satellite, payloads, NITBAR, and the end product also, applications. So that also is being done at our center. So if you see our composition of human resources, mechanical, electronics, computer, of course, all type of engineers and all type of people in science domain also, geophysical, marine, biological, physical, geological, chemical science, everything. We have ITIs, diploma holders, degree holders, postgraduates, PhDs, everybody, all variety of people. So we are more like you, that is Ahmedabad University. We are more like an academic institute or university rather than a government institute. So that is the difference between us and other ISRO centers. And our activity also are very varied, as you can see, from communication, navigation, optical camera system, micro radar systems. Each of them are a big user of composites. That is another point in this. And same way application related to that. So these are some of the examples. Our satellites related to optical camera systems, all variety of satellites for various applications. We have advanced from 1 kilometer resolution, means this whole campus will appear as one dot in an image. From that to, we can read number plate of car now from space, from a height of 500 kilometers. So that's how progress has been made. And again, making these telescopes or camera systems, composites are going to play a bigger role in future. You can see this. Our first camera, IRS-1L, the first one, 150 kg weight, and it can cater to only 4 bands. From that, we have moved to this Carto 3 type of telescope, which, as I say, can read your number plate also from 500 kilometer with a 0.3 meter resolution and with a CFRP structure. So that's how CFRP has again helped us in improving miniaturization plus lightweighting. Similarly, for radar systems, again, we are at par with world, so we are world leaders as far as radar is concerned. And why I am saying this, I'll come to that. Again, resolution there have improved from few hundreds of meter to now 1 feet, from hundreds of meter to, from kilometer to feet. That is how improvement has happened with radar also. Radar has the advantage that it is a dual use technology. It has military use also. It can take pictures even at night. So that is the biggest advantage even in any weather conditions. So these are all the features which make radar a very useful tool. And again, radar building this radar panels, especially antenna panels and various other elements, again composites are going to play a very big role. And till now, as I was mentioning, we were launching one satellite in 3 to 5 years. Now it is going to be other way around. Every year or even 6 months, we will be launching these type of satellites. So this is our progress in radars. So the big antenna you are seeing right hand side of our first RISAT-1 radar imaging satellite. So it used CFRP in a big way. So again, lot of scope is there for these activities. And this is one, we are going to hear a lot about this. NASA, ISRO. So NASA approached us to collaborate after we launched our first radar in 2012. And last 12 years, we have been working with NASA and JPL. JPL considered to be world's best aerospace laboratory. NASA, of course, world's best space agency, number 1. So they came to India, ISRO, SAC, to collaborate with a proposal that they have a radar which they can provide. But we didn't agree to that, surprisingly. It looks very audacious on our part to say no to NASA or JPL. Because they say we have a radar, you give a satellite launch vehicle, launch it, and we will give you data. But we said no. So then it was done on a 50-50 basis. Means we developed one radar, they developed another. Both radars were integrated. So what we are seeing, the picture is our radar here. The other one is JPL radar. So we sent it to California, JPL, where it is located, Pasadena. They integrated it, and then it is sent back to Bangalore, where it is now getting integrated with our satellite. So in next couple of months, we are going to launch this. Whole world is looking forward to this radar. Again, composite. This antenna, of course, is built by an American company, Astro. It is a large 12-meter diameter, very complicated one. But we are also mastering this technology as far as building these. Similarly, communication satellites, again, lot of scope for composites because, of course, as I said, launch vehicle and satellites anyway are going to be a regular feature which are using all composite, but for payload also, where different panels where we mount the payload elements, so they are all made of CFRP and various substructure element also for this communication satellite. So these were all, as I was mentioning, geostationary satellites. So very few are required to do communication. So they are geostationary orbit stationary. So 3 satellites can cover the whole world. So you don't need in large number to do communication. But as I was mentioning about Starlink, that Elon Musk satellite constellation, so that is now the trend in last couple of years. So 6,000 are already in orbit, OneWeb against 800 satellites. And the advantage is Russia-Ukraine war is a classic case where Russia has bombarded Ukraine like anything and everything is devastated. But still TV is working in Ukraine, internet is also working. That is all thanks to Starlink. So that's how these technologies are going to help. So again, composites are going to play because you need large number of satellite. So that will more volume of work for industry. Similarly, I was mentioning about navigation after the Kargil war. So India has its own navigation system now. Of course, we are still struggling. GPS completed 50 years. Last year, we completed 25 years this year. But we are nowhere in operationalizing that. But we are going to hear a lot about this in next couple of years, where Navic will become a part of a regular feature of your mobiles, like it is GPS is there right now. So again, this is going to be, and as I said, navigation is a continuing system. It is always there. So you go on replacing this satellite, and lot of ground segment is also there. So all places you need composites and its usage. So again, this is going to be a big way. Right now we are using it for governance and various development application. But as I said, it will going to replace GPS, or if not replace, at least augment GPS in near future for various activities. Because right now train movement, small boat movements after that Bombay happened, so that no foreign boat can enter our sources, our waters, and we are not able to track them. So all these things we are trying to take care through this system. Similarly, aircraft monitoring and lot of these indigenization technologies, so they also use, like this center you are seeing a big telescope. So these for astronomical and other observations. So that antenna is built using CFRP as a prototype initially with 3 meters. So such 66 petals were put together to integrate this particular antenna. So such similar antennas we are going to mount many places in the country, which will aid in astronomical and other observations in sub-millimeter and higher frequency ranges. So again, lot of scope for composite industry. This we have anyway used composite to build a prototype. And of course, the final version, which is a 6-meter diameter, is going to be metallic. But there again, we need to explore usage of composite. So there is a scope of lot of activity in all these things which we are going to build. Then quantum frontiers is another area which is going to come in a big way. After all the cyber fraud and all things happening, your OTP gets stolen, your accounts get hacked, and all this will become thing of the past with this quantum technology, where OTP, password, everything will come on a quantum channel using photons of light. So again, building this satellite we call it opto-quantum satellites, quantum communication satellites. So again, we will need large number of such satellites, so which will again feed into the requirements of, and of course, missions like Chandrayaan, Mangalyaan, all these things, because they are planetary missions where weight is at premium. So again, composites obviously will play a very big role in making either rover or many other panels and other things, building these type of instruments. And of course, Gaganyaan is going to be our next major milestone, where already work is going on last 5 years. And we hope within the next couple of years, by 25, 26, we'll be able to put man in space. And then it is going to be continuing program for space tourism, like you have in USA. So these are all building this crew cabin or composite-based stages for this launch vehicle, orbital module, service module. So lot of scope for all these activities as far as composites is concerned. It's just It will be orbiting at 400 kilometer. Mission will be for 1 to 7 days, and 1 to 3 astronauts will go into space and come back after that. Right now we are working on that. Launching is easy, but bringing them safely back. So right now we have all what we call engineering and technology for the mission. But what we are missing is the safety critical aspect. So how to make it safe, like an aircraft, where when you go, you come back to live. So that is what is required, rating all these hardware elements for human safety. And another major requirement is crew communication 100%. Right now, with all capabilities which ISRO has, it is only 40%, 35 to 40%. Means not a single moment we will leave astronaut without communication with Earth station. So for achieving that is a big affair. So again, lot of scope so we'll be launching 2 more satellite first, which will be continuously in contact with Gaganyaan. So because Gaganyaan will be there 2 times in the morning, 2 times in the evening, visible over India. Rest of the time it is moving somewhere else. So during that time it will communicate with that geostationary satellite, and through that it will be looking always to Bangalore. So that way we try to achieve 100% communication. And then a lot of ambitious announcement you would have heard. One is this reusable launch vehicle, which we are going to build or we are testing nowadays. So again, composites will have a major role because it's a 2-stage to orbit instrument where and it will come back. So many reusable parts will be there, which will be re-employed, refurbished and reused. So again, composites are going to play a major role. And then India has planned to build our own Antriksh station, that is like International Space Station, by 2035. That is the target. First module will go by 2028 and it will be assembled in space. So again, we need to develop that new generation launch vehicle. Right now, we are limited by our launch vehicle capacity, which is only 4 tons as on today. That's why we take 40 days to reach moon, when America, Russia, China can go within 4 days. So that is the path we have to still cover. So we are making now our new generation launch vehicle. Again, that will have a lot of scope for composites because new stages will come up, new technologies. And then building this Bharat Avkash station, that will again open up many opportunities, as I was mentioning. So, and of course, future space tourism station, colonies. So, and as far as industry interface, so we have a very established procedure. So all are welcome to take part in there. Many of you are already doing in different forms technology transfer, using our facilities, consultancy, high reliability training. All these things will aid in a big way. So these are for many other industries, but so you can get associated with us through technology transfer, consultancy, indigenization, many other things. So and these are different jobs which we have been doing wherever composite can replace it, we are open to that. This type of all the materials which we are using, and now with the newer materials like graphene and meta materials, other things also we are working on. So of course, as I said, space qualification is one major requirement, but again, for large number of constellations, what I mentioned to you about Starlink and all, something similar India is also going to build. So there it will be more a product qualification rather than a process qualification. These are some of the things which we have already realized using composite. Just for your feed brackets which we are put for our GSAT 19 satellites. So our team is here, so they have made this, Mr. Neeraj Mathur and his team, so antenna related composites which is used for various payload elements. So right now for payload instrumentation, antenna and telescopes, we are using in not that big way, but as I mentioned, we can always improve the overall usage of these composites for various other activities as well. So apart from satellites and launch vehicle, that anyway is a captive market for you. So reflectors, telescopes, and as I was mentioning, opto-quantum, that communication payload. So that will again open up many new areas of working. Similarly for Gaganyaan and the associated other things, all antenna elements related to that. This is another for our meteorological satellite, again developing that hood of composite which was done with the help of Atira. So again that was a very good achievement for us. Similarly, the feed bracket for various communication satellite. And of course, future, we, as I was mentioning about the terahertz telescope and also in a big way, we are going to put, after testing it on ground, in space also, like the James Webb JWST telescope. So something similar India will be building. So for future also, a lot of scope is there. So these are the Cartosat series, the structures for the telescopes, which again were built using composites. So, and if you see overall how right now our market, although a lot of hype is there, but we have only 2% market as far as space is concerned. Global space market, India is contributing only 2%. So that government wants it to increase to 5% or even 10%. So that's why space sector is now opened up. And with the setting up of public sector New Space India Limited, which will again give opportunity to industry to work with NCIL. And in space, Indian National Space Promotion and Authorization Center, which is now headquartered at Ahmedabad, what we lost when Sarabhai died, the headquarters moving to Bangalore, at least something we have gained with this in space being headquartered here. So they will be both arbiter, they are more like a regulator and then arbiter as well as facilitator for various space activities. So all private industries, academia, anybody or student startups, they can approach them not only for funding related things, but also for facilitating so that you can use our facilities in a big way. And space policy, space activity bill, FDI 100% they have allowed. So all these things, many new things have happened so that space sector grows. So you can visit or meet people at in space to get more idea about how you can utilize all various incentives which are available. Technology Adoption Fund is getting now, it is going to be announced any day by Honorable Prime Minister. So there will be venture capital plus technology adoption fund. So there is going to be available from Government of India. So all this will open up lot of avenues for various industries, including composites. So these are different areas where you can work with us, Space Application Center especially, which will help you to contribute in a bigger way so that we move from 2% to 10%. It will be a big jump, 5 times. So as I said, last 10 years we have grown 5 times our activities. It will further 5 times it will grow with all these big announcements related to our space station and all these things. So thank you for being patient.
Thank you, sir, for your enlightenment address and giving the opportunity for the industry and academicians to work with the ISRO. So thank you once again, sir. Now, it is my pleasure to introduce Mr. Pragnesh Shah, sir, the Director of ATIRA. Based in Ahmedabad, Mr. Shah has an extensive background in the textile industry, having previously held key roles at Arvind Limited and Arvind Mills. He holds a degree from the Institute of Chartered Accountants of India, where he completed his FCA from 1980 to 1984. Mr. Shah brings a robust skill to ATIRA, including expertise in ERP, strategy, project management, business process improvement, and creative direction. His leadership and vision have been instrumental in driving innovation and excellence in the textile industry. So please join hands with me welcoming sir.
Good morning, everybody. First, extremely knowledgeable speech from Sri Nilesh Bhai. Every time I hear him, my knowledge about the space application program and the respect for our scientists in ISRO always grows up. We know very little about these programs. We always respect NASA, etc., but we don't know our own people working so much for the space application program. Thank you very much, Nilesh Bhai. Thank you all of you for coming. This is a very important event, and I congratulate Dr. Singh and Ahmedabad University for organizing this. This kind of platform, this kind of networking events are very important for the industry like Composite, which is having extraordinary opportunity, but still at a very nascent stage of the growth. We saw some figures about the space application programs, but if you care to see what size of composite industry is, any guess what size of the industry globally, India, any guess? Suppose I say $100 billion is the industry size globally. You say it is small, big, what it is? And if you say Indian size is maybe $3 billion by 2028. Now let's look at what composite industry can do. Its the biggest role is lightweighting. You agree? The key role of composite industry is lightweighting. If you look at the space application program, so they were using various metals. These metals are very heavy and have a specific function. But if it is replaced by composite material, the weight might go down by 50, 60, 70%, and the cost of carrying the payload will substantially fall. Right, sir? Apart from other properties that it will bring in. So lightweighting is the key role that, or the key benefit that composite industry can give. So if you look at all the application areas in the world where lightweighting can benefit, whether it is space, aerospace, transportation, structural engineering, you name it, and there is an opportunity for the composite industry to work. And if that is the opportunity, why we are talking about $3 billion and $100 billion? Just imagine. Mr. Tyagi also spoke about the opportunity that is there in this industry. It is huge. Let's look at the constraints that we face in the country, which might be restricting the growth in the composite industry. First, possibly the biggest constraint that we face, as Mr. Tyagi talked about, is the raw material. Today in the country, we hardly produce any of the raw material, be it fiber, be it specialty chemical, or even prepregs. The basic prepreg that is needed for the industry, that's not available majorly in the country. We are highly import dependent. Second, labor, skilled labor. For the country, which has got 140 crore people, available of the skilled labor for this particular industry is very less. Third one, the capability of designing and development. If you are looking at lightweighting, if you are looking at replacing the heavier materials of steel and aluminum with the composite, I think the most important skill that we need in the country is design and development, and possibly support by the tooling. And the fourth one that possibly is important equally is that most of our manufacturing processes in the country are still highly manual driven. We have very little of automation. We have very little of technology used to produce highly sophisticated products or the work on the highly sophisticated application areas. These are the hindrances to the industry. These are the hindrances to our growth. These kind of conferences are very important for us to exchange our views and to find collaborative opportunities where we can work together for solving these kind of issues. Okay, I had some presentation, but I don't think we have heard just now. I'm representing Atira. Atira is working on bringing newer technology to the industries for last 75 years. Again, started with the visionary like Dr. Vikram Sarabhai, Shri Kasturi Lalbhai and other industrialists, and Government of India. It was started in 1947 to 49 to bring in the scientific approach to the textile industry. At that point of time, textile industry was already a matured industry in the country. It was almost 100 years old that time in the country, but government felt that it needs a lot of sophistication and scientific. How? Dr. Vikram Sarabhai, Kasturi Lalbhai brought all the scientific brain to the city, and they worked on bringing new technology to the textile industry. If we come back to 10 years back, somewhere around 2011 to 2013. Atira was the first one to get into technical textiles, which is the new sunrise industry for the country. And in 2013, we established our first center of excellence for composites, supported by Ministry of Textiles, Government of India. Since 2013, till date for last almost 10-12 years, we have been working majorly on the lightweighting, developing various products and technologies for various industries. We also work with Space Computing Center for developing some of the components for them. We also work on various products which are having social impact, which are having the sustainability impact. Our R&D team is working constantly in finding newer and newer technologies for lightweighting the composite material, helping industry in solving the problems, and training and skill development. In future, possibly in a year's time, we are going to upgrade our Center of Excellence for Composites to make it much more sophisticated, capable to produce higher-end technologies for the industry. We are going to upgrade our testing facilities. We are going to upgrade our talent group, which will help industry to solve the problems for the adoption of the new technologies. The areas in which today Atira can work with you, with the industry, with academia, are majorly the R&D area and the skill development area. As we are connected so with industry here, as well as the education, the universities, Atira's role is very crucial in actually acting as a bridge between the education and the industry. It is Atira who will help to make the skills of the students, skills of the technician more industry ready. So the Atira's main goal, as we are connected to Ahmedabad University, as we are connected to other education institutes, to bring in more skilled manpower to the industry who are already educated in the field. From Atira's side, I invite all of you, whether it's from industry or from academia, to come with us to collaborate for development of various technologies, for startup supports, incubation supports, as well as training and skill development. We have a team of excellent scientists and the engineers who are having experience of developing newer and newer technologies and products which could be useful to the industry. However, Atira alone in its own lab cannot really function and achieve its objective. The objectives could be achieved if the engineers and scientists are able to work in collaboration with the industry. So that's why we invite industry to work in collaboration with us, where we can work on a joint development programs, we can work on your joint training and skill development programs, where we can work on developing production technologies for stabilizing or scaling up the production. I end my speech over here with all the best to all of you for engaging for next 3 days in a very meaningful discussion over here. Thank you.
Thank you, sir, for your insightful thoughts. We are highly thankful to you. Moving ahead, in this inaugural session, we have the last speaker. Now, I would like to invite Dr. R.K. Singh, sir, Director of the Composites Excellence Center of Asia, to address the audience. Composites, as you all being seeing that, have a rich history and vast applications in our daily lives. And Dr. Singh has been a pivotal figure in the composite industry for over more than 30 years. Throughout his career, he has explored new technologies, collaborated with innovative minds, sourced advanced raw materials, and consistently strived for continual improvement. Sir takes great pride in having worked with some of the world's leading composite technologists and companies. He has successfully led teams to achieve excellence in product development, process optimization, and customer loyalty. With his diverse expertise in composites, extensive international experience, and visits to manufacturing facilities and mines around the world, Sir now dedicates his knowledge and skills to supporting the Composite Excellence Center of Asia in Vadodara. His mission at CECA is to advance the Asian composite industry by enriching the technological skills of professionals and driving improvements in product processes and profitability. So please join hands with me in welcoming sir.
Good morning, all. Respected distinguished guests, Desai sir, Shah sir, and Tyagi sir, and industry colleagues. So it's a great pleasure seeing you all together in the third annual session of this Composite Industry National Conference. नहीं रहता तो चलो।
नहीं यही लैपटॉप ठीक है वो देखते हैं चलो देखते हैं
So there is some technical interruption in between, like we should proceed further. So we at Composite Excellence Center of Asia, we have got the mission to make India the hub of composite manufacturing on earth by year 2030. And with that aim or objective, we are actively collaborating with universities, research institute, as well as industries. So we are working as a pool, amongst the universities and industries. So, the previous speakers have highlighted that India has got n number of people unemployed, but industries, they are not finding suitable skilled people to do their jobs or to complete the jobs, especially in design of composite, research and development of composite, and the frontline workers who can do work with their hands. So to mitigate these issues, we have taken the initiative and started collaborating with various universities and industries. For that purpose, we have started some membership. So we have got membership like individual life membership. So those who are working with industries or the students, research students, they can become the individual members and network and collaborate, help each other. Then we have got corporate life members. So those members are the industry people. And the third category is honorary life membership. The people who have served the Indian composite industry more than 20 years. So on our panel, we have got more than 150 very experienced people having rich experience more than 20 years. And we count the number of individual life members, so we have got around 5,000 life members from all verticals of composite industry, from industry or from institutions or from academia. Recently, we have got collaborations or MOUs with universities like Navrachana University, Vadodara, then Ahmedabad University, Nirma University, Pandit Deendayal University, and you can see them, they are our knowledge partners. Apart from that, like Sri Pragnesha sir told, lightweighting. So lightweighting is also important for automotive. So EVs, when we talk of EVs, or like a sports car, or even any mass transport or road transport, you require lightweight. So for that automotive, we have got MOU with International Automobile Center of Excellence, Gandhinagar, who is having a very good facility, that is Government of India, and Maruti Udyog Limited collaboration at Gandhinagar. Then we also organize various short-term and long-term courses for the working professionals. Short-term courses are those who are in the industry. So if they do not have the technical knowledge or technical courses, so we organize 4 days or 10 days courses. So we organize those programs in-house and online to make the skill set required by the industry. Also, we have a manpower data bank. So for the help of our corporate life membership, so we have got this composite industry manpower data bank. So that helps, like if they require a technician to vice president level people, so we have got a very vast data bank, and that is free of cost available to the corporates, those who are the corporate members. Also, we have got directory, both domestic composite industry directory as well as international composite directory. So those who are our corporate members, they have got access to those directories. We are regularly organizing various master classes on composites in collaboration with IIT Gandhinagar, then International Automobile Center of Excellence, and also we have proposal to do master classes working together with Atira Ahmedabad. So like in the month of August itself, we have got a program at International Automobile Center of Excellence, Gandhinagar, that is testing of composite is 1 day master class where industry people can join and attend that testing of composites. Apart from that, we help Indian industries to take to the international level. So we have MOUs with CAMEX, that is composite advanced metal show happening in USA. So since last 3 years, we are organizing Indian Pavilion at CAMEX. So last year it was in Atlanta, where we were having Indian Pavilion, and around 12 companies from India has participated, including Composite Excellence Center of Asia. This year, this is going to happen from 9th to 12th of September at San Diego, and again we are going to have Indian Pavilion there and taking Indian industry there. So our very much intention or objective is to support the growth and development of composite industry, developing a cluster of composites, especially like Gujarat and India, and yes, we have got on our compass like it is whole Asia, because we are Composite Excellence Center of Asia. So our objective is to making India the hub of composite manufacturing by year 2030. So we are having like a pool of experts to help support individual industries for their technical requirement, and also we have got our technical experts from Germany, Italy, USA, France to support Indian industry and bring the new technology of composites, so we advance in composite industry. So I am very much thankful to all the sponsors, especially Indore Composite, then Reliance Industries, then Neatpro Composite. Then we also are thankful to sponsoring that Alumina Chemicals and Castables and Creative Carbon Fiber to supporting our event. Our special thanks to Professor Kale, who has initiated, actually this program was to be organized at IIT Gandhinagar. He said that, yes, we are going to start composite, so we should be doing this event this year at Ahmedabad University itself. So that's why we all are here, and we support, we require support from all of you to join the movement of making India the hub of composite manufacturing. And yes, hope you all support this. Thank you very much.
Thank you, sir. Special thanks to Singh sir also. Why? Because he's being the architect of this national conference. So once again, big round of applause. Now, before moving ahead, we would like to facilitate our esteemed guest on the dais with a sampling. So first of all, I would like to invite Singh sir to facilitate our chief guest, Professor Nilesh Desai sir. Now I would like to invite Professor Sunil Kale sir to felicitate our guest of honor, Mr. Pavan Tyagi sir. Now I would like to invite Professor Vishwesh Badeka sir to greet Mr. Pragnesh Shah sir with a sampling. Now, I would like to extend a warm welcome to all our distinguished speakers whose expertise and perspectives will enrich our discussions and broaden our understanding of the dynamic field of composite materials. Your participation is invaluable, and we are grateful for your contribution to this conference. Over the next 3 days, we will delve into a diverse array of topics, from the latest developments in the composite technologies to their applications in various industries, including aerospace, automotive, construction, and beyond. The sessions and exhibitions will provide a platform for researchers, industry professionals, and academicians to share their work, exchange ideas, and forge new collaborations. In conclusion, I would like to express my deepest gratitude to all the organizing institutions, sponsors, and participants for their unwavering support and dedication to making this conference a grand success. Together, let us harness the power of collaboration and innovation to drive the future of the composite industry. So thank you once again, and I wish you all a productive and inspiring conference. So there will be a 15-minute tea break, and a tea is being arranged outside the conference hall in the exhibition. So thank you once again. And we'll be here again after 15 minutes. Thank you.
प्रेजेंटेशन था ना सर
हाँ जी कर दिए, हाँ वही कर रहा हूँ मैं सर।
कहाँ पे?
हाँ बस दिस सर ना
कंप्लीट डिलीट मारी।
हाँ यहाँ से
नहीं,
हाँ हाँ यहाँ पे वही आपको
क्योंकि
मेडिकल
उनको
सर में समझ गया, वो गवर्नमेंट वाला होता है वो।
साइकिल बिन में गए थे। साइकिल बिन कहाँ है? बिन नहीं है क्या यहाँ? कहाँ पे रखा था?
ये ट्राई अंदर जो ट्राई 9 फुल है
नहीं ये तो नहीं। हाँ ये
यहाँ पे था।
ये था ना 9 अगस्त।
हाँ वहाँ यहाँ से मूव कर दिया।
ठीक है, कहीं है नहीं ना?
नहीं
देख लो, आप देखो।
इसे सर कैसा लिखी था?
एक है।
रिकॉर्डिंग बंद की है क्या? पॉज कर लो। तो अभी रुका रहेगा ना, थोड़ा लाइन निकाल के नीचे लगा सकता हूँ। बंद हो जाएगा।
कौन सी?
अभी वहाँ यहाँ से कुछ नहीं
हो गया।
मैं निकालना
वो नहीं दिख रहा ना, साइकिल में
ऐसा भी आ जाएंगे विंडो जी। हाँ
बिन नहीं है क्या?
हाँ बिन है ये ना सर, खाली जाएंगे।
ओके ठीक है। ठीक ठीक।
बट इस पे नहीं हो रहा है। नहीं कुछ भी नहीं हो रहा दोनों में, सिर्फ एक यू वॉलपेपर आ रहा है बस वही।
डिवाइस साइड थी कहीं छे अगर वो कंट्रोल पर नहीं था तो
स्विच भी हो गया, कंट्रोल नहीं छोड़ दिया इसने, तो बंद करके चालू कर। अगर लाइन निकाल के वापस कनेक्ट करूँ,
पावर तो आ रहा है। प्रोसेसर को
हाँ यार फोटो एचडीएमआई डिकोडर का स्टेटस गया है। डिकोडर NB21
So have you posters? You will get simply join the team.
આઈ ગયું. આ શું થયું છે ત્યાં? એમની પણ શું થયું તે થયું? चेक करो भाई, कैमरा चालू करो, अनफ्रीज करजो. પણ આ કેવી પ્રોજેક્શન બધી ને ક્યાં છે વાળું?
હા ત્યાં વાળું જ થાય છે. હા પેલું પાછળ વાળું છે.
હા. So,
શું કરે સોય શું કરે? કેમેરો પિન કરવા.
Screen.
હલો ચેક. હલો ચેક.
जस्ट वांट टू मेक श्योर कि हमारा लोडेड है ना।
मैं वही करने आया हूँ।
हाँ,
Come to see whether
आपका है, आप लोड करें।
हाँ मैडम।
एक मिनट तो यहाँ से कुछ ऑपरेट नहीं होगा, सब बैकएंड से होगा।
अच्छा
अगर
पेस्ट
आपको
करना, पेस्ट करना है तो
आपको पीपी हाँ
तो भी वही
यहाँ
से
से हाँ ये सिर्फ रिकॉर्डिंग के लिए है सर।
अच्छा अच्छा मैंने यहाँ से निकाल दूँ फिर।
हाँ ये अभी निकालो आप। पीपीटी प्रेजेंट करना है आपका, कब सेशन है?
हाँ बट लास्ट मोमेंट पे तो नहीं करेंगे ना, अभी से करेंगे ना।
इनके बाद मैम का है, मैम के बाद सर का है, सर का लेके अपने सिस्टम में रख लो।
उठते हैं पार्सल बीजा लैपटॉप यहाँ से नहीं होगा सर। हेलो हेलो आई एम ऑडिबल। हेलो हेलो ऑडिबल
और वहाँ से
ऑडिबल
टेस्टिंग करके हो जाएगा।
जूम
मेरा
जूम
भी
अभी
मुझे कैसे चल सकते हैं?
Thank you all for rejoining us with post tea session. It is now my pleasure to introduce our next distinguished speaker, Professor Inderdeep Singh, Head of Design Research Interest at IIT Roorkee. Professor Singh's research interests are centered around composite materials, including their conceptualization and development, manufacturing of polymer and metal matrix composites, and natural fiber-based green composites. His educational journey began at NIT Hamirpur, where he earned his BTech degree in mechanical engineering in 1998. He then completed his MTech in production engineering in 2000 and his PhD in mechanical engineering in 2004, both from IIT Delhi. Professor Singh's exemplary contributions to education and research have been recognized with several honors. He received the Outstanding Teacher Award from IIT Roorkee in 2013, the Foundation for Innovation and Technology Transfer Award for Best Industry Relevant Doctoral Thesis from IIT Delhi in 2005, and was named Outstanding Sportsperson of the Year by IIT Delhi in 2000. He has published numerous research papers that has significantly advanced the field of composite materials. Today, Professor Singh will be delivering a talk on sustainable composite materials, concept to product realization. This topic is of great relevance as we explore the development and application of sustainable materials in our industry. We welcome you, sir.
Okay, I think we are at the cusp of noon, so good noon to all of you. I'm happy to see a great number of interested delegates from academia, industry, as well as some students who have shown interest to attend academic lecture. At the onset, I'm thankful to the organizers, Dr. R.K. Singh, the Ahmedabad University, Professor Sunil Kale, for giving me this opportunity to come here and discuss what we are doing at IIT Roorkee in the field of composite materials. A lot has been said in the previous session, Since this is a first academic session, I will start from the concept and finally lead to the product realization. As this conference is focused more on industry, I will try to emphasize more on the application part of the composite materials and the manufacturing aspects rather than going into the characterization and testing and analysis. Because here our target is to see what is a composite material and how it can be used for making money. So commercialization is more important when industry is involved. So instead of putting my academic lecture in terms of lot of testing results, this is the strength is improving, thermal properties are like this, flammability can be improved using this is a flame retardant. I have not clubbed anything of that sort into my lecture. It is a purely, you can say, industry specific lecture where we talk about the need, where when you go and sell a composite product, the type of questions people will ask you in terms of cost, in terms of sustainability, in terms of relevance, and then how you can make composite materials, some of the products that we have made at IIT Roorkee, which can be commercialized. And finally, I will end up with something where there can be other efforts that can be put up. To start with, I will try to be well within my limits rather than limits in terms of time, so that we are able to follow the time schedule laid out by the organizers. First thing first, why sustainable? And if you see the title, there are two words which are green. First one is the sustainable and second one is the product. So finally now there is a lot of emphasis on making products which are close to the nature. And we are seeing right now also the climate change that is happening. And since I come from Uttarakhand and the neighboring Himachal Pradesh, I belong to Himachal, serving in Uttarakhand, two border states, but we are seeing what devastation the climate change can cause. And why our products need to be sustainable, that we need to understand. From that point of view, we have to see that why sustainability is an important issue. Now, 2017 at IIT Hyderabad, there was a conference, and I think which was the most well-attended conference I have seen in our country in 2017. There were around 600 delegates, everyone working in the field of composite materials, and out of those, I think more than 25% delegates came from the other countries. Normally, we call a conference as an international conference, but then we have only a handful of delegates from the foreign nationalities. Most of the delegates who with Indian origin only, they come back to visit India, and then we say it is an international conference, but that conference was purely international in all its aspects. So finally, there was a panel discussion in which all experts right from Japan to Canada, all people who are working in composite materials for last 30 years, they sat down on the dais like we had a discussion today morning, and they were given a task, what would be the future of composites. And I am not talking about 2001, 2003, I am talking about 2017. So hardly 6-7 years back, this panel discussion took place. People who have published more than maybe 500 research articles in the field of composite materials. Professor J.N. Reddy was there, a most cited Indian in the field of, you can say, science and engineering. Professor Reddy was there, then his students were there who have also retired from different US universities. So all these stalwarts were there, and I was also there in the audience. Three things came up for the future of the composite industry. First thing, many of them have already worked in the theoretical aspects of composites, as in the morning it was pointed out that we need to do the design part of the composites and then the technology development in the field of composites. So the design is a major, you can say, hindrance than when we talk about the application, because you need to have a sound design which can then be fabricated into a product. So the first thing that came up was the design. Now, design that is done, lot of analysis has been done, which is purely theoretical in nature, analytical in nature. So every expert pointed out that this design has to be validated using the experiments. Now, a design may be suggesting something, the nose shape must be this, thickness of the composite must be this, but it has to be experimentally validated, because whatever we design, when you fabricate it, many things will change. And their process-induced imperfections or defects that we call, Those will creep in when you try to manufacture it. So whatever design states, you have to experimentally validate it. That was the first important outcome or first important, you can say, highlight of the panel discussion. Second important was the volume. In the morning, we had a great presentation for ISRO. The composites were developed for the aircraft industry for lightweight applications. All of us have understood it. Now, lightweight applications, if we talk about how many aircrafts we are manufacturing in the world. So, if the composites are only going to be used for manufacturing of aircrafts, the volume will always be low. Even if we talk about spacecrafts or rockets, whatever application we take, high-end application, the volume of material required will be significantly less. I am going to talk about material to your bathroom. When you go in the morning to brush your teeth, you use a plastic handled toothbrush. If we can reach to that level of application of composite materials, then the volume will significantly grow and we will start seeing composites all around us. It's not only in the aircraft industry or in the space industry where the composites can find application. They can find application in day-to-day products also. I'm talking about a toothbrush handle which can be easily made with a composite material, which can be a thermoplastic. Most of that industry in India, as I see, are focusing on thermosets. The thermosets are also going to be very soon replaced by thermoplastics, because now we have three R's of sustainability. All of you know: reduce, reuse and recycle. Now thermoplastics are easy to recycle as compared to the thermosets. So in future we will see many applications where the thermosets will be replaced by the thermoplastics. So that was the second aspect which came out, that whatever we are doing, we should try to increase the volume of composites in our day-to-day life, or volume of consumption of composites in our day-to-day. And the third thing that came out was, which has also been highlighted in the morning, that who will make composites? And if you use a composite product, who will repair it once it is damaged? So there has to be a skilled manpower or at the grassroots level which can help us in repairing the composites. In the morning there was discussion on pre-pegs. Now pre-pegs are not manufactured in India, they are bought. The cost is very high. Second thing is, even to maintain them, you have to maintain a temperature of -16, to keep them in a state in which they can be reused, or they can be used whenever there is a need or requirement. So not only pre-pegs, buying of pre-pegs, but also maintaining the pre-pegs in the state is also a challenging task. You have to maintain environment. So we have to have people who will be experts in the field of composites, not only from manufacturing point of view, but from repair point of view. So there need to be a skilled manpower, and till date, we don't have even a single UG program focusing on composites. And I am very happy to note that Ahmedabad University has decided to start a PG program in the field of composite materials. So at least at IIT Roorkee also, we are in the process of discussion with a team at IIT Delhi to lead a joint program in the field of composite materials. Rather than starting a master's program in composite material, we are planning to establish a center for composite materials where the diverse experts from different disciplines and different departments can collaborate. Now this is an interdisciplinary field. If you talk about a polymer, you need to have a chemist or a chemical engineer who has all the details about the polymer. If you talk about fibers, again you need experts from textiles, as in the morning we have heard a lecture from the director from Atira. So here then you need to have a mechanical engineer who will bring these two things together, the polymer and the fiber together, to make a good quality composite material. Then once the composite has been made, you need someone who will test it. And then after testing, there has to be a techno-commercial evaluation whether this will be able to satisfy the commercial viability of the product in the market or not. So you need to have someone who will have, as Mr. Tyagi was there in the morning, who is a business head, to see how you can make money out of making a composite or fabricating a composite product. So I will restrict myself in the presentation to what we are doing at IIT Roorkee and why sustainable products are important and are going to be the future. Here also you see things have started to change. When we used to attend a conference 10 years back, 15 years back, all these bottles used to be plastic bottles on the table. Now you see glass bottles. So things have to change right at the grassroots level to make an impact. Other than we can discuss so many things, but when nothing happens on ground, normally we lose hope. So we have to see with little modifications in our day-to-day life, we can easily replace one of the most damaging materials for the environment, which is a polymer. I think, Mr. Pavan, please excuse me, because Reliance Polymers is doing good business, but in future we have to see that how Reliance can bring in biopolymers into our day-to-day consumption, so that which are easy to recycle, easy to degrade, easy to sometimes if possible biodegrade. So we have to see that materials at the end of life. Not yesterday, 2 days back, we had a speaker from University of Akron, Ohio, Professor Ajay Mahajan, who happens to be from IIT Delhi. He has worked for the racing car for Schumacher. So he said, he was discussing in one of the discussions, what is an ideal sports car? In the morning, that discussion has already come up. What is the recyclable satellites? In the morning, Director Sir was pointing out recyclable, reusable satellites. So from there, that thought crossed my mind that Professor Ajay Mahajan was talking about what is an ideal sports car. He told the manufacturer told him that the ideal sports car is a car which ends the race without even a single drop of gasoline or the fuel left in it, and it automatically disintegrates into the part after crossing the line. Now that is the ideal scenario. A racing car, driver gets out, maybe in next 10 minutes it disintegrates into the different parts, and all these parts are recyclable, reusable, and these can be easily disposed of. And then you can reuse these parts to make a new car. So that is the ideal scenario of products that we are trying to conceptualize. For example, here also, for composite materials also, once the product has lived its life, we have to find out means and mechanisms to see what happens to the products at the end of life. So just I have taken an example of a racing car which also uses lot of composite materials, because you need to reduce the weight of the car significantly to improve its, one is the speed and another one is the fuel efficiency. So concept of composite materials, I believe, is known to all of you. Now I will just try to focus on 1 or 2 slides what is the basic concept, because I start with concept, then finally to the products, and what are the challenges with sustainability. Just 1 or 2 slides I will try to emphasize on that. So this is a well-known definition of sustainability given by the UN, and we need to be sustainable on all fronts: economical, social, and more importantly on environmental context, because there are limited resources, limited space, limited time, and so on and so forth. Not changing. Now it is. It will take some time. Pointer, I think, is not working. Okay, now it is working. Okay, so I was here, so I think I had to point it this way. So this is the context in which I am going to speak. Now we have a concept of design for excellence, because when we talk of a product, then we talk about manufacturing, a design of the product, then manufacturing, and then using the product. So first thing comes in a product development cycle is that design. So this design for excellence is a, you can say, well-known concept. So what excellence means, X can be a variable. So X can have different aspects as mentioned there. It can be manufacturing, cost, quality, assembly, sustainability. Sustainability I have definitely put in green, because that is the title of the talk today. And if these guidelines we are not focusing. Now in design for excellence, what is the basic concept? That when we are selecting a product or making a product or thinking that this product we have to make, we have to focus on all these aspects: the cost, the quality, the manufacturing, the assembly, the sustainability, and we have to come up with a solution which makes a trade-off among all these different aspects. For example, for aerospace industry, one of the important aspects can be the weight. Since morning, when all speakers have focused on the weight. So weight can be one of the parameters for a product which has to be used in aircraft industry. And in one of the books, it is written that if you are able to save 1 kg weight of an aircraft, you can save 6 gallons of fuel. So that is the kind of advantage, the you can say indirect advantage you gain by reducing the weight of an aircraft. So what I am trying to emphasize is focusing on the product, what is going. For example, you want to make a toothbrush handle. Maybe weight may not be a very, very important criteria there because already it is lightweight, it is a plastic. Then you are making a composite. Target can be sustainability. Even there is a design in which a toothbrush handle can be used multiple times, only the part with the bristles will change. It can be screwed or joined using any type of arrangement with the handle. So handle you can reuse it multiple times, only the bristles part you change as per the advice of the doctor, maybe after every 3 months. So that is when you are designing a product, you have to see that what are the focus areas for that product. It can be cost, it can be reliability, it can be quality, it can be assembly, it can be manufacturing, it can be sustainability, it can be environment. So that we have to keep in mind. And if we don't follow these guidelines, what can happen? Many products, if you Google or you go to YouTube, put failed products, you will get long list of videos where they have highlighted that what are the failed products and why they have failed. So if the guidelines are not followed at the design stage, the product can fail. Now DFX has got different dimensions, as I have already highlighted: assembly, manufacturing, cost, service, safety, reliability. Now our focus today is design for environment. So sustainable composite materials means materials which are good for the environment. So how we can follow these guidelines? What is our model today? I think those from industry will definitely echo the same sentiments that I have. What is our model? Our model is take, make and waste model. So we take some material, first we identify who are going to be the raw material suppliers. In the morning, I think everyone has said it, there is a challenge to get the raw materials. So we take the raw materials, we make a product, we sell it in the market, and then our job is over. Normally we don't think what will happen to the product at the end of life. So that is not going to be the case in the next 10 to 15 years. There we will have to take responsibility of our product right from the launch in the market to what happens to the product at the end of life. I have just 2 sentences to say. One of our professors went to Japan and bought a second-hand car. So when he was coming back, he was not able to sell it again. He had to pay more money for disposing it off rather than the money that he spent for buying the car. So what I am trying to emphasize is, you as a user, you have to take the onus of the product, or as a manufacturer first you have to take, then as a user I have to take onus that what happens to my product at the end of life. So therefore these concepts become much more relevant, that we design a product in a way that it is reusable, it is recyclable, or you can remanufacture it. So therefore this concept of design for environment has come into being. So enormous amount of waste is created, and we have to see how we can eliminate this waste. This is the overall product life cycle. Our focus today will be on materials, as I have highlighted it. Then the materials will be made into a product which will be distributed, users will use it, and finally it will be disposed of. Now where design for and what we are doing at IIT Roorkee, we are trying to select raw materials which are natural in nature. These biopolymers are also available, these have been commercialized. Then we make samples. Then we make products with these samples. These are obviously not our products, but from the net. But whatever products we have made, I will try to show. And finally, at the end of life, what can be done? There can be, we can try to decompose them, and they get converted again into the natural ingredients. So this is a cycle which we try to analyze in our studies. So this is a very, very important diagram, and this chapter has been introduced in this book by Steven Pinker just maybe 10 years back. Earlier, this was a book, very famous book, Product Design and Development. But now this chapter on design for environment has been added. And if you see, this is a natural cycle on the left-hand side. And from nature, we are taking the materials, we produce a product, distribute it, use it, and then at recovery, we have to see what can be done with these materials. So this is, I think, a challenge. When we take the materials, what we can do, these are the guidelines, what we should do when we are designing a product. We must focus on renewable resources as it is given at the top. So when we choose materials for our product, we have to focus on materials coming from renewable resources. And when we decompose the products back into the natural cycle, we have to avoid the disposal of toxics and inorganics into the environment. We should focus on organics. So our first decision to choose a material for our product is very, very important, because if we choose a very, very environment friendly material for our product, then automatically at the end of life we will have less challenge to dispose it off into the environment. So therefore, first choice at the first decision regarding the materials, if we can do that, it will make our life easy. This is a summary of this. These are the challenges for plastics all over the world. Every year we celebrate the these are some of the case studies about the plastics. These are the single-use plastics. I will skip this. I think everyone is aware. So on World Environment Day, every year we try to focus on the environment. So what the composite industries can take from that is we have to reduce the use of polymers, try to emphasize on reuse. Now, reuse is only possible if your raw material is recyclable. If you talk about thermoset difficult to recycle, but then for thermosets also now there are a lot of strategies. You can pulverize it, grind it, and then mix it with some form of other material, use it as a filler. So you can have different strategies for recycling of thermosets also, but thermoplastics are easily recyclable. We have done a lot of work in recycling of thermoplastics also and published it. So if someone is interested, you can write to me, we can discuss it further. So what we are trying to do now is, with this reduce, reuse, we are trying to integrate the natural fibers with the thermoplastic polymers and trying to make composite materials which are natural fiber. So natural fiber reinforced polymer composites. So this is our concept now. We take a polymer, which is our matrix, which is biopolymer and biodegradable fibers, and combine them together. How we combine them, which I will be showing in the next slide, and then we try to make the biocomposites, which are green in nature. So sustainable composite materials we are trying to emphasize on, which are renewable, recyclable and biodegradable. Now many times these materials are difficult to degrade, and biodegradable means that you will degrade them under a specific environment, maybe a composting environment. You have to create a pit, put the samples there, and then investigate how this material will degrade. So all those aspects we are trying to analyze. One of the students has already completed a PhD on understanding that how these composite materials will degrade over a period of time. Maybe for 6 months, 1 year, 1.5 years, 2 years, what happens to the materials. So that kind of studies already we have done. So this is a concept of natural fiber based composites. You can make partially green composites or fully green composites. Fibers are derived from nature. They are natural fibers. And we can even have hybrid, where you can have, many times we talk about the strength. I know this question will be coming to many of the delegates' mind, that this strength of carbon fiber is very high, glass fiber is very high. How these natural fibers will be able to attain that kind of strength? So therefore, initially only I told that these materials right now are being proposed for non-structural applications, high volume. On a table you have a stand which is made up of a plastic. Now you can replace that using a thermoplastic and using 30-40% of fibers. The fibers are also coming from maybe sugarcane waste fiber, or you can use rice husk, you can use wheat husk, you can use even in Uttarakhand and Himachal these days, not these days, maybe in the month of April, May and June, lot of forest fires, all of you may have read in the news or even seen in the television. Now these fires are caused because of the pine needles of the pine trees. Now these fiber, government is saying we are ready to give free of cost. Even we are ready to collect also, and we will supply wherever you want, because this is a menace, because it leads to the forest fires, and lot of our jungles are maybe subjected to fire. Even Forest Research Institute is doing a lot of research how to avoid this problem. We are also collaborating with Forest Research Institute in Dehradun and trying to develop the fire dosing tools. This year only 5 people lost lives during the jungle fires in the state of Uttarakhand. So this is natural resource which is freely available. Now if we can put 30% of this into making tables with biopolymer, this can be a good product which can be used by all of us, which will be a environment friendly, or we can say biodegradable product. So this is the concept through which we can have. The next slide will make it more clear. So if we have natural fibers and biopolymers, we can make fully biodegradable composite materials. But at the same time, there are non-biodegradable polymers like the ones that we use today, epoxy, then we use polyester. So if we have different types of non-biodegradable polymer, then we combine with glass fiber, carbon fiber, and make non-biodegradable composite. So in future, maybe we will see that there will be a transition from non-biodegradable to fully biodegradable composites without compromising the strength and other requirements. And then this was the old practice, and this is the research trend now. Today also morning I was checking my email, 2-3 research articles have come, all of not only from India but from the globe, where people are focusing now on natural fibers all over the world. It's not only, but India has very large, you can say, flora and fauna, the kind of fibers. We are the biggest producer in many natural fibers as a country. So we can always leverage the potential that is the nature has already given us. Now only we have to think that how we can make entrepreneurs out of it and how we can make products out of it. So what we have done now, maybe another 10 minutes, we have this, because we are academic institute, our outcome is measured in terms of publication and in terms of technology transfer. So we do research in this area. These are the samples that we make, which are as per the ASTM standards. Different tensile flexural impact testing samples we make. And this is the setup that we use. This is a direct injection molding setup where you have a fiber, a polymer. Fiber is in the short form. Therefore, I told these cannot be used for very high strength applications where you need very, very high strength. You have to go for woven fiber as a reinforcement. But here we use short fibers. Natural fibers are available easily in this form. We mix the polymer and the polymer pellets and the fibers and then mold them into the samples. These are the samples. Then we use extrusion injection molding process also, where we extrude initially the fibers and polymer pellets into composite pellets, and then these composite pellets we use as raw material for injection molding and make the samples. This is an extrusion cum injection molding process. Same samples we have made here also. Then we can even use extrusion compression molding, where we extrude first a wire, then we take it to compression molding and compress it in the form of a plate, where we can get this type of composites in the form of tiles. So I'm not showing the mechanical characterization, but these are all the samples made by different processes: direct injection molding, extrusion injection molding, and extrusion compression molding. And if you see the effect of fiber loading on the right hand side, we can see a pure polymer composite thermoplastic, not a composite thermoplastic sample, 0 degree fiber, then 10 degree, 20 degree, 30 degree. So the color is also changing by addition of the natural fibers. These are some of the samples. We got a project from the top furniture manufacturing company in the country. So these were the products that we changed for them. The top one is the first product that they were making, a pure polymer product. Then we put 30% sugarcane fiber into it, and this is the product that came out. These are some of the products that we have developed. These are all child parts in a chair, different types of child parts that are used there. Then this is a flower pot which can be made. This is a pen stand which can be made with a natural fiber based composite. And you can even give different shapes depending upon the mold that you use. Then this ward separator also, during COVID we have developed this. This is not our image, but we have also developed a similar ward separator in which we have used a recycled these coats that were used for the patients. Those were recycled and then they were used with jute fiber to make the composite. This is one chair with jute fiber and epoxy, which was made for just as a demonstration purpose of application of composite. Now this can undergo a lot of iterations. It can be further improved. I have already got this message for the time, so I'm just skipping some of the. उधर करना है? अच्छा, अभी आप बहुत लास्ट में आए बताने के लिए. कोई बात नहीं, we have to be happy. So now, since all of you, many of you are from industry, and then sometimes we feel that X is an expert or Y is an expert in this field. Now, how to get in touch with that? And many times for academia, you feel that people charge IIT or other institutes charge a lot of money to provide the expertise. So one of my students has developed this software in which this is a process selection software in which a user can give the input. As you see at the top, the thermoset or thermoplastic, which material you want to choose, there is a drop down menu. Then the shape complexity or the process also, check the processes that are available from this table. You can see which shape closely relates to the product that you want to make. So based on all this information that the user will provide, he may not be having any technical knowledge. He may not even have heard of all these processes that are listed down there. So he is just an entrepreneur who wants to start doing business in the field of composite materials. So they can use this platform for selecting the right process for the composite material. So this we have done a case study on this chair only. Now this calculates based on the input, it calculates PCS, which is a process compatibility score for all the processes. Now all these processes that you see there, compression molding, hot pressing, reaction injection molding. So there is a long list of processes. It calculates a PCS score and a cost rating. Now many of you may be wondering how this software will work. So this PhD, she has already completed, a girl student, because in composites I thought lot of experimental work if you have to do, you have to go to the lab every day, spoil your hands working with the machines. Being a girl, although girls do better job than many of us when sincerity is concerned. But then she said, sir, I am from industrial engineering. I want to do something related to software. So then I said, okay, you do this job. And she has done a wonderful work in this. And this 2.5 to 3 years was only spent on collecting all the data available in the world in the field of composite materials and manufacturing of composite materials, processes related to composite. There are huge database that was created, and based on that, she used the artificial intelligence and machine learning algorithms to code this whole program. And this is a graphic user interface which was created for the composite industry, where the user may not be an expert. He would not like to spend 3 years to collect this data. He can or she can only put the input that I want to make this product. It resembles closely to this product, because if it is directly the same product, it will even give you a better result. So you choose the shape, you choose the volume, how many you want to make, you choose the materials that I want to make in thermoplastic or I want to make in thermoset. The software will calculate these two scores, the cost ranking and the process compatibility score. Then you can do a trade-off and select the best process. And the software will also provide you one summary of the process. For example, for making this, compression molding has been found out by the software. Compression molding process can fabricate the composite with higher fiber volume fraction, less than 60%, and type of products it can make. So it is kind of an expert system which can assist the entrepreneurs who want to venture into the field of composite materials. So now the last part, the future, where it can lead us to. These are all the samples that have been made, and if you see, it is showing as 25.98 grams. And if you cut that sprue part, it is 2.46. So almost 10% of the material is going as waste. So this 10%, what we have done, this 10% we have collected, we have not disposed it off. For different samples, these are the samples which were fabricated, and with this process waste only, we have again recycled them into the samples and then again tested. So multiple time recycling was done. I am not showing the results here, but we have found out that 3 to 4 times if you recycle, 5 times also if you recycle, the properties of the resultant composite is better than the pure polymer. This is a thermoplastic polymer. So if you use a polymer, you get property X. If you add fibers into it, X plus delta X. But when you recycle it multiple times, still the property that you get is more than X. So it means that it is recyclable 3, 4, 5 times you recycle it, still you get the same properties which are better than the properties that you get with a pure polymer product. So which means that this is also published in an article. If someone is interested, write an email to me, I will share. read the article, how it was done, what were the results that were achieved. But today, I don't want to, you can say, barrage you with lot of data and strength and stiffness and all these values. Just a concept that this is a concept which may be in the composite industry in the next 10 to 15 years. Maybe it has already started, but then we will be seeing products which are, I have visited there was the Plast Focus exhibition in Delhi, I think 3-4 months back, and there were already 2-3 companies which have started making products which are using natural fibers and thermoplastics for making the mugs or for the tabletop products, or these type of companies have already started to, entrepreneurs have already started to explore these ideas of sustainable products for making, you can say, money out of this concept. So with this, I think I will stop. Instead of 5, I think I have taken 7 or 8 minutes. So thank you very much. If there are a few questions, you can ask me.
So any questions from the audience?
Yeah, please. Sorry. Yeah. Yeah, so when we did this, 2 words very important, consistency and scalability. Now for I'll take it in two ways. First thing is consistency. Now for consistency, if you see a banana fiber from North India and a banana fiber from South India, obviously there will be some difference. But then we have to see that which fiber is going, and for non-structural application, the strength of the fiber is not all that important. Only thing is your main selling point or USP is that you are reducing the use of 30 or 40% of the polymer. So if you are able to integrate 30% of the fiber into a polymer product, you say my product is more green as compared to another product which is using 100% polymer only. So we are not using these fibers for strength. So wherever the fibers are being included into a composite material for strength purpose, there the consistency of fibers is very, very important. And variability also we have seen. Once you treat the fibers with different, we have even some of the reviewers suggested that fibers we have taken natural. Treatment you are doing chemical, where is sustainability? Then we developed the treatment process also, which is coming from the sustainable chemicals only, which are like, we have done one study on sodium bicarbonate, which is a natural alternative to sodium hydroxide. So you treat the fiber, then the consistency significantly improves, and all fibers are then consistent once you treat. And in glass fiber, carbon fiber, you only say sizing of fibers, but here we do maybe treatment of fibers, natural fibers, maintaining the natural characteristics, but still improving the consistency of the fibers. And the second point that you pointed out was scalability. When we did this project, I will discuss with you off the stage because I can't name the company here. So when we worked for this company, they called me, they said, okay, sir, the concept is good, everything is good, but who will give us the fibers? So they called one of my PhD student. I think he will be coming here tomorrow. If you find time, you can discuss with him now only. So they called him and told him, यार ये fiber का plant लगा लो आप, और ये सारा fiber जो है, is there Manish? He is already there, so you can discuss with him. They said कि आप plant लगा लो fiber का, हमें आप सिर्फ fiber supply कर दो. We are ready to get into this agreement with you. So as a professor, means I cannot start at that time, maybe 10 years back. Now we have a entrepreneur policy for the professors also. We can also be a part of a company. At that time, we didn't have a very clear-cut outline that whether a professor can be a part of a company or not. Now we have a clear-cut policy. So I could not get myself into that business, but then my students, they interacted with them. And finally, it didn't work out because of a number of reasons. But now we are in touch with many companies who want to be, there's a torch manufacturing company in Haridwar only. Those who are after us, they are asking us to transfer the technology. But he has started his own company. So now we are trying to get into that company through his company rather than IIT Roorkee getting into a direct engagement with that company. So that is possible. Scalability is always a issue, but we have for example, we are called as a sugar belt of the country. Western Uttar Pradesh and this plain area of Uttarakhand. So a lot of sugar mills are there. So the sugarcane waste fiber is available in abundance there. Only thing is someone has to draw that value chain together. You have to talk to the supplier, things will be available, technology is already known to us, and we can start. Products are there for you to see. He may have also brought some products physically. Have you got some products?
Yes, sir. It is with me.
So you can just interact with him. My job is to, the third part in the beginning of my talk in IIT Hyderabad's conference, to train the human resource who can make composites successful in the market. So I am doing my job. I think 2 or 3 of our students will be coming here and speaking on different topics related to composites. So my job is done, but if still they feel I can contribute, I am always available. There was yeah.
This one, you mentioned that some kind of thermoplastics and thermosets. So generally thermosets we are using for our space applications. I am audible?
The question is not very clear to me.
So what I am asking that how thermoplastics can be more usable for the space application.
Thermoplastics may not be very applicable in space applications, because thermoplastics, the melting temperature is lower as compared to the thermosets. Now in the morning I have made notes. You can meet me. I have made 3 things I have written down when Dr. Desai Saus was saying. I have made, normally when I try to remember something, I cut down into smaller pieces. I have made it RVT when I was not knowing that. Radiation, vacuum and temperature. So these are the 3 challenges. So thermoplastics will score lower marks as compared to thermosets when the high temperature applications will be there.
My supplementary is there that how effort can be made to make it more sustainable. Any effort is being made by our researchers so that this thermoplastic also can be one of the candidates for the future space applications.
Yes, that can be done. You can have different thermoplastics which can be, there can be 2 approaches. At the synthesis stage only, you develop a thermoplastic which can sustain more temperature. One. Second thing is you can add additives at a later stage during the processing to improve their thermal resistance. So both approaches can be tried, adding fillers during the processing stage or doing some modification in their chemical structure at the synthesis stage to improve the thermal resistance of the thermoplastics. That can be done. There can be a lot of efforts which can be done in this direction. I think I am able to understand your question and give you some insight into what can be done.
Something we are doing, but some more if can be done for the continuous fibers processing of this thing. The peak we are doing, peak is also part of the thermoplastic only, but some of the peak can be used. So, but in the fibrous form, they are going to use some kind of the processing listed down, like RTM and vacuum listed, all these things. That matrix system.
So fibers normally, you can discuss, but fibers normally, natural fibers, as I showed you, some fibers are available in the continuous form, but many of them are available in the short form only. So if you want to do this filament binding and other processes, you need to first create an ecosystem where you have someone who is manufacturing continuous fibers for you, which are natural in nature. So one of the fibers can be basalt fiber, which is a mineral-based fiber, but falls in the natural fiber category. We are talking about lignocellulosic fiber, which are coming from agricultural and forest waste. But there are mineral-based fibers, natural fibers, which are like basalt is one of them, which can easily replace glass fiber. Okay then, thank you very much.
Thank you, sir, for the giving the insightful deliberations on the sustainable development of the composite materials. Now I would like to invite Professor Hemant Chauhan, sir, from Ahmedabad University to facilitate, sir. Thank you, sir. Thank you once again. Moving ahead, it is my pleasure to introduce Dr. Hiral Parekh, Head of Research at the School of Engineering and Technology, Navrachna University, Vadodara. Dr. Parekh holds a PhD in Mechanical Engineering from Charuset University and ME in Machine Design from Birla Vishwakarma Mahavidyalaya, Sardar Patel University, and BE in Mechanical and Engineering from GH Patel College of Engineering, Sardar Patel University. Dr. Parekh research focus on fiber reinforced composite materials, composite manufacturing and tribology. She has amassed valuable experience through her work at various esteemed institutions. Among her professional achievements, Dr. Parekh has been an invited reviewer for reputed international journals and served as a newsletter editorial board member for the Composite Excellence Center of Asia in 2020. She was also honored with NUV SET Dean's Choice Award for the academic year 2015-2016. Today, Dr. Parekh will be delivering a talk on the role of universities in the growth of composites. This topic is crucial as it highlights the significant contributions and potential of academic institutions in advancing composite materials research and development. We welcome you, ma'am.
It's not working. Thank you, Dr. Sani. But there is a little bit glitch in that. The topic is I was asked to deliver a short presentation on the growth of the composite materials at Navrachna University. What we are doing at the Navrachna University, because Navrachna University is a very young university, and as a young university, we are doing to give up, to train the students, young minds in the field of composite materials. That is what is my topic is. And first, as I'm going to brief you about the Navrachna University, because Navrachna is partner for this. So first, let me start with the briefing of the Navrachna University. I'm going to take a few minutes for that. Navrachna University, that is started somewhere in 2012 with the Gujarat Private University Act, UGC, with the intent to offer the quality educations. And there are 5 schools that comprises of the Navrachna University: School of Business and Law, School of Environmental Design and Architecture, School of Engineering and Technology, School of Liberal Studies and Education, School of Science. So these are the 5 schools that comprises of Navrachna University, and we are offering 13 undergraduate programs, 8 PG programs, 2 integrated programs, and the 4 schools that are offering the PhD programs. Now, we believe in the choice-based learning, and that can be seen students at the Navrachna University. The students are learning the different courses under the 5 different pointers. The first one, it is mandatory discipline specific courses, where the students are getting an in-depth knowledge of their subject specific, which is mandatory for all the students of all the branches. Second, it is a university elective courses, where the students are having a flexibility to choose the subjects of their own choice. Just an example, if the mechanical engineering students, if he is willing to if he is willing to learn something on the basics of stock market, so he can able to take the subject which is offered by the School of Business and Law. Similarly, if the School of Architecture students, if he is willing to take the subjects, or if he is willing to learn something on the robotics, so he can able to take the course which is offered by the mechanical engineering program, right? So that is university elective baskets. In this semester we have offered around 120 subjects, and the students opportunity or the flexibility to choose the subjects of their own choice. The third one, it is minor discipline. So here the students are having an opportunity to select the minor discipline as a we are offering a minor disciplines, and they will get the certificate for this. Fourth one, it is a course project, which is again a mandatory subject for all the students, where the students are going to work on the social, when the students are going to work on the problem which is social relevance. So just in this, the faculty members, they are going to float the problems as social importance, and the students, interdisciplinary group of the students, they are going to work, and finally they will propose the solutions for this. And the fourth one, that is a university foundation program, in which we'll take care about the nurturing the basic foundation skills of the students. So reading and writing courses, the critical thinking, research skills, basic programming languages. So these are the subjects that is going to be covered under the university foundation. This will give the basic idea about the learning path of any students at the Navrashna University, and that believes, the Navrashna University philosophy that believes in the choice-based learning, that can be seen. Now coming back to this topic, that is a growth of the composite materials at the Navrashna University. So I would like to discuss here on the 4 pointers, that is the faculty profiles. Second one, we have included this composite materials in our curriculum. Third one, that is a current research work which is going on in the field of composite materials at the Navrashna. We have organizing a number of workshops and seminars to spread the awareness about the composite materials. And finally, the hands-on session, that what we are giving to the students, so that they will have they will have an idea about the manufacturing of the composite materials. So I feel first starting with the faculty profile at the Navrashna University. In the core engineering discipline, we are having 20% of the staff members, those who are having a research background in the field of composite, or either they are having a specialization in the field of composite materials. They are mainly working in the field of the natural fiber, metal matrix composites, and the designing of composites. So these are the major research profile of the faculty members. And the major research work which is going on by the faculty members, that is a first area, that is the sir just now he has said that the academia, they are normally working in the field of they will do the lots of testing in the field of composite. That is what we are also doing. The first part, it is in the natural fiber. We are creating the natural fiber, or the manufacturing the natural fiber by using a different types of the fibers. Maybe in the matrix, maybe in the fiber forms, or maybe in the yarn forms fibers, or the fabric form of the fibers. So we are manufacturing the different composite materials by using a layup technique or by using a VRTM processes. We have already created the number of the composite materials, hybrid composite materials. We have also tried by using a number of fillers in the resin materials, because we wanted to achieve certain properties. So we have tried with a number of fillers in the resin materials and created different kinds of FRP composite materials. We did the testing of that, and we have seen that whether we are getting the similar results that what we so that is one area where we are working. Second area, that is again on the natural fiber we are working, but here the application, it is a potential acoustic material. So this we have already tried by using the waste from the coil fiber and from the sugarcane fiber. So we have tried to develop the test coupon, which is highlighted here. The 2 test coupon which we have manufactured by using a hot press technique, and we have done the impedance tube testing on that to identify the acoustic coefficient for this, and we have got a very good results, very promising results we have got for this. And these results we have also compared with some commercially available acoustic material, fly sheets and the timber sheets. We have compared with that, and we can say that we are getting definitely a very direction also. And third direction that where we are working, that is creating a filament from the composite material itself, because that PLA filament, that is commercially available, right? But composite filaments, specifically by using a natural fibers as a fillers, so that is a very difficult to achieve that. And here in this area, now presently we are rigorously working on to create the filament by using the composite material, natural fiber as a filler. So if you could able to achieve this, then we can able to do the 3D printing by using this natural fiber reinforced composite material. We are working. We have already started working on this, but we are not getting a success in this direction. So we really looking for us in this direction to create the composite filament. Second, this is a faculty profile. The second one, it is a student curriculum, and in the student we have a very well defined student curriculum at the undergraduate and the postgraduate levels. So at the undergraduate level, we are offering this subject, composite as a tribo material, as an elective subjects. And the students are really, as we are having a choice-based curriculum, the students selecting the subject based upon their choice, but admission in this particular subject. So students are really liking this subject, composites as tribo material. And second, it is a post-graduation level. We are offering a thermal aspects of composite material, where we are covering a thermal aspects of the composite material. So this is how this subjects, it is already there in our curriculum. Third one, that is, we are also emphasizing on the hands-on session. That is very important, because it is something like, you are witnessing the birth of a totally new material. So the emphasizing on the the hands-on session. So this is a one project with the students they have carried out, and this time we have asked them to create a grading system which has a commercial value. We have asked them to create this grading system. So as academia, we were not aware of that, how exactly to create the mold and how to do the setup for this. So the went to the industry, those who are a manufacturer of this grading system, and the students, they have learned in that. The industry people, they were so kind that they have guided the students at what kind of the mold that they require, and from that they have created this. If I could able to on this video, chalega kya video? That's okay otherwise. So students, they have learn how to to do the manufacturing of this grating system by using a glass fiber and the epoxy resins. And after that, they have also learned in this. They have also learned that how to take it out the product from the mold, because that is also very critical part. So that is a hands-on session where they have learned about this removing the product from the mold part. And third, it is a secondary process is also very important. That is what they have learned in the third stage, right? So this is how the students are learning. The next, we are also taking a certain, we are also giving a certain projects, not only on the hands-on, not only on the hand layup technique, but also they are using a VRTM process to develop certain test coupons, because we are creating a number of natural fiber reinforced composite materials. So they are where we are using a VRTM process. So they are creating the test coupons by using this VRTM process. Few of the students, they have used a natural fiber and they have created the product which has the architectural point of view which has a value. So they have created the product something like this. So likewise, they are having a lots of hands-on sessions on the composite material. That's why they are liking the subjects more. So whatever they will learn in the theory part, they are correlating that things in the practical sessions, and they are creating. Apart from this, we have now started exploring the 3D printing of the material, and that is for that we have introduced one subject called as a solid modeling and 3D printing concept. So this we are offering as a university elective courses, and throughout the university, whoever the students are interested in this, they are taking up the subjects. So I would like to emphasize here, we have used a PLA filament, which is a commercially available PLA filament. The students, they have learned the designing of this by using a Creo software. They have done the designing of this, and then they have done layer wise, they have done how to do the slicing of the materials, and then they have 3D printed this part. The first, it is showing the Navrashna University model. The second one, it is a lab model, computer lab model, where they have very precisely chair, table, CPU, mouse, everything very precisely they have done the designing of this, and after that they have scaled down the model and then they have 3D printed this. Obviously the infill density is very less, so we could not able to get exact figure, but if we can improve the infill density, then definitely we can have a better idea of this. The next one, it is something like this. They have taken this designing of this key holders from the Amazon. Then they have took up this design in the in the software. They have modified the design. They are doing on the in the field of 3D printing. And this we are emphasizing 3D printing because presently they are doing these things with the help of a PLA filament. But we are in a process. We are rigorously working to create a biofilaments. So if you could able to achieve this, all these products which is done with the help of a PLA filament, we can able to use waste material, the filament manta, we can use that material and we can create this particular product. So that is what is our aim is to guide the students to make to guide the students in the 3D printing also. So this is the one aspect. The second aspect is to spread the awareness. We are also conducting a various seminars and the workshops. So we have conducted the seminars and the workshop in the field of Two, we have done in collaboration with Composite Excellence Center of Asia. We have also got a very grants from the fundings. We have got it from the Kuch Coast to organize these workshops and the seminar. So this is what we are doing at the Navrashna University. That is what I was asked to tell you, that what we are doing at the Navrashna. We are very young. Just 10 years back, we have started this program. So as being a very young university, what we are doing is spreading the awareness of the composite material. That is what I was asked to to tell to you. So that is what is from my side. So as academia, we are we are spreading the awareness with reference to the curriculum, research environment. But if we have a more collaborative work with the industries, if we have a more collaborations with the industry, we can definitely work in a proper directions. Likewise, we are, whatever work we are doing, it is simply giving a projects. That's what I am feeling is we are giving a projects to. But if the industry people can tell us that what exactly the need of the industry is, and if we work in that direction, I think that will be, that will have a more impact. So we are really looking for that kind of collaboration from the industries. Thank you. I think the sir has answered all the questions for the natural fiber, so so that we will have questions.
Thank you, madam. Now, I would like to invite Professor Vishwesh Badika, sir, to a statement, please. Okay, we will do it after a few minutes. So now I would like to invite, sir, please. So our next speaker is Professor Vishwesh Badika, sir. He is the Dean of Academic Affairs at Pandit Deen Dayal Energy University in Gandhinagar. Professor Badika has a distinguished academic and professional background, having earned his BE and PhD in Metallurgy Engineering from the Faculty of Technology and Engineering, along with an ME in Industrial Metallurgy from the MS University of Baroda. He also holds a diploma as an international welding engineer from the International Institute of Welding, France. Professor Badika is affiliated with several prestigious organizations, including the Indian Institute of Welding, the Indian Society of Non-Destructive Testing, and the Materials Research Society of India. Among others, his expertise extends to welding and metallurgy engineering, and he has received numerous awards for his contribution to these fields. Some of his notable achievements include the Dr. Vikram Sarabhai Award for friction stir welding of aluminium and its alloys from Guj Coast, and the Broad Outlook Learner Teacher Award for his environmental efforts. He has also been recognized for his innovative work with patents related to welding technology and has received several prestigious awards for his research papers. Today, Sir will be delivering a talk on the role of PE in growth and development of the energy sector. So this discussion will shed light on how the petroleum, design, and process engineering sector contributes to the advancement and sustainability of energy resources. So we welcome you, sir. Thank you.
So, good morning, everyone, and thank you very much for giving this opportunity to share some of the development in the area of composite material, followed by some of the initiatives that the university has taken in the area of energy domain. So moving further, into that, so this is the introductory slides wherein we are getting the opportunity through the formal collaboration with the Composite Center of Excellence. Where, I don't know how it is going. Yeah. So to begin with this talk, I would like to acknowledge the support that we have received after signing the formal collaborations with the ATIRA and the Composite Center of Excellence. So we had a formal MOU last year in the month of September with the ATIRA. And as a part of this MOU this year, during the summer internship, the 5 students of university, they got the opportunity to spend around 2 months with ATIRA for the summer internship. They will be presenting their work as a part of this Young Professional Composites. So that is scheduled tomorrow. So during that part, they will present this work. Moving further, we also had MOU with the Composite Center of Excellence this year only in the month of May, wherein Dr. R.K. Singh visited PDU, and we had a formal MOU with our Vice Chancellor, the school director, and other deans and the faculty members. So our interest is in the area of metal matrix composite. So we have a very good system which has been developed there, which mainly makes the metal matrix composite, especially for the low melting point materials called aluminum, magnesium. And you can develop various kind of metal matrix composites, not only the single reinforcement, but you can do dual reinforcement also, which is termed as a hybrid metal matrix composite. So in this, there is a process called, there are different processes you can see here. There is a stir casting we have, the vacuum die casting we have a rotary casting also we have. So there are different modules are there in the system. And depending on the requirement, you can develop various metal matrix composites, and you can add reinforcement. And these reinforcement, you can ensure very good mixing with the help of ultrasound, which can be applied during the system. So you can see here that these are the various systems wherein you can develop various metal matrix composite with the various processes, and with the different processes, the different parameters also. Now moving further, you see there is a schematic diagram which talks about various parameters which you can control during the process. And like a standard casting process. So there are various parameters, there are various nomenclatures which are mentioned. I'm not going into the detail, but you can see this is a bottom boring type mechanism which has been shown here. So you can make a casting of the order of 2 kg metal matrix composite with the help of this system, and followed by ultrasonic cleaning, ultrasonic stirrer also. And this you can see the actual system which is available at the university. And if you see that there are different modules which has been casted on the right side, if you can see, you can cast plate also, you can cast rod also, you can cast tabular sections also. And these are the sections which has been shown. The most important element about this system is that you can do ultrasound during the manufacturing, and which will help you to have a better reinforcement distribution during the process. Now, there is another technique which is also there, that was a melt route wherein you can develop a metal matrix composite, followed by there is another technique wherein, without melting the metal also you can develop the metal matrix composite. So this metal matrix technique, which is called a friction stir processing route, wherein you can see that there is a plate here, which you can see there are certain pattern, or you can see the blind holes which has been created here, you can see here. And those holes can be filled with some kind of reinforcement depending on your requirement, especially for the soft material like aluminum, magnesium, or to a certain extent other non-ferrous also, wherein you can fill those cavities with the reinforcement, followed by mixing of that reinforcement with the various tools, which is called friction stir processing tools, where in first case you close the cavity with the help of the tool, wherein you can see there is no pin. You can see there are 2 different tools are there. One tool wherein you can see there is no pin, while the other tool where there is a pin. So you first close the channel with the help of the pinless tool, followed by a tool which has a pin, and then these particles will be stirred and mixed in the matrix of the material. So there is a process which is called a solid state way of creating a metal matrix composite. So this is also possible along with the melt route technique. These are other two techniques wherein you can make a sandwich pattern also. Between the two plates you can put the reinforcement and you can do processing and you can develop that composite. And one wherein you can apply directly with the surface coating method. So these are the 4 different techniques which are currently under research by various researchers for fabricating the metal matrix composite at research level. Now, because we have a limited time, so I'm not giving you much detail. There is another system because after developing a metal matrix composite, there is a need to characterize those composites, especially the tribological property at the room temperature, at the high temperature. So there is a system called tribology system, and this system will help you to characterize the wear behavior of those metal matrix composites with the help of under the dry condition, under the wet condition, and if you want to study the behavior of those metal matrix composite at high temperature, then also it is possible. So this is another system which is available, especially for 3 different modes. Now, you can see that university has taken various initiatives in the area of skill development in order to support Viksit Bharat 2047. So here you can see there is a metal 3D printing facility which is available on our campus, which was initiated by our Honorable Director General Professor Sundar Manoharan. So after his joining the university, this facility was installed. By now this facility is about 3 to 4 year old, and we are imparting a skill program to all the students across the Gujarat region, including university students as well as the students of nearby institution, wherein the metal 3D program is there. I'm sure many of them have talked about 3D printing, but along with the 3D printing, the metal 3D printing is also very, very important. You can see here that our Honorable Director General is interacting with our President, Dr. Mukesh Ambani. He visited our university in the month of January, and he looked at the facility, what kind of the product that we are manufacturing. And by now, university has trained close to 250 students in the area of metal 3D printing. And this will go in a long way. And this 250 numbers is in-house number of students. At the same time, very recently, about close to 20 students of GTU affiliated institution during the summer training was offered to those 20 students. 2 weeks of summer training was offered as a part of the curriculum requirement. So this is what a metal 3D printing facility that we have, and you can print variety of metal powder. So this is what is the required. So this metal 3D printing has variety of applications, not only in the, say for example, energy sector. Along with the energy, it has wide variety of applications. Say for example, you can use for biomedical implants also, say the titanium related printing, stainless steel printing, inconel printing, aluminum printing for aerospace, biomedical. So there are various applications. I'm not going into the detail of those applications, but here this facility is available, and every weekend we are conducting such programs for the students with the very nominal fees from them, so that they get the new skill set, which is the demand of our current government, like say Make in India, Skill India, Digital India, and to support Viksit Bharat 2047. We were also part of this 2023 event wherein Dr. R.K. Singh, they conducted the program, and we got opportunity to work with them, and that leads to the formal MOU with them this year only. In addition to that, with the reference of sir only, we got Naresh Chandra Sharma sir on our campus, wherein he delivered a talk about the career in aerospace and defense composites applications in manufacturing. So close to 120 students attended that particular talk at PDU, and it was a wonderful interaction with Professor Chandra, and we had interaction with our school director and the deans and the head of department, and that is it. Now, moving further into that, in order to promote the composite amongst the students and the industry, we also had, under the direction of R.K. Singh sir, we had composite industry delegates. They visited on 24th of May, and we had an interaction on metal matrix composite facility, which you can see in the background, and they also visited metal 3D printing facility and polymer matrix composite facility as well. Now I request please click on this video so that it will start. Volume is in your control probably.
पीडीपीयू देश ही नहीं बल्कि विश्व में भी अपनी एक जगह बना रहा है, अपनी एक पहचान दर्ज करा रहा है। और मुझे ये देखकर बहुत गर्व होता है कि यूनिवर्सिटी अपने समय से बहुत आगे चल रही है। बीते 1.5 दशक में पीडीपीयू ने पेट्रोलियम सेक्टर के साथ साथ पूरे एनर्जी स्पेक्ट्रम और अन्य क्षेत्रों में भी अपना विस्तार किया है। लेकिन अब जिस प्रकार से देश और दुनिया की रिक्वायरमेंट है, जिस प्रकार से इस यूनिवर्सिटी ने अपना रूप लिया है, मैं गुजरात सरकार से आग्रह करूंगा कि कानून में अगर आवश्यक हो तो परिवर्तन करके इसको सिर्फ पेट्रोलियम यूनिवर्सिटी के बजाय अच्छा होगा अब इसको हम एक एनर्जी यूनिवर्सिटी के रूप में कन्वर्ट करें, क्योंकि उसका रूप दायरा बहुत विस्तार होने वाला है। और आप लोगों ने इतने कम समय में जो कमाया है, जो देश को दिया है, शायद एनर्जी यूनिवर्सिटी इसका विस्तार बहुत बड़ा लाभकर्ता देश को हो।
Next. Yeah, with this, I've come to an end of the talk. Thank you everyone for giving this opportunity to share some of the thoughts of the university.
Thank you, sir, for sharing about Pandit Deen Dayal Energy University and their initiatives. Now I would like to welcome R.K. Singh, sir, to felicitate Radhika, sir, please. I request Parik ma'am, please, you should also. Thank you, sir. Now there will be 3 presentations from different university and academy, that is from the industry side. Now, first I would like to call upon Professor Milind Joshipura's Head Chemical Engineering Department from Nirma University. Sorry, Mamta ma'am is there, so please request you ma'am to please come.
presentation is not. हाँ डाला है मिस्टर राहुल है ना उन्होंने डाला मिस्टर राहुल ने डाला हाँ
So I think ma'am will be taking it after 10-15 minutes. Now I would like to invite another speaker. There will be a presentation by Dr. Harini Parekh ma'am, IIT Gandhinagar from the Mechanical Engineering.
Thank you. I'm Harini Subramanian from IIT Gandhinagar. It's a pleasure to be with all of you here today. I work in the Department of Mechanical Engineering at IIT Gandhinagar. And thanks for staying back in spite running a little bit late. I really appreciate all of you being here. And I'll take 10 minutes of your time and use this opportunity to briefly talk about the work that we are doing at IIT Gandhinagar, research-wise, in the area of composites. So I kindly request for the presentation to be put up on screen. So, yeah. Thank you. So, as you all know, IIT Gandhinagar is a second generation IIT and it was started somewhere around 2008. We've been building up slowly but steadily. And we have close to, I believe, 120 faculty members right now. And I would like to introduce some of them who I'm representing today, who are working broadly in the area of composites. So I'm from mechanical engineering, and there are about 10 to 12 faculty in IIT Gandhinagar who are working on different aspects of problems when it comes to research in composites. The reason why I'm bringing them to your notice today is there could be a possible collaboration at some point of time, depending on their area of research interest and your requirements. So the first slide is about the research that I'm currently doing in my lab at IIT Gandhinagar. I predominantly work in the area of modeling the mechanical response of materials with a specific focus on fiber reinforced composites. Some of the questions that we try to answer is how to improvise the progressive damage models that we have for composites, how to capture the progressive failure that happens in composites, how can we innovate with respect to the failure criteria, and also looking at certain exotic materials like self-healing materials. So We are also interested in understanding the ways of predicting the mechanical response of composites, especially when it comes to their properties. This is known as micromechanics, where we try to look at how can we effectively estimate the properties of a composite and compare it with the experimental observations. Apart from that, some of the questions that we are also answering include how to look at the crack propagation in composites, because as you all very well know, unlike metals, composites are orthotropic materials, especially when we are looking at fiber reinforced composites where the fibers are continuous. Then one of the challenging questions is the orientation of the fiber is going to affect the crack, and it is going to deflect the crack in a way such that it runs parallel to the fiber. So if somebody is working on modeling of composites, maybe you will be able to get what I'm saying at the moment. So this is a pretty important question to answer when it comes to studying fracture in composites. So these are some of the problems that we are currently working on. Our interest is in how do composites respond at extremely high temperatures, and how do extremely high temperatures affect the crack propagation within an orthotropic material. Apart from that, we are also interested in answering questions like how does the curing method affect the residual stresses within the composite? Just 2 days ago, I got a calendar from the institute because we started a new academic year, and today morning when I saw what it was yesterday is not what it is today. It has slightly folded. The reason, because this calendar, whatever paper it's made of, whatever the AC moisture is in my room, it has absorbed that AC moisture and it has basically deformed. When I looked at it, I realized that is exactly what's happening when it comes to a composite, because when the composite is undergoing curing, there is formation of these polymer chains, and there is a certain autoclave process temperature and pressure that we apply. So these parameters really affect the end product that we get. So we are interested in understanding that. Apart from this, we are also interested in answering questions like, do composites really exhibit inelastic response? Inelastic in the sense, considering the viscoelastic nature of polymers, the plasticity response that can happen when the response is matrix dominated. So can these really affect the final failure behavior of the composite? So I'll be talking over the next couple of slides about my colleagues. I'm very happy to bring their work to your attention over here. Who we have on slide is Professor Raghavan Ranganathan. He is working in the Department of Material Science and Engineering. He is interested in understanding the mechanics of composites at slightly lower length scales. Professor Raghavan works in molecular dynamics and atomistic scale simulations, where they are interested in looking at optimization of material properties using data-driven approaches. They're also looking at how to draw a correlation between the structure and the properties of the composite. So one of the recent works that they did was taking inspiration from Nactar and Dactyl. They modeled the response at the molecular scale, and they have also answered questions as to what would happen when the composite is being tested at really high deformation rates, how the shock deformation of the composite would look like. And he is closely working with ISRO and also with ARDB. So his work finds application in those domains. If anybody is interested in his work, I would kindly request you to contact him on the email ID given over here. Next, we have over here Professor Kabir Jasuja. Kabir works in the Department of Chemical Engineering. He's an experimentalist. Kabir's research group has recently developed nano sheets. His expertise is in nano sheets, and they have made these using boron. Now, the advantage of these nano sheets is that they're finding potential applications for utilizing in bulletproof jackets. So he's collaborating with an industry for fabrication of bulletproof jackets using these nano sheets because they have improved mechanical properties. These nano sheets developed are also used in other functional composites. For example, they're used in biosensors, energy storage, that is hydrogen storage, and also in flame retardant applications. So if somebody would like to contact Kabir, you have the email ID over there. Who we have over here is Professor Shiva Teja Choparla. He is in the Department of Civil Engineering. Shiva works in the area of sustainable concrete and improvement of concrete performance. He is greatly exploring the use of cellulose and industrial byproducts in these concretes, development of recyclable concretes, and he's also an experimentalist. The kind of questions that they are trying to answer are how to improve its durability and also its long-term performance. He's a new joinee at the institute, and if anybody would like to contact him, here is his email ID. We have Professor Ravi in the Department of Mechanical Engineering. Professor Ravi also works in the area of mechanical modeling of ceramic matrix composites and foams. His work largely deals with high deformation rate response. So currently he's collaborating with R&D Pune, where they are interested in understanding the response of foams and how to come up with better constitutive models that can predict their response at high strain rates, and how can we improve the failure initiation prediction when it comes to these materials. So he works broadly on solid foams as well as on the response of brittle materials. Especially the question is, at dynamic strain rates, how would the crack growth happen in brittle materials? And also looking at ductile materials in the aspect of void nucleation, growth, coalescence, so on and so forth. And Professor Ravi, through the Institute's support, has recently procured an XCT setup. Now this comes with an in-situ testing facility, which has given the opportunity for us to answer more interesting scientific questions. For example, to look at the crack initiation and propagation in foams as well as in ceramic matrix composites at very low length scales. And we are also interested in exploring the possibility of healing in polymers, and we're planning to do that using the XCT setup. So if anyone is interested in contacting Professor Ravi, we have his contact detail over here. Finally, I have on slide Dr. Sri Harita. Sri Harita works in the Department of Materials Engineering. She's a tribologist. So she's interested in working on development of ceramic matrix composites as well as in surface engineering, development of hydrophobic surfaces, how to reduce the wetting, and also how to improve the performance of ceramic matrix composites. I wouldn't be doing enough justice to any of their research work, but at least I'm happy that I'm bringing some attention to what they do. So I hope if you're interested, please contact her. She's also working in collaboration with ISRO, and she's also working in the area of surface texturing. One of the most important reasons why I'm here today is to talk to you all about a baby project that we've been working on for quite a few months right now. IIT Gandhinagar has been curating an e-masters program in composites. Our major audience of interest would be industry experts who have joined into the industry way in the beginning of their career, who would probably like to scale up with respect to certain areas in composites. So this program has been curated with certain industry relevant and currently relevant courses. We, of course, have also ensured that the rigor of the program is not compromised. We will have courses on design and analysis of composite structures, testing and design validation of composite materials, advanced composite analysis, especially impact crashworthiness, quality assurance and inspection, tool design for composites, and we are planning to have industry relevant projects. The idea of bringing this to your attention is because you could spread the word of mouth. And we are also looping in experts from outside the country as well as from the country who are in the industry, who work day in and day out with composites. Especially a course on process modeling in composites will be probably offered by somebody from R&D, because their everyday bread and butter involves process modeling of composites. So we have tried our best to ensure that the courses are being taught by experts who deal with the subject on an everyday basis. So the admissions are going to be open very soon, probably in a week or so. And we are expecting the first cohort to begin in January 2025. So if you have any questions regarding this, I'd be more than happy to answer it off stage. With that, I would like to wrap up the presentation. Do make a visit. I know it's an hour away from here, but it's an equally beautiful campus. And we would be more than happy to host anyone from here when it comes to possible collaborations or any kind of discussion in the area of composites. Thank you so much for the opportunity.
Thank you, ma'am. Now I would like to invite Parik ma'am to greet ma'am. Ma'am, please. Thank you. Thank you. Madam. In continuation, I would like to invite Mamta ma'am, please.
क्या हुआ? Just picture. It will be visible here, no? Yes. Yeah. Good afternoon, everyone. Myself, Dr. Mamta Sayyed. I am Associate Professor at Nirma University at Chemical Engineering Department. Initially, this presentation was supposed to be done by Dr. Milind Joshipura. He is our head of the department at Chemical Engineering Department. But as he had some work, so he has to go back. So now I am presenting it. I will give some brief about the university, some activities carried out at university, and especially the composite work, the research work which is carried out at industry. Then I will give some brief idea about it. Oh, this side. यही है ना? ओके. हाँ, वो मैं यहाँ पर, मुझे ये देखना है ऐसा है, ऐसा. But let me see. Yeah, now society is well aware about the Nirma University. It is established by Padma Shri Dr. Karsanbhai Patel, and it was in year 1995, and it has got the university at 2003. So almost Nirma University is now being completing 30 years in next. In this year, it is 29 years they have completed. The university is accredited by A+, NAC A+ grade, and it is awarded Center of Excellence by Government of Gujarat. And these are the different institutes which are established under the umbrella of Nirma University. That is technology, management, pharmacy, science, law, architecture and planning, commerce, and now lately it is Design Institute also, it is started. Where I should do this? Okay, okay. Okay. These are the intake in the different institute. Yeah, I can see here. These are some achievements and recognition Nirma University and Institute of Technology had got. That is, all BTech programs are accredited by NBA, It is ranked fourth in the top 50 private state university in India in 2022. It is ranked fourth across the India, across the GHRDC Ready Reckoner of top engineering. It is ranked top 20 private institute by India Today under best colleges in India in year 20. It is active collaboration with foreign universities such as USC, SUNY, ASU, Iowa State University, Carleton University, etc. And it has equally, green campus as Ahmedabad University. We have collaboration with industry. Some of them are Tata Motors, Co-Federation of Indian Industry, that is CII, JK Lakshmi Cement, Mitsubishi Electric India Private Limited, Building Energy Efficiency Project, that is B, Infosys Technologies Bangalore, Sika of course, Inspiration Engineering Private Limited, L&T Construction, Milacron India Private Limited, Robert Bosch Engineering Company and Business Solutions Private Limited. These are the few names. We have academic collaborations with some of the foreign universities like ITER France, INS Valsura, SUNY Bingham University, Florida Atlantic University, that is FAU, University of Southern California, Carleton University, Canada, Iowa State University, USA, University of Victoria, Canada, University of Dundee, UK, Arizona State University, USA, Curtin University, Australia. We have collaborations with some research organizations, that is Central Salt and Marine Chemical Research Institute, that is CSMCRI Bhavnagar, CSIR Advanced Material and Process Institute AMPRI, Sardar Patel Renewable Energy Research Institute, Central Building Research Institute Roorkee, Indian Space Research Organization, that is ISRO, then Institute of Plasma Research IPR, ATIRA Ahmedabad, CSIR Pune, and Bureau of Indian Standards, that is BIS. At Nirma University, in our department, we actually do not have a special program on. Yes? आप मुझे कुछ कह रहे हैं? Okay, sorry. So, actually we don't have that specific program on composite at Nirma University, but our civil, mechanical and chemical engineering programs are very well, working on composite materials. However, civil engineering has started with some subjects and they have introduced some subject on open elective subject of composite materials, which is, by civil engineering department for final year students. And this can be, opted by civil, mechanical and chemical engineering and other branches of students. So civil engineering department has introduced some, courses for the benefit of mainly for the civil engineering students by covering the following aspects, that are the maintenance and rehabilitation of structures, testing of geotextiles for infrastructure applications, and for PG students it is structural evaluation and strengthening. So these are the subjects which civil engineering department at their UG and PG level has introduced, and at UG level the subjects can be taken by other branches also. Now I will give some brief idea about the ongoing research project at Nirma University by different branches. Some of them are the process development for minimization of spring back deformation and enhancement of profile accuracy of CFRP reflectors. Here the values of process variables with respect to mold material, curing cycle layup, sequence and the laminate thickness that results in minimum spring-back deformation, and development of methodology for simulation of autoclave curing process using matrix characterization by using FE methods is carried out. The investigations on 3D printing of CFRP using plastic waste. This is done at Mechanical Engineering Department. The composite beam column, this research work is going on at Civil Engineering Department. That is the constituent material, which basic material used is a tube material, and infilled is a concrete material. So the tube material could be of steel or FRP, and it can be composite with the concrete. And the tests which are normally done on it is tensile test, compression, and flexural testing. So that and the test on composite beam column are done by using monotonic axial compression test and monotonic axial flexural test. These can be used at high-rise building and bridges. The another work carried out at Civil Engineering Department is geocomposite, which typically consists of a combination of two or more geosynthetic material like geotextile and geomembranes, geogrids or geonets used in various civil engineering applications, and that is how the geocomposite material is developed, which can be used in a drainage, filtration, and so on. The raw material used are the polypropylene, polyethylene, polyester, etc. And the application of this geocomposite material can be used in the drainage system, erosion control, landfill liners and caps, gas venting, waterproofing embankments, retaining walls, and so on. The development of GFRP hybrid rep is carried out at Nirma University. The application of this hybrid rep for structural strengthening of RC and precast elements, where the flexural and shear strength of RC beams are checked. Behavior of beam column junction under the monotonic and cyclic load is also checked, and that is how the development of GFRP SSWM hybrid is developed. These are the few images of development process. We also have a patent on polymer composite, that is the radiation hardened epoxy graphite polymer composite. This is from the Chemical Engineering Department. I am happy to say that is mine. This material is specifically used for space application, and along with it can also be used in defense, nuclear plants, and applications where the high frequency cosmic rays are present. We are also now working on the flexible resin material, and a few more polymer composite projects are also going on in our chemical engineering laboratory. The another is nickel coated carbon fiber, and that is also a research project funded by the industry. Nowadays, the manhole covers are being replaced by the FRP and FRP composite covers, and to design and develop and check the strength, we are working on this material. We are working on this project, and this is also industry funded project. So we are working on manhole FRP manhole covers. These are the research project now civil engineering has undertaken. This is the list of it. These are few publications, and you can refer this publication further for know more about the research work going at our institute. These are the publications.
I would like to add something here that we have also done the MOU with SICA. And with SICA, we are, the objective behind it is to collaborate with industry and to train the people, experts, as well as the skill manpower, and to get some, industrial problems, industrial research problems from the industry. So I here request all the industry to consider Nirma University as a, knowledge partner again, not only for the conference, for the, fraternity, that we are there for training and research problems, industrial research problem, and which we can do the collaboration, or we can, by each other the mutual understanding, we can carry out such problems. So that is how, with this, I will end my presentation, and I can, if anyone has any question, please. Thank you. Thank you so much.
Thank you, ma'am. Now I would like to request Badika sir to greet ma'am. So our next presentation is from Mr. Tejas Mehta, sir, from ASM International. Please, sir.
ओके इसमें है मेरे पास, इसको लोड कर दिए, लोडिंग अप, ये है ना, ये देखने की जरूरत, ठीक है। सर्च करें, जी जी जी, बिल्कुल बिल्कुल, हाँ हाँ बिल्कुल, वहाँ से करना है, नहीं हो गया सर, ठीक है, ओके, यस यस, परफेक्ट। Okay, good afternoon, everyone. Well, on behalf of ASM Gujarat chapter, I would like to first congratulate Mr. R.K. Singh sir and CESA team for arranging this wonderful workshop and conference with the exhibition on the composites. I think this is a wonderful opportunity, and we as a ASM Gujarat chapter, we are very proud to be partner of this event. I think we should collaborate, we should innovate, we should come together and foster the innovation and the growth opportunity within our industry. So, as I am here to give you a little presentation about the ASM International Gujarat chapter, what we do and who we are, I would like to go through the introduction about that. Well, ASM International, that is the main society, or the world's largest society, to disseminate the information about the materials, processes, the advancement, the technological advancement in the various sectors. And earlier, when it was founded in 1913, then the focus was only the metals. But as the technologies advanced and the things became more broader, now the focus is on all kind of material, and ASM provides all kind of materials, information, technical handbooks, various types of journals. They arrange national, international conferences, and many other things which can give the reliable, trusted information to all the researcher, all the industry professionals, all the universities, students, etc. So what you see here, the picture, which is a very beautiful picture of ASM Material Park, which is located right in Cleveland, Ohio, about 20 miles east of Ohio in Cleveland. Basically, it is a dome made out of aluminum extruded pipes. And this is one of the source of inspiration because there is a beautiful campus out there which has about 3 millions worth of equipments, testing facility, arranged inside that beautiful office. And lots of different programs are arranged to provide this material information to various industry and the researcher people. We are very fortunate to have 6 different chapters here in India. One of them is right here in Gujarat. We are rightly present here in Ahmedabad. And as we go through the next slide, I would like to mention one important thing that since last year, we are very fortunate to have a leader, Mr. Pradeep Goyal, who is heading the ASM USA as a president. And after him, Mr. Naveen is going to be a successor in this current year. So come this September, Mr. Naveen is going to head the ASM USA. And it is absolutely a great pleasure to have such a wonderful presence of Indian people in the ASM community at the USA headquarters. So this couple of years, we are very fortunate to have something voice up our Indian community's demand to various presentation, and we can get some more work done for the betterment of the overall growth of the industry, overall growth of the researcher community and the students. Let's talk about the membership benefits. As you can see here, there are tons of benefits. First of all, the foremost is a huge pool of trusted scientific information which is verified, which is proven, and which is available through the trusted source. So you can rely on this. You can have a full trust in this information. Because nowadays people go onto Google and YouTube and get the things done, but there are more information, more trusted information are available right here. We have a global expert of more than 15,000 people across the worldwide, and you can connect to them with the ASM Connect portal. Once you become a member, you are able to approach them directly, which is a very wonderful thing. You can have one-to-one dialogue with them. You can get guidance. You can get one-on-one session and get a great interaction with them. Also, there is a wonderful magazine which is published every month, Advanced Material and Processes, which is available in the email. You can go through the digital copy, and whatever research, whatever specialized research industry or any other students are doing, they get opportunity to get recognized and get reputation in the ASM headquarters. So that's a wonderful opportunity also. When we talk about some things like they provide different type of webinars, digital handbooks, also other softwares which are available on the website. The online resource is so powerful that you get so many different type of stuff in there, and daily basis the new stuff's getting uploaded, and you get to know the latest and greatest trends in the industry, whether it is a composites, whether it is something else, whether it is forging, casting, anything. You name it, and they have all kind of stuff available. So I think with this online platform, there is a wonderful opportunity to become a member of this ASM, and you get to access such a great thing through this. There is a voluntary opportunity. There are various committees which are formed at the headquarter level, and in that, depending upon your profile, you get to nominated in these different committees and contribute based to your knowledge, based to your information, and help the other fraternity in your best way. Some of the past event which I would like to showcase to you. This is one of the event which we did a few years ago, Lesser Additive Manufacturing. When I talk about Gujarat chapter, one unique thing I would like to inform you that whenever we do any seminar or lecture, we usually try to make it more interactive in a sense that we do the practical workshop. So there is a practical aspect also involved, hands-on training is also involved, and there is a live demo of the product or the process, which brings more interactive collaboration between the research participants. And so far, all the participants have wonderfully appreciated that having just a plain seminar and having a practical workshop, which is way more fruitful for the collaborative efforts. Let's go further. These are some more pictures about those events. Here, as you can see, the picture of one of the professor, Dr. Chris Bunt, who is the guru of the thermal spray. Thermal spray is one of the very important process in improving the surface of the materials. And in that particular segment, Mr. Chris Bunt is renowned to be the guru of that technology. So he visited us like 3-4 times till now, and every time we set up a workshop in his presence, there is a wonderful response we get from the industry as well as from the researcher. Next, if we go further, there is another gentleman, renowned world famous metallurgist, Dr. George Vanderwood. We had a session with him about few years ago. More than 55 participants attended that. That was right here in Ahmedabad, and right across the street in the LD Engineering College. Our office is set up right there, and this was another most appreciated seminar we had, along with some live demo. We had done similar work for the composite industry. This was very recent. As you can see, it is a workshop on the advancement in the pultrusion technology. Dr. Fausto Tusi, he came from the Italy, and he gave a wonderful presentation, as well as we had a pultrusion demo right here in Atera, and that was a collaborative effort between the CESA, SSME, Atira, and it was a joint effort. I think we had about 80 participants, as you can see here. Similarly, we had, in loving memory of Dr. APJ Abdul Kalam, he had done one Materials Day celebration few years ago. In that, we had Dr. Nilesh Desai as our chief guest, who was here in the first session with us. He gave a very inspirational talk about the latest and greatest development in the ISRO SEC activity. So we had a wonderful session with him. Going forward, the online resource which I was talking to you. As you can see, there are various handbooks available, and if you just search a word, let's say composites, in the ASM International website, you get to see more than 1,200 types of resource available to educate you, to train you, to give you the information. And some of the things are listed here. As you can see, the ASM handbook, volume 20, that is the material selection and design. ASM volume number 21, that is on composites. This is just a few of them. There are also webinars, some videos which are freely available for your education purpose. And just yesterday, one wonderful email came from the ASM headquarters, and I'm happy to share it with you, that whatever resource they provide online, whether it's a paid workshop or the paid, paid digest or the ebook or the on-demand video, they have offered 50% discount in that when you become a member. So I think it is a great opportunity. I think when you become a member, you should take advantage of this. Going further, as I mentioned, there are 6 regional chambers in India. To name them, Mumbai is one of the first one, the pioneer one. They started in Mumbai. Earlier it used to known as a India chapter, but now it's a regional chapter. That's why it is called Mumbai chapter. Chennai chapter, Bangalore, Gujarat chapter, Pune, and Salem. Salem is the latest one and the new chapter. All across these chapters, there are more than 700 members. And when we talk about the strength of the overall ASM across the world, it is more than 30,000. Our Gujarat chapter has an executive committee member. It's a very small team, but very powerful and very active team. Mr. Ragesh Bhattiriwala, who was here present earlier, he is our mentor and a past chairman. Dr. Neeraj Jamnapara, he is our past chairman and he is a fellow ASM. Mr. Nishant Shah, he is our chairman. Myself, Tejas Mehta. Ms. Bijal Parmar, Dr. Pramod Bingale, he is present here. I would like to request him to just stand up on your place so people will know. And Mr. Gaurav Avasthi, who is our secretary. And we have few other members who are very active in their field. They are working together to, help our fraternity here in the industry for their betterment. Some upcoming events we have in India, I would like to just list them. And the 5th edition of Materials Engineering and Technology and the 15th edition of Heat Treatment Show that is coming up next month in Mumbai. I think whoever has an opportunity to visit Mumbai next month must visit this wonderful exhibition and the conference. There are going to be several foreign delegates, more than 100 speakers are going to take part of in that. And in that, there are various MNC companies take part, as well as there are various technical sessions, wonderful exhibition, and also there is an opportunity to collaborate many of them. So in that exhibition, you can go onto the website, make registration, and this year the focus is on medical materials and devices, also the defense, automotive, and some other industries having a good presence in this. So you can visit the website and see for yourself this wonderful exhibition taking place. There is an opportunity to advertise your products. There is an opportunity to synergize your things with other industries. And one of the other seminar which we have upcoming here in Gujarat, that is on September the 19th, that is the application of AI. AI is the buzzword and people like to know about AI application a lot. So we are inviting Dr. Mikhail from Germany, who is going to talk on the AI application in the corrosion protection. So when you become a member or if you are a non-member, you are more than welcome to attend this session. And that is going to happen right here in Ahmedabad. I think as he is coming all the way from Germany, you should make a plan to attend this seminar and take the best benefit of it. With this, I would like to thank you everyone for the time and efforts. And if you would like to become a member, here is the QR code. You can scan it. You can just take a snap and download the membership form. The membership is very affordable, even for a micro company. And being a giant company, you can definitely come with us, join with us, and we'll be more than happy to help you in your work to do things better. Thanks a lot. Thank you so much.
Thank you, sir. Now I would like to request Badika sir again. Sir, can you please? Thank you. Now we'll be breaking for a 1 hour lunch, and again we'll be assembling here at around 3 p.m. So thank you once again. Yeah, just hold on please, one announcement.
Everyone is requested to collect the coupon from the registration desk. Right opposite to this building, we have a university center. So the lunch is in the room number 107 and 110, first floor. Please.
तीन बजे कर देंगे, हम ऑलरेडी करीब लेट चल रहे हैं.
Okay, sure. Done.
How are you?
ये भी अवेलेबल वाला है।
अरे मैंने भी निकाला ना। चलो ठीक है, ये चल रहा है ना।
पूरा पावर अप करके करना है क्या?
नहीं, मेरे को नहीं करना किया। फिर उसके बाद स्विचिंग करके देखूंगा, आ गया तो बेटर है ना।
अभी 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 ठीक है, वहाँ से ही करेंगे।
तो वही जो वो चल रही है उसको चलवा दें। वो दिक्कत नहीं आ रही तो अलग से। अभी जूम का रिकॉर्डिंग स्टॉप करो ना, बुलाओ उनको, स्वैप को बुलाओ। यहाँ से वीडियो बंद किया।
ठीक है ना, भले
अभी मेरा लैपटॉप देखो, इतना ज़्यादा चीज़ बंद हुआ, डिकोडर चालू नहीं है बस। ब्लैक वाला केबल आया क्या, लाइन वाला? कहाँ है? हाँ, बड़ा वाला काला वाला किधर के लिए? अरे वो लैन केबल।
केबल
What is energy? Aristotle portrays energy as the actuality of a potential. potentiality, volatility, uncertainty, complexity, ambiguity. In this VUCA world, we are players brimming with untapped potential. But with a little push, we can become kinetic, setting our dreams in motion. Education, research, and innovation turn potential into actuality, and goals into a reality. In 2007, Gujarat was emerging as the industrial hub and developmental epicenter of the nation. Aiding this change, the then Chief Minister Shri Narendra Modi envisioned an extraordinary institute that India needed, where passionate researchers and innovators from across the nation collaborated to contribute and complement industrial growth in the petroleum sector. Thus, we came into existence, Pandit Deen Dayal Petroleum University. But since the first law of thermodynamics states that energy transforms from one form to another, we transform too. About a decade ago, we set up a solar plant that produces 1 megawatt of energy and inspired Gujarat as well as India to think about solar energy at a massive scale. These were the seeds sown that resulted in a bloom of specialization in other renewables. And then this happened.
बीते 1.5 दशक पीडीपीयू ने पेट्रोलियम सेक्टर के साथ साथ पूरे एनर्जी स्पेक्ट्रम और अन्य क्षेत्रों में भी अपना विस्तार किया। लेकिन अब जिस प्रकार से देश और दुनिया की रिक्वायरमेंट है, जिस प्रकार से इस यूनिवर्सिटी ने अपना रूप लिया, मैं गुजरात सरकार से आग्रह करूंगा, इसको सिर्फ पेट्रोलियम यूनिवर्सिटी के बजाय अच्छा होगा अब इसको हम एक एनर्जी यूनिवर्सिटी के रूप में कन्वर्ट करें।
Pandit Deen Dayal Energy University.
Pandit Deen Dayal Energy University has a unique obligation to impart energy education in order to train energy ambassadors for the nation. For its pivotal contribution in its journey towards energy transition, the Government of India has bestowed the highest NAC A++ grade and has declared PDU as one of the premier institutions in our country. With the developed disruptive technologies for energy transition, PDU is transforming to be a model Industry 4.0 campus.
Well, Industry 4.0 is the evolved product of the industrial revolutions the world has undergone. The fourth industrial revolution combines renewables, automation, Internet of Things, artificial intelligence, cyberspace, and advanced logistics for advanced manufacturing. In short, it's the present and future of workspace across different industries. And to inculcate these learnings, we have 4 schools for that. School of Energy Technology, School of Management, School of Technology, and School of Liberal Studies.
The world is realizing that alternative energy is the future. India needs engineers who specializes in the energy sector to optimize this system, making them efficient, reliable, greener.
हाँ ये बंद कर दो पॉज कर रहा हूँ नहीं पॉज जो नहीं तेरे पॉज तो ऊपर दिखाई नहीं मैंने यार रिकॉर्डिंग बंद कर दी तू यार
यार तो अड़ियत नहीं है मेरी रिकॉर्डिंग में तो
पॉज से
रिकॉर्डिंग नहीं कर यार हमें बिल्कुल यूज कर आईपैड है तू हाथ में
बाकी આપણે હવે જોઈ બિચારો હમણાં જ જમવા એટલે ત્યાં વર્કશોપ
હા એ મને ફોન આવ્યો ને કે બંને થઈ ગયા. આપણે અત્યારે પાછળ જે છે એ રાખીએ શું કેવું?
और असं केलं ये मेरे को लगता है ना नहीं, इसको वापस से नेटवर्क
ना अंदर जाऊँ चाहिए मीटिंग से अंदर जाओ राहुल कुछ एरर गलत है ना, कोई केबल वगैरह ऑप्शन ਤੁਸੀਂ लैन के थ्रू कनेक्शन जो है वो इसके थ्रू अब नीचे नेटवर्क ना वो उसका इशू नहीं चाहिए नेटवर्क पे कुछ हो गया
what is energy? Aristotle portrays energy as the actuality of a potentiality, volatility, uncertainty, complexity, ambiguity. In this VUCA world, we are players brimming with untapped potential. But with a little push, we can become kinetic, setting our dreams in motion. Education, research, and innovation turn potential into actuality, and goals into a reality. In 2007, Gujarat was emerging as the industrial hub and developmental epicenter of the nation. Aiding this change, the then Chief Minister Shri Narendra Modi envisioned an extraordinary institute that India needed, where passionate researchers and innovators from across the nation collaborated to contribute and complement industrial growth in the petroleum sector. Thus, we came into existence, Pandit Deen Dayal Petroleum University. But since the first law of thermodynamics states that energy transforms from one form to another, we transform too. About a decade ago, we set up a solar plant that produces 1 megawatt of energy and inspired Gujarat as well as India to think about solar energy at a massive scale. These were the seeds sown that resulted in a bloom of specialization in other renewables. And then this happened.
बीते 1.5 दशक में पीडीपीयू ने पेट्रोलियम सेक्टर के साथ साथ पूरे एनर्जी स्पेक्ट्रम और अन्य क्षेत्रों में भी अपना विस्तार किया। लेकिन अब जिस प्रकार से देश और दुनिया की रिक्वायरमेंट है, जिस प्रकार से इस यूनिवर्सिटी ने अपना रूप लिया, मैं गुजरात सरकार से आग्रह करूंगा, इसको सिर्फ पेट्रोलियम यूनिवर्सिटी के बजाय अच्छा होगा अब इसको हम एक एनर्जी यूनिवर्सिटी के रूप में कन्वर्ट करें।
Pandit Deen Dayal Energy University.
Pandit Deen Dayal Energy University has a unique obligation to impart energy education in order to train energy ambassadors for the nation. For its pivotal contribution in its journey towards energy transition, the Government of India has bestowed the highest NAC A++ grade and has declared PDU as one of the premier institutions in our country. With the developed disruptive technologies for energy transition, PDU is transforming to be a model Industry 4.0 campus.
Well, Industry 4.0 is the evolved product of the industrial revolutions the world has undergone. The fourth industrial revolution combines renewables, automation, Internet of Things, artificial intelligence, cyberspace, and advanced logistics for advanced manufacturing. In short, it's the present and future of workspace across different industries. And to inculcate these learnings, we have 4 schools for that. School of Energy Technology, School of Management, School of Technology, and School of Liberal Studies.
The world is realizing that alternative energy is the future. India needs engineers who specializes in the energy sector to optimize this system, making them efficient, reliable, greener and sustainable.
I guess my most precious moment at PDU was the day I got a grant of rupees 2 lakh for my research project.
As a researcher, there is a lot to experiment with. Here, students are working on various process intensification-based biodiesel production techniques.
I'm not exaggerating, but this is the best place to learn about solar energy. I mean, where else you will get solar power plant and solar panel production unit on one campus?
At School of Technology, we offer 5 undergraduate programs and 10 postgraduate programs. From this year, we have initiated several minor programs.
There are so many options that one can pursue. There's data science, IoT, robotics, VLSI design, and additive manufacturing.
We have designed this project such that the students are able to get something that we call as practical wisdom, basically enabling them to showcase their engineering expertise in the real-world situation.
Cybersecurity and data sciences are no more things of the future. They are the driving forces behind Industry 4.0.
PDU has 1 month of international exposure program in which we get to go to foreign universities to study.
Actually, my life in PDU is full of experience. I got to meet different people from different background, nations, and I learned a lot.
Today, companies have no option but to keep up with technological advancements. This leaves management schools without an option but to create leaders who are agile, purpose-driven, resilient, and adaptable. And we are adamant about creating such leaders.
Students in energy management and general management are working for summer internship. It is a mandatory part of their curriculum. Many students convert this into pre-placement offer.
At the School of Management Pandit Deendayal Energy University, we have carefully curated and crafted our curriculum so that we make our students not only the best managers, but better business leaders so that they are going to add value to the enterprise.
We are proud to say that we have 100% placement record so far for all our graduating batches.
Industry 4.0 requires Education 4.0. The most modern way of making students learn and understand what work condition is likely to be in the future. Creativity, collaboration, and communications are some of the aspects which have been relevant in the past. And that's how they are going to be in future too.
Liberal studies is all about this. We want our students to develop themselves and go beyond every horizon.
It is not about learning one thing. It is about building an ability to pursue and learn several things, to understand issues that are important for the modern and future human societies and the world, to apply their mind to solve several social, economic, political, and environmental issues and problems.
The era we live in, where the entire economy is going to be based on automation, it is important to build liberal arts education. It develops cognitive flexibility and a mindset which will provide students the attitude towards understanding the profoundness of life and a way to live forward.
Pandit Deendayal Energy University is housed in 100-acre green and vibrant campus. With its world-class infrastructure, it is ideal for teaching, learning, and research process. We take equal pride in our sports, culture, NCC activities, and discipline, and thus contribute towards nation building. Jai Hind.
With ardent support from the government, collaboration with industries, and our expertise in academia, PDEU stands strong as an institute nurturing the future of the country. You can't create industry-ready students in just labs. One needs to go beyond. With investments flowing, we have established 16 centers of excellence that provide unparalleled practical exposure. Maruti Suzuki has contributed 70 crores towards the establishment of IACE, which spans over 9,600 square meters. It is the go-to place for all things automobiles. In the field of additive manufacturing, we are breaking new ground with metal 3D printing. We can create components for various industries, including automotive and biomedical applications, using our 3D printer. Contributing to the vision of Atmanirbhar Bharat, we have established a 45-megawatt solar PV production line.
To meet the global challenge for energy transition, PDU is establishing several manufacturing skill set training. The solar PV panel manufacturing line will be the first of its kind in the globe to set up a manufacturing unit within the campus. And this is exactly what industry is looking for, and that is what makes PDU unique in keeping our students industry ready.
Moreover, We are also making remarkable strides through our other excellence centers for carbon capture and energy storage, and are coming up with a similar center for semiconductors so that India has the brain power that's needed for its advances in the field. You can estimate the energy of places by the presence of the people. These are the guests PDEU has hosted since its inception. PDEU is a new home for students who come from far away to achieve their dreams. It is a campus of excellence, inspiration, and the future. Along with high standards in education and research, the campus is witnessing a vibrant culture enlivened by numerous magnificent events throughout the year. It is a place where you can literally feel the energy. Sun, wind, water, and the inner energy, positive energy, the energy of friendship. Oh, and athletes require a lot of energy, right? The energy of music, the energy of dance, performances full of energy.
So just imagine a world where energy is sustainable and abundant, a green, energetic world. So are you ready to be a part of this journey? And how is the energy for that?
PDEU, the world of research and University of Energy.
Very good afternoon. On behalf of the organizing team, I welcome you again in this post-lunch session. We'll be having one presentation in this session, as well as we'll be having the panel discussion. So, moving ahead, I would like to invite Mr. Vinay Kathor sir from IACE Gandhinagar for his presentation. Sir. ठीक है.
Good afternoon, everyone. Yeah. My name is Vinay Khator, and I'm heading Training and Operations Department at International Automobile Center of Excellence. The International Automobile Center of Excellence is established by a joint venture between Maruti Suzuki India Limited . So International Automobile Center of Excellence established by a joint venture between Maruti Suzuki India Limited and Government of Gujarat when Shri Narendra Modi ji was the Chief Minister of Gujarat state back in 2010 and 11. At that time, many of the OEMs, automotive manufacturers were coming to Gujarat. So Modi ji had this vision that whenever any manufacturer move from one state to another, they have to bring in a lot of manpower and employees to work in an industry. So rather than bringing employees from all over the India, Modi ji decided to train the manpower of Gujarat state and get them job ready. With this vision of Modi ji, IAC was established, and for its establishment, both Government of Gujarat and Maruti Suzuki India Limited supported with a 50% equity of each stakeholder. We are a Section 8 company, that is a non-profit organization company, and we are located at Knowledge Corridor, Raisen, Gandhinagar. Since we are a training organization, we see ourselves in the coming future as an apex body to train the youth of Gujarat state first in the automotive sector and then spanning across India. So currently we are conducting our operations at Gandhinagar, Gujarat, but soon enough we'll be establishing several small center of excellences in various states of India. And we are particularly looking at the market trend on training in Industry 4.0, that is a manufacturing segment. For automotive system, we are more focusing on electric and hybrid vehicles. And lastly, automotive lifecycle management, which deals with the scrapping policy at the end of registration of your vehicle. And also when an OEM manufactures a vehicle, a lot of components have to be brought in from various vendors and supply chain. So how the manufacturers manage those supply chains, just-in-time deliveries, and how they manage their productions, and after manufacturing a vehicle, how they deliver it to various dealerships across India. Not only India, across globe. So everything is taken care under one roof at IAC. We have three key stakeholders: Government of Gujarat, industries and students. So Government of Gujarat and industry have somewhat similar requirement. That is, they want the youth of Gujarat state to be trained in automotive sector, and industry have this requirement to have, industry have always the shortage of skilled manpower. So they look at IAC as a training partner, skilling partner, and many of the OEMs manufacturers that are located in Gujarat state undergoes training at IAC in various sectors. We do not only cater training to automotive manufacturers, but every person who is directly or indirectly related to automotive sector is our training. So it can be a manufacturer, it can be a vendor, it can be an insurance sector, tire industry, scrappage industry, and so on. So we offer three main things at IAC: job readiness programs, which is generally offered to the students who have recently completed their education, whether it be ITI, diploma or engineering graduate. And we train them on the skill which is generally required in industries. And after completion of the training, they are ready to work in an industry from the very first day, because they'll be working on that are actually being used in the industry. Then we offer upskilling programs for the industry professionals and trainers. So industry professionals cannot be away from their work job place for more than 2 or 3 days. So we hyper customize the courses depending on their requirement. And we also offer train the trainer programs to various engineering college faculties, diploma college faculties from across India. Lastly, we are a Gujarat state nodal officer for the startup events. So we have an incubation center called Prerna, where we incubate various startups. We get them in touch with government organizations and industries. And if after evaluation it is found that the prototype that the startup has can create an impact in the automotive ecosystem, automotive industry, then we also provide them funding up to rupees 25 lakhs so that they can further design and develop their product. So we offer training in two main sectors: automotive systems and manufacturing technology. So in automotive systems, we start with very basics, automotive systems, electrical fundamentals, and then we go deep into various modules related to vehicle. So it is powertrain, drivetrain, painting, lean management, soft skills, industrial safety, and managerial skills. And similarly for manufacturing technology, again we start with very basics and then we go into various domains related to manufacturing, that is plastic industry, machining technology, welding technology, body repair, LMS, MIS and soft skills along with industrial safety and management skills. In engineering colleges and universities, more theory is there and less practical is there. So we are a kind of finishing school where majority of the time the trainee is on the shop floor performing hands-on practicals. So 80% of the time is spent on practicals, hands-on experience, and remaining 20% is functional theory, where they are briefed about what has to be done today, how we will perform certain sets of experiments, certain practicals, and so on. Apart from providing technical skills, we also provide them soft skills, management skills, and industrial safety, because only technical skills will not get a student job. During an interview, soft skills, management skill, and how to present yourself in front of an employer is also important. So we give them a full package, starting from technical skills till interview skills and soft skills. A few highlights: other than training programs, we also keep hosting various government events and industry events. So back in 2022, a ministers conference was held at IAC, where education ministers and secretaries from across India visited IAC to discuss the implementation policy of NEP 2020. So all the ministers from across India came to IAC to have this discussion. So apart from government events, a team from Suzuki Motors Japan came to IACE to undergo training on electric and hybrid vehicle as well. We are also a center of excellence for Maruti Suzuki India Limited and Suzuki Motors Gujarat. So all the GETs that these two industries hire, so before they are allowed to work in an industry, they come for an induction program at IAC for a duration of 5 days. A few other highlights. So we have signed MOUs with different DTEs, that is Directorate of Technical Educations, who sends their trainers, college faculties to IAC to undergo training, periodic trainings, which can be of shorter duration or medium duration. We have also signed an MOU with National Council of Vocational Education and Training, NCVT, Ministry of Skill Development, and through their support, we can offer the credits to the students. So using those credits, the student can skip a particular course or a particular subject in their engineering graduation, and they can go in-depth knowledge. They can have this in-depth knowledge by performing hands-on practicals. Then all the MSIL and SMG employees that they have, Maruti Suzuki India Limited and Suzuki Motors, so all the employees that they have, somewhere around 3,000 or 4,000. So we trained them all in the field of electric and hybrid vehicles. We also kept this first responder training program. Back when electric vehicles and hybrid vehicles were launched, none of the people in Gujarat state, particularly I'll talk, were aware how to control the fire once it is spread or once it occurs in an electric or hybrid vehicle. There's no way you can control the fire or you can stop the fire. But the best we can do is how to evacuate from the place so that we can safeguard ourselves. So we kept this first responder training for all the firefighters that are there in the Gujarat state. A few other highlights. So all the trainers we have at IAC are internationally skill certified. So a team from Germany and Australia came to IAC to train our trainers, and after their training they were certified with IST certification. Suzuki Motors Gujarat and Maruti Suzuki has to keep an annual meet for their vendors where they discuss what can be done further, how can we improve the product categories, costing wise, materials and so on. So we also host several events for not only Maruti Suzuki or SMG, but for various industries. We also started recognition of prior learning and alternative medium of assessment, wherein a person working in an industry for several years, and if he or she do not have an education degree certificate, so based on their experience, we keep this RPL assessment, and if they successfully crack this exam, we award them on behalf of Ministry of Skill Development an equivalent degree certificate. a few enablers what makes IAC different. So we have more than 21 university tie-ups. We have more than 21 university tie-ups which are not limited to the Gujarat state. We also have an industry knowledge partner. So we use this knowledge partner for two purposes. First, when we design any new courses, so we require a lot of contents. So we ask our university partners, knowledge partners to support in that. And secondly, these knowledge partners also allow their students or bring their students to IAC to undergo internships, to undergo training programs, to undergo post-graduation programs, and so on. Similarly, we have a pool of Industry Connect team. So this Industry Connect team lets us know what the current trend is going on in an automotive ecosystem, automotive sector. And based on their inputs, we hyper-customize our courses. We ask our Industry Connect team to verify whether this course will solve the problems that the industries are currently facing. And once the verification is done, we start offering these courses and make the industry ready in the direction which they are planning to move ahead in 5 or 10 years down the road. We are actively working on social media platforms, whether it be Instagram, YouTube, Facebook, anything. And very frequently we release videos, infotainment videos, short videos, long videos related to automotive sector. We have several affiliations. So all the courses that we offer at IAC, so that trainee receives a dual certification. One is from International Automobile Center of Excellence, and second can be either from this 4 universities, depending on the course that they have enrolled in. To offer future-ready courses such as Industrial Automation and Industry 4.0, we have tie-ups with Fanuc, Festo, Panasonic, and Rockwell. And similarly, to offer the courses for advanced driver assistance system, electric vehicle, hybrid vehicle, and so on, we have tie-up with Lucas Newley, White Carbon Motors, and LaunchTech Company Limited. So on behalf of IAC, I thank the team of SECA and Ahmedabad University to allow me to introduce International Automobile Center of Excellence on this huge platform. And I warmly welcome you all. If you wish to visit IAC sometime, you are very most welcome to visit IAC. We are located at Raisen, Gandhinagar, Gujarat. And it's one of its kind organization, not only in India, but in entire Asia. So we are spread across an area of 2 acres. And in this 2 acres land, we offer the training of automotive systems and manufacturing technology. Thank you very much.
Thank you, sir. Now I would like to invite R.K. Singh, sir. Moving ahead, in this session, now we'll be having a panel discussion that will be moderated by Dr. Piyush Goyal, sir. So before inviting him, I would like to give a brief about sir. Dr. Piyush Goyal is working as an associate professor in Mechanical Engineering Department at Faculty of Technology and Engineering, the MS University of Baroda. He did his PhD in 2010 from SVNIT Surat. Dr. Goyal area of research includes design, manufacturing, and tribology of composites. He is a life member of IST, TSI, FRP Institute, and annual member of SAE. He has guided 4 PhD students and 4 are pursuing, also guided 35 ME MTech dissertations. He has more than 70 research papers in referred journals, national and international conferences. He has also published 5 book chapters in reputed publishers like Springer, ACME, and also edited 1 conference proceeding and 1 thematic journal issue. He has delivered more than 30 expert lectures in various faculty development programs and many expert lectures to student community. He is acting as a reviewer in many national and international journals of Sage, Springer, elsewhere, and in his area of research. He has completed 2 MODROP projects of AICT New Delhi. He has also received research product grants from DST Delhi and Guj Coast. He has also awarded travel grants as a young research scientist from DST India in March 2011 for Malaysia and under UGC merge scheme in March 2015 for London. Dr. Goyal is also acting as external expert, BOS member at BVM Charuset. He is also a part of various national level body at AICT committee. Sir, we welcome you to moderate our session on present challenges and future ahead of lightweight composite industries in India. We welcome you, sir.
Good afternoon, everyone. Good afternoon, everyone. And thanks to SECA and other institutes for inviting me as a moderator for this panel discussion. Now I would like to invite Mr. Jitendra Trivedi, Member Governing Council, Composite Association, as a panelist for this. Welcome, sir. Other panel member is Mr. Sri Naimish Patel. He is the head Optical Payload Mechanical Division, ISRO, Ahmedabad. Welcome, sir. Another panelist, Mr. Lalit Khatri, who is Director, Link Composites. Welcome. We have with us Dr. Hemant Chauhan from the Ahmedabad University as another panelist. We are given maximum 45 minutes time, so we'll try to finish in 30 to 40 minutes so that later on we have 5 minutes remaining. The topic of the panel discussion is present challenges and future ahead of lightweight composite industries in India. So since morning we have various lectures and insightful information regarding the composites. So as we have experts in this field and will be whatever the knowledge we have gained, based on that we'll be having this discussion on this. So it will be result into some fruitful outcome for this panel discussion. So, sir, what we have planned is I'll be floating the question and we'll be having the discussion. And first you will give your views on that, and then later on if anybody wants to ask or some counter questions are there, that will be there. Is it okay, sir? Okay. So first I'll be asking questions to Mr. Jitendra Mistry, who is Governing Council, Composite Association. The first question is, in light of the current challenges faced by lightweight composite industry in India, particularly the high production cost and the lack of, what steps is Council taking to address these issues? Yes. You can sir speak from micro.
Audible. Well, I think audible. I'm audible. Yes, yes. Uh, when we talk about lightweight composites, so I need to also give you a little bit of background on what 360-degree changes that has happened. So while coming today in the morning, I saw in your morning panel from ISRO, also Mr. Pawan Tyagi from Reliance. One thing that came to my mind was when industry started, I'm not talking about 60 years back, but I'm talking about last 30 years, 25, 30. At that time, those who were manufacturers have become end user, and those who were end user have become manufacturer. So this is the 360-degree. So giving you two classic examples of how this transition has happened in composites. I'm talking about way back in 1984-85 in transport industry, mainly in railways. Eastern Railway was the first one who started SMC unit in Calcutta, manufacturing conversion. So they were manufacturer for composites. Today, with Vande Bharat Express, they are the largest end user of composites. So this is one example. What Reliance started in petrochemicals, equipment for chemical and piping system, today they are manufacturers. So this is the transition, this change that has happened, and it is happening in most of the application areas. This is one part of it. The second part of it, what Mr. Goyal has asked me about what association or what industry per se can do. So there are challenges there. So there are challenges in terms of, in the morning it was talked about what is the way to collaborate. And the collaboration and the knowledge share has to be on the basis of commercial viability of any of these associations. Merely research and development, merely saying that this product is good, this product will work well, is not going to help. So that challenge somehow the industry has to overcome somehow. The knowledge partners, knowledge centers need to understand what is the need of the industry and how those needs can be fulfilled in most competitive way. This is the two things that I see as what we need to look at in the period from now onwards for next 10 or 15 years.
Sir has described that the challenges and need of the industry, that is the main focus. Are there any specific initiatives or collaborations in place to lower production cost and enhance the skill development within the industry? It's open for all.
So, I would just like to, Vedis had told that this is the need for the industry, technology and the training. So we are also taking initiative there. Very soon, going to start a technology training center in Vadodara. It is already under development. It will take 1 year time. There we are focusing to provide technology, information, training to new technocrats who can learn their technology and then serve to industry. It's a kind of understanding, and they can come with their idea or their challenges. We have a team of specialists, experts they can provide the solution. Further, we are also going to develop a tooling and mold making center there. So, in the composite, the tooling and mold making is the main challenge because your mold is good, you have the technology, but the mold is not as safe. So you cannot make the part. We are going to offer a technology for mold making, and somebody wants to take a trial or they want to make a mold in our facility, we are also offering that we are going to offer to industry.
Thank you. I think RK Singh sir has already taken this initiative, and this is the result for that. We can step in this direction. So this is one of the things. Now my next question is to Mr. Nemesh Patel, specific related to ISRO. Given the critical role of lightweight in the design and performance of optical payload for space missions, how is ISRO addressing challenges of high production cost and limited domestic supply of advanced composites materials?
First of all, actually, morning our directors said that we would like to see the number plates from the space. So that demands like very large optical instruments, optical telescopes. Now, if we are going for a very large telescope, and if you think of use of metal usage will be a very heavy. It will be like of the order of 1 kg payloads. Now, launching 1 kg mass into a orbit around 10 lakhs rupees. So, if we shift from metal to composite, we can reduce weight by half or even lesser than that. So that way we can reduce the cost with the use of composite. Now within the composite, how we can further reduce the cost? One is right now whatever design right now ISRO or SAC is doing a design of composite, and we are procuring material from outside the countries because of speciality or because of requirement of like high modulus, high stiffness, high strength. So if Indian industry can make those fibers, if they make resins within India, we can reduce the cost of import or we can reduce the cost of final product. Apart from that, there are two categories. One is a lightweight, only a lightweighting to reduce. Other requirement in case of especially for optical payloads, we need a very high stiffness. Reason is like when we are on the ground, there is a gravity. The gravity is acting on the hardware. So even though we use a lighter material, it will be under gravity. Once we go to a space, there is absence of gravity, and because of that, the absence of gravity force, structural shape gets changed, and that affects the optical performance or performance of the payload. So with the use of high stiffness, we can eliminate that issue. So if we right now we are procuring those high stiffness fibers from outside, if we can make in India, it will have a cost benefit. Second aspect is like we need a low thermal expansion, because in orbit we have a lot of temperature variation. So in the temperature variation, if we have a fiber, India can make a fiber with a low thermal expansion, that will make our instrument less sensitive to temperature. And in addition to that, if we add some thermal conductivity into a fiber, that will reduce the temperature gradient. So right now, this technology or the fibers, whatever we are getting, it's from outside. If some industry in the India, if they can fabricate, so that will have a cost benefit. If I recall that when I joined it 20 years back, we were not thinking of even developing composite within the India. We used to procure it from STM outside. Those camera structure we used to get it from outside, which was costing almost, even today also, whatever cost they costed at 20 years back, we are able to manufacture in half or 1/3 of cost at present. So that time we procure full hardware from outside. Now at present dates we are designing, we are procuring fiber only from outside. By that we are reducing price by half or 1/3. If you are fabricating fibers and resin within the India, that will further reduce the cost composite, especially for optical fibers and remote.
Are there any partnerships or in-house developments which are aimed at overcoming these challenges to ensure reliability and efficiency of the future?
Right now, I mean, within our SAC, few of my friends are here who are dealing in the design and development of composite. So right now our objective is not to develop fiber or resin. We would like to use those resins and fiber to customize our product to develop our product. So we are looking for some industry who can participate into the development aspect of that. But yes, design of composite structure, even after procurement of fiber, both like fabrication, testing, even testing also like getting zero CT. Zero CT means it is insensitive to temperature. So even we design a zero CT structure, testing of that zero CT, expansion zero, that needs a instrumentation, high order instrumentation, that those developmental parts is there within the issue.
Question is to Mr. Lalit. As a leading player in composite manufacturing industry, how is Link Composite navigating the challenge of high production cost and limited domestic supply chain in India? First of all, are we agree that we have limited supply?
Yes. I think we are agreed on that we have limited supply. So in domestic, we have a limited manufacture of the raw materials, and that's why we are importing a lot from other countries, China, Paris, everything.
So, any strategies are you implementing to remain competitive in the market? It's a personal matter. Because
yes, so we are investing as a new plants. So we are expanding our facility, and we are going to collaborate the foreign companies. So right now this material availability in India is less. So we are going to do a partnership with other companies so we can bring the technology and then we can start the manufacturing in India. So that we are already in the process. We are signing JV with other companies. So soon we will disclose also.
Now that was regarding some of the questions. Now we come to academics part somewhat. So as we have gone through some of the lectures and mostly in our academics, whether it's a chemical engineering branch or a mechanical engineering branch or it's a polymer field or textile, they are studying specific things. And this composite involves the multidisciplinary approach. So it's very challenging to develop the engineer who is having complete knowledge of the composites. So that is one of the most difficult challenge that we are seeing right now. And I think just now we have gone through that specialized course in masters at Ahmedabad University as well as IIT Gandhinagar. So I'll be asking the questions to Dr. Hemant Chauhan, who is from Ahmedabad University. Considering the current challenges, whatever we have discussed, faced by the lightweight composite industry in India, such as shortage of skilled labor and need for advanced research, how is academia is contributing to bridging these gaps?
Well, all the points were relevant and I had some of the other input to that. So maybe we'll start from here. As we all know, the research starts from top. So when there was no metal, first time ore came into existence and metals came. Few decades back, 5, 6 or 7 decades back, something like composite came into existence. And today we are like, that's the primary reason which sir can enlighten us that okay, there are more than 6,000 satellites moving all around us. Just because of, I mean, one of the major reason happens to be composite. Had there been only metal, probably would have expected these numbers. The numbers would have been there, but much lesser. So we see that the science first develops from the top. So we have lot many PhDs across the globe. Yeah, might be the West world is far ahead of India. Yet in India also we have decent number of researchers or academic institutions, including IITs at the top, of course. So there is lot of research going on. But when, like he said, that in industry we look for, so industry is looking for the real labor who is going to work on the shop floor. Now there is a big gap. The one who has done research and PhD, we don't expect, nor the industry would like that a PhD has got a blue-collared job kind of, and he's working with the resins. He should be more of a scientific nature. So this is the first of its kind initiative that we want to bring that knowledge from PhD to masters. Definitely it can't be equal to PhD, but at least he'll know all the aspects of composites. So that will bring a stage closer to what industry is looking for, so that they can serve industry in a better way. So that is the primary objective. We can fill that gap from that. And I'll take some examples like Sir mentioned. I would say that in last 2 to 3 decades, carbon fiber has become a standard. Aerospace means carbon. At one point we say it's good, but at the same time, we said that there is a need of innovation as well. So we all agree. But that part is missing. So if we have new task force, new members in the team, the new generation, then that part can be only taken up by the academics. Just we won't have time for that, and space organizations won't allow to experiment with in the space missions directly. So that is one part. So that is something, sir, which I would like to add, that we are somehow entire globe, not just us. It's to all the mankind that we are in that trap. Aerospace is equal to carbon.
Actually, we had I think one ma'am was there from IIT Gandhinagar. So we had certain issues like swing back of hardware once we remove out of board. We are looking for some researcher who can dedicate, who can explore the theoretical aspect and explore or generate a model so that we can counteract compensate so that those specs can be compensated, or at least we can give a corrective measures in the mold so that after spring back we can get a desired shape.
Well,
so that is one example. That is one
the
example.
raw material part of it. We
Raw
are stuck
material,
with that,
yes,
okay,
actually,
there is a limited set of resin, there is a limited set of fiber we will follow. And we are not willing to experiment with something new. Yes, you don't have time for that. That will only always begin with academics. So that is what my point. And adding to that dimension, sir, I came from the defense side, bulletproofing area. So recently, Reliance, one segment of Reliance actually, they have started working on the development of ultra high molecular weight fiber tape, not fiber form, not the filament form, but the tape form. So there is a bit of a technical difference between the two. Who has been doing that? So yes, the work has started, and UHMWP happens to be one of the most costly affairs because that comes from the bulletproofing background, high strain rate applications.
I am also from academics, and I had guided 10 PhDs and more than 70 MTechs till date. What difficulties I had faced in the initial stage when I started my PhD in 2003, I was just looking for the banana fiber, and I asked from the Kerala. Parcel came, that postman came. It was smelling like anything. My wife told that what has come, what you have ordered, something. So it was something scam kind of thing, and so, but that was a learning experience because just now in the morning we were having wonderful lecture with Professor Inderdeep Singh sir, sustainability. As being from academics, we are more interested in that, looking to environment and other things also. Other thing I want to point out, as industry people are and R&D are here, as a academics, sometimes all institutes are not having all the facilities available. So even though they are interested, but they have to look around and take the help from the organizations.
I can add a dimension to that, sir. And that is like, as you know, and I probably missed to mention in that first.
That is missing actually. And,
so here, like
this kind of
is in collaboration. It's the university's Ahmedabad University, but then a major portion is to be taken here by Atira. And Atira, we all know, is the primary member, supplier. So we have that good hand-holding of the industry, and that to the extreme elite class with ISRO. So ultimately the students are working on projects of ISRO, indirectly of course, not directly.
Actually, many of the time,
even first testing I had done at textile there only. That was the initiative. And but the viewpoint is that more collaborations and more interactions like this, That will help individuals.
Any of the time people are not knowing
Not knowing, that is the main thing.
Suppose in ISRO, many of the people may not be knowing what are the different facilities which can be used for development of composite. Same way, I may not be knowing what are the facilities in other composite development industries. So such kind of conference can expose those facilities to users so that they can use.
This is what we have been working. So manufacturing equipment, these are white elephants. All understand. Processing of composites.
That's what now actually ISRO now present development is. Government of India has given a free hand to ISRO that all the facilities of ISRO can be used by private vendor or startups who cannot invest to like very large vibration facility or very large thermo chamber. So they can approach our ISRO facility and they can use with a minimum or nominal price.
Individual questions I had asked, now generalized questions or some of the query maybe for the audience also, but a few points of discussion like, do we have we are having absence of solid and concrete regulatory member bodies for composites in India?
To some extent, I would say yes, because if you look at US or if you look at Europe, there are two bodies, which is the government body functions, science and technology sector, very actively industry associations. They have a effort for standardization. Whether you look at it infrastructure area or any of the composite area, that is not the reason why US composite industry is so developed. There is always one third effort by the partners. Something similar is there in Europe, mainly Germany, where industry and academic participation is either equal or higher on industry side and lower on university side. Make efforts towards more competitive, workable solution. Whereas in India, it's still something to develop and only or as composite association or any of the knowledge partners of center of excellence. Center of excellence has to work in standardizing those aspects. I think in Atira we did when I was one of the forum member long back. We did try to bridge the gap with the Bureau of Indian Standards. So they already have some standards, but then how do you, those ASTM and all, you can bring it here and more useful in terms of what a product standard should be. So we did work on a couple of, unfortunately, one of the largest area at that point of application area was GRP5, which was, both for sewage and water. Government, that's why I'm mentioning that the government was pioneer in, water transport pipelines, secondary pipelines, did award a lot of tenders at that time. But somehow, since there was no standard pipes, that industry has, is completely, vanished today as GRP piping. So we need to work on standards which are locally acceptable, and whether we work with BIS or whether we work with Center of Excellence and in formulating those with the industry, that would help a lot.
Thank you for your dimension. Rightly mentioned, sir. So I have to narrate rather the short journey of. We started a project. Army had a requirement that happens to be X. That was hard steel core AK-47 is primary. Here down the line, first time Indian standards for ballistic testing to existence. So now what was the original question paper is now migrated to a new one because now we have Indian standards. When it started, it was to follow US standard, NIJs. And one and a half year down the line, now we have Indian standards. So few of the finer things of testing, now they are slightly deviated. Now whom to blame him, how to, because the original plan was something else and now things has changed. The goalpost has changed. And by the end of what we could do, the army said that, okay, this particular threat is no more a threat to us. I mean, it's too small a threat. We have raised the bar of the threat. Now we are more concerned about sniper bullets than. So now again the question paper has been changed by someone else. And he is the end user. So ultimately the entire research is for that. Otherwise there is no point of research. The part is that there was a US standard, then comes an Indian standard. And of course, as you rightly mentioned, majority of our Indian standards, of course, they are derived from maybe West or US, but then most of them have come into existence in last 1 decade. In fact, you must remember many of the committees or the BIS committee, we are in the stage of finalization of the Indian standards. They are yet to be finalized, including finals.
That if industry people are giving some product, should they give the reliability of that product to the customer, that this much it is? That level we should think in composites. Because for metal, right now it is a...
Yes, but you have a Bible there.
Yes, because handbooks are there and everything is there. But so if this is available, that can be achieved.
Also, John was mentioning very correctly, there is also a requirement by the industry to have a international standard testing facility for composites. There are a facility available in IIT Bombay, IIT Chennai, IIT Kharagpur, but these are all underutilized facilities. I don't know really about now what is the status with Atira. They have a very good testing facility, how effectively that is utilized. But if these testing labs are in a position to give certification for the industry, because I purely look at it from industry side of view and from the commercial point of view only. And when I look at that part, 60% of our finished products, either in direct form or indirect form, end user is government. Just take it. So 60% plus is end user government. Whether you take transportation, infrastructure, or any of the area. So composite per se in that is either you have a secondary contractor, primary contractor, or the level 4 or level 5, whatever you call it, the government tender process. So if the government is end user, then the government is looking at those standards. And if we are able to combine these efforts from the knowledge partner in standardizing that, yes, there is a test lab which will certify product for you. We take the guarantee that if the product is manufactured as per this, will meet your end use requirement. So I have coined a word called fitness in use. So we need to look at fitness.
Actually, many of the tests we go for, like metal test we used to real lab. Yes. But if I look for composite testing, if I ask some private vendor to measure a coefficient of thermal expansion, I'm not aware about what are the different standards to be followed.
You're very right.
For that. And that
tailor-made fiber structure pattern, that is also affecting.
The test and because of lack of the standard of composites, maybe like commercialization of like you told about reliability numbers. When because of this standard, it will be difficult to get that reliability number also. Like whether to say 90% or 70% on what basis we know we don't have that goal.
Industry, they are asking products for composites, they are asking A bias or B bias. There are in terms that 95% or 99.9% reliability. So it is very difficult right now to opt that.
At the same time, there is another challenge. Handling composite sample is extremely difficult when it comes to extreme composites. Had it been a glass fiber or basalt, it's fine. Things can be managed. But when it comes to extreme cases, like UHMWP or carbon fiber based systems, clipping, having the proper holding fixtures, without any error, conducting experiment with composite specimen in itself is that is one of the major reasons that standards cannot be like finalized. One party is agreeing to it, another one has said no, we have experience of so we need to cater to that as well. That process many of the times like the standards unnecessary or maybe stretch timelines.
More last point of discussion regarding this lightweight composites. Do we have low IP activities? Low IP activities intellectual property.
Covered by resins.
Still, people are working and developing, but that is not. They are not approaching this IP activities. So, is it so or
actually
intellectual property rights?
Okay, I was under the impression of measurement.
Mainly in the government sector, everything is IP. Especially for ISR, we don't disclose outside. So in order to get the IP, at least you need to disclose it. So to avoid that confidentiality part, many of the time, whatever development is done within the government sector, especially research sector, those confidentiality can will but sometimes generic things used to be registered to get the IPs.
So like he mentioned for aerospace, I would mention for the defense. So in ballistics, bulletproofing, neither the raw material nor the end they are interested in filing the patent. So it's really difficult. At the same time, we are not even allowed or preferred to share the results. You became a success in a particular threat level or you became a not success in a particular threat. So it is discouraged that you disclose the result because ultimately you are going to share the result to the globe. So your neighbors and your counters are also knowing the result which government or the organization. We do agree to that. The defense data, so it should
not. We can say that if it is research based and some critical applications are involved. Right now in India, people are not going for that, and if it is a commercial product, if it is to be used by many people are going still.
Then it's a trade secret. Then it's a trade secret. So Reliance comes to us and they say they don't.
Like John, look at the kind of I'm taking DRDO or DRDO. The patents are there, the technology is available. It was not commercialized for last 30 years. Now, some of them are being shared with the industry. That yes, this technology can be going to the industry. Industry can do the manufacturing and all those areas. Then they have a confidentiality there. They have an it is one-to-one only and that way. But one of the another area that I would like to the challenge if we divide this whole industry into two parts where Raman and Mr. Patel is one very high-tech area of defense and, satellite communication. And on my right, I have a young boy who is, on more commercial side. You look at the biggest challenge that we see now in the composite industry, mainly the commercial composite industry, is recycling. And in the morning, yes, Singh did talk about thermoplastics, thermosetting, and what recycling can do. The work is already in place. Some of the things, the challenges are already addressed, both in terms of commercial carbon and glass composites, where recycling is happening, patented. And I think in next 5 to 10 years, we will see a lot of those matrix systems coming in with recyclable properties, where especially in, aerospace, pre-preg side, and also on renewable energy side, we see a lot of these recycling, systems be in place.
Now it's open for the audience to have specific questions.
Yeah. So you were talking about the lack of availability of raw materials from Indian suppliers. I think Mr. Patel mentioned that when it comes to specialty applications for Indian suppliers, and those products are mostly imported. So the only way that you can develop local suppliers is if the manufacturers of composites are either encouraged, or if you place some kind of regulation to increase the amount of raw materials that are locally manufactured.
We are not able to.
Actually, it's not audible here.
Not audible clearly.
Sorry.
Please come here.
Excuse me. You can speak from there.
Or you can speak little louder there.
Yeah, sure. I can speak louder. Is that better? Can you hear me?
Slightly.
Okay. So you made a point that that the Indian raw materials, especially for specialty applications, you don't see a lot in the market, and you're forced to import because of the lack of availability of those raw materials. So if you want to see more Indian raw materials being used by composite manufacturers, then you need to encourage them to use those Indian raw materials or help raw material manufacturers develop those products. So how would ISRO, for example, or the Composite Association not just regulate, but I guess encourage composite manufacturers to help raw material manufacturers develop those products? Something like your FAME subsidies in the automotive sector, they require a 70% local raw material usage. That has greatly encouraged people to start developing specialty raw materials. So how would you do that in the composite sector?
The question is whether, whatever special material is required, instead of importing from outside, what is the government's initiative to do it within the India? So if I share 2-3 examples, like nowadays for procurement, we look at government institutes. We have a requirement of Make in India. Our policy is like that it has to be, if something is available within the India, you have to buy it from India only. You cannot go outside. So that policy will enforce or it will help Indian startups to, or it will promote the Indian startup to develop something new. Second is, earlier we had a policy that something if you want to procure from outside, we were mentioning that they should have a prior experience. They should have a prior 4-5 year experience in the similar field. Now to encourage the small scale industry or startups, those terms is removed from our procurement. We always love to encourage startups for developing something new. And third thing is, we have different channels like Respond. So we have a Respond model where if some industry as well as some academia, suppose for Ahmedabad University want to develop something on resin, which is of importance to our application, or fibers, which has an importance to our application. We have some funds which can be given to those institutes who can develop products which are required for ISR. So that fund also will help researchers to R&D or development which is required by ISR. So these are the few examples I know. Many of the things I may not be knowing. Maybe Government of India is now continuously behind encouraging the Indian industry to develop and to eliminate the foreign imports, by which we can save the foreign exchange. We can generate employment within India. There are different models like this model is there, some other models also will be available, which will encourage Indian startups, Indian entrepreneurs to develop products which are required for India.
Like as you mentioned, in both these fields, aerospace and defense, what happens? There is a weight restriction. There is an upper limit of weight. You can't go beyond that. That at the time, what he has correctly mentioned, what government initiatives are, there is an upper limit to weight, and there is a requirement of mechanical properties. Unfortunately, till we meet those numbers, it's really difficult to use those components. I hope sir will agree to that. So that is another major challenging area, that in many of the extreme testing conditions, many of the products unfortunately could not perform to the desired level. So, but the good part is that government is still promoting the negative import fees. So I have been dealing with a couple of defense products again. So if army is getting something from the westward and there is a weight X, India is producing X plus delta, government may push it. When it failed in terms of mechanical performance, then there was a challenge. So that definitely adds a dimension. Having said that, okay, we qualify, that won't work many a times. I hope we can add.
So, what are the applications of composites in the area of railway?
Okay. Sir, I hope we should have the entire wagon out of it.
Current applications.
Current applications.
Future application. Current, do we have any applications?
Many of the component interiors of
made from the composite, whether it's the window panel or this roof ceiling, floor panel, it's all from composites. Toilets also, water tanks. All this in modern railway, all the toilets are made from composite. 100% composite.
That to low cost composites. So that's a good part. Like 1/3 in weight, nearly slightly above 1/3 kind of. And the costs are also pretty moderate. Right?
Another question is that we talk about 3D printing for polymers, metal. Nowadays, there are printers available in the market for printing the composites. Probably that also should be considered, probably your discuss. That is good, otherwise printing using composites.
The good part, we have fiber now. Not so good part, we cannot have a continuous fiber. So when we say 3D printing intermittently, we may require to stop printing, depending on the complexity we change. So what to do? So we cannot have printed a continuous fiber. There is when we say any of the application-based fiber, keep the training, we are happy with the isotropic kind of a material, homogeneous. So we use a random fiber. But here if we are having a nozzle operated thing, then we can only expect material from one direction. So continuous fiber and continuous or unique kind of a phenomenon that has got a lot of benefits. So on that front, there is a difference. Otherwise, yes, in 3D printing now we are having a lot of chalk fibers.
Any other questions from the audience?
I would like to share one small desi example of my childhood. I am from small village. My mother, at the time there was no plastic parcel. फिर उस वक्त क्या करते थे जो पानी वगैरह मतलब अनाज भरने के लिए कुछ बकेट्स चाहिए तो जैसे हम लोगों का स्कूल खत्म होता था ना तो जो बुक्स होते थे उसके पन्ने फाड़ के उसको पानी में भिगो देते थे। एंड देन गाँव में इमली होती है, इमली उसके जो सीड्स होते हैं ना उसको पानी में मतलब थोड़ा बॉइल करके उसका सीड का जो पाउडर होता है दैट एक्ट लाइक अ रेजिन, इट एक्ट्स लाइक अ रेजिन। एंड जो पेपर्स थे उनको पूरा मैश करके तो रेजिन ऐड करके देन शी यूज्ड टू टेक वन लाइक एग्जिस्टिंग बाउल और एक पानी जैसा रख के उसके ऊपर वो लेयर लगा देते थे एंड देन केप्ट फॉर सम टाइम एंड देन दैट पेपर एंड जो रेजिन था जो सीड्स का वो एकदम क्योर होके इट वाज एक्टिंग लाइक अ वन बाउल। सो कंपोजिट अभी हम जैसे बात कर रहे हैं कि कुछ सालों से कंपोजिट हम यूज़ करते हैं बट इंडिया में कंपोजिट कई सालों से अपने जो पूर्वज थे वो कई सालों से यूज़ करते हैं। आज काफ़ी सारे सुबह में मॉर्निंग में बायोडिग्रेडेबल कंपोजिट देखा तो मुझे वो रिकॉल दैट इवेंट।
So we'll conclude this panel discussion on the lightweight composite industry, present challenges in India. Very much thankful to Jitendra Mistry sir, Nemish Patel sir, Lalit Khatri, Dr. Hemant Chauhan. And I think we have very fruitful and nice discussion on this topic. And in short, we'll conclude this discussion that the lightweight composite industry in India are facing significant challenges, that is including high production cost, a shortage of skilled labor, limited domestic supply chain. Despite the growing demand in sectors like automotive and aerospace, the industry struggles with the high cost of raw materials and specialized manufacturing equipments. Additionally, there is a lack of awareness and adoption of composite materials, hindering widespread use, regulatory hurdles, and the need for environmental sustainability further complicates this progress. To overcome these obstacles, the industry must focus on the innovation, skill development, fostering public-private partnership to build the robust ecosystem for the growth. Irrespective of these challenges, in last decade, we have seen much progress in this field, as we can see lot of collaboration and lot of research in this field. So with this, I conclude this panel discussion. Thank you very much.
Thank you all the panelist members and the moderator of this session. I would like to invite R.K. Singh sir. Sir, please. Sir, please. To answer. Sir.
You answer.
Sir. 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 Thank you, sir. Sir, Arun sir, please. Thank you.
एक ग्रुप फोटो ले लो।
Sure.
आगे जी।
आप हमारे
So we came to an end of the first session of the post-lunch. So we'll be breaking for tea for 15 minutes and then we'll be back after 15 minutes. I request you to please be on time. That is 15 minutes break. So be on time. Thank you.
पोडियम पे जा रहा हूँ अभी देखना मेरे को तू देखते रहे अभी मेरे को कर रहा है कि
पोडियम सिलेक्ट आ गया है
मेरे को ले लिया हाँ अभी तेरे को प्रीसेट सेट करना है ना तो तू क्या करेगा प्रेजेंटेशन है इसमें जाएगा लेफ्ट पोडियम बंद करेगा कैम होम करेगा फिर कैमरा कंट्रोल में जाएगा ये सिंक वाला हाँ मैं लगाता डन चल रहा हूँ फिर रहा हूँ कार्ड कैम होम किया तूने पोडियम बंद किया पोडियम पे तो मेरे को कर रहा है कि नहीं मेरे बता नहीं कर रहा है ना कि वहाँ बैठ लेफ्ट पोडियम क्या हम रेंज भी नहीं भी रेंज बेसिकली लेफ्ट पोडियम चालू कर उसके बाद देख क्या बताता है हाँ चालू कर दो लेफ्ट पोडियम चालू कर
नहीं पूरा ही कर रहा है
कुछ किया
नहीं कुछ नहीं किया उसके बाद
कुछ सेलेक्ट नहीं किया
नहीं किया
अभी पहले चल रहा था अभी हो गया
अभी हो गया आपका
अब मेरे को ले अभी बोलता हूँ स्वयं वीडियो प्ले करना
अभी आपको नहीं यहाँ पे आगे बैठे उसके बाद दिया
मेरे को अभी मैं निकल जाता हूँ
हेलो प्रोफेसर सुनील हेलो प्रोफेसर जफर हेलो अभी क्या ऑनलाइन है हाँ वही
आ जाओ
हेलो
माइक पॉज कर
कितना लिखना भाई
कर रहा है
आएगा आएगा आ रहा है हाँ आप क्या बता
रहता है उसको क्या हम कर रहे हैं
यहाँ पे पहले भी हम जैसे यहाँ गए पोडियम के नजदीक
कभी ले लिया
हाँ
जो पोडियम के नजदीक रहेगा उसको ले लेना ठीक है तो तू ऐसे ही करना समझ करना बाकी जो पोडियम रहेगा तो आ ही जाएगा
हाँ
हो गया तेरा पोडियम लैपटॉप से करना है तो पता है तेरे को वायरलेस प्रेजेंटेशन कैसे करेगा देखना या तो इधर फोन से कोई करेगा विंडोज़ का लैपटॉप रहेगा ना
हाँ
तो क्या दबाएगा पता है देख क्या लिखा है विंडोज़ प्लस के दबाएगा
हाँ
ये दबा हाँ अभी देखिए AM वाला एयर मीडिया
हाँ
इस पर क्लिक करने का अभी इसके बाद ना उससे कोड आएगा तुरंत एक 5146 5146 5146 अगर मान ले तेरा ये भी बंद हो गया वो भी बंद हो गया तो ये तेरा रहेगा हमेशा के लिए। हाँ तेरा ये प्रेजेंट करेगा।
हाँ
और इसके लिए फिर तेरे को डुप्लीकेट स्क्रीन करना पड़ेगा।
डुप्लीकेट, हाँ
तो
वो तो पता है मेरे को, विंडोज़ पी होता है।
विंडोज
डुप्लीकेट है ये।
डिस्कनेक्ट एक्सटेंड
एक्सटेंड कर दो ना, एक्सटेंड कर दो, आ जाएगा साथ से। तो यहाँ पे अभी नहीं आया।
यही लैपटॉप कर रहा है ना ये?
हाँ यही लैपटॉप नहीं, यहाँ से यहाँ पता है हम वो मॉनिटर वो सिलेक्ट कर देते हैं ना, कंट्रोल रूम।
नहीं पोडियम लैपटॉप नहीं, रुक जा डुप्लीकेट पे भी नहीं आ रहा है।
हाँ
डिस्कनेक्ट सेकंड स्क्रीन ओनली। हाँ
सेकंड स्क्रीन पे आ रहा है।
करेगा ना तो आएगा।
हाँ तो फिर यहाँ से नहीं आएगा, वो वहीं पे ही दिखेगा।
विंडोज प्लस के वापस करना। तो बंद हो गया क्या लैपटॉप?
हाँ वो यहाँ पे नहीं आएगा अभी। अभी यहाँ से वहाँ पे आपको सिलेक्ट करना पड़ेगा, वहाँ पे जाके। हाँ हाँ
ये आया
अभी आ गया।
अभी क्या करेगा? इसको डिस्कनेक्ट करने के लिए वापस विंडोज प्लस की दबाएगा, यहाँ जाके डिस्कनेक्ट होगा। ठीक है, एक तरह ये ऑप्शन रहेगा। यहाँ पे देखो पूरा गाइड मिल जाएगा इसका। ठीक है, कंट्रोल रूम और पोडियम लैपटॉप जहाँ से करना होगा वहाँ पीपीटी लेना है उनको।
वो पता नहीं चला मेरे को, आपने लैपटॉप यहाँ पे भी कनेक्ट किया हुआ है बराबर, और वहाँ पे भी कनेक्ट किया हुआ था आपने
बराबर।
तो अपने वहाँ पे से क्यों पीपीटी शेयर करते थे?
यहाँ पे कैसे बीच में बंद हो गया। हाँ ऑफलाइन जब देखिए दिख रहा है ना, इसमें सब ग्रीन दिख रहा है। ये दोनों डिवाइस है ना, ये दोनों में से ना एक कभी रेड हो जाएगा या कभी ब्लू हो जाएगा, तो समझना क्या है।
ये अभी बंद कर देते हैं ना पोडियम माइंड।
पोडियम सबसे पहले इधर आ जूम करने में खाली करना है।
Hello. Yes, good evening, sir.
Am I audible?
Yes, clearly, sir.
Okay.
Okay. Sir, please share your PPT.
Okay. क्या?
अच्छा ये भेजो क्या?
So is the PPT also visible?
Maximize. Yes, correct.
Okay.
It's working all right. So you have to full screen, no problem. Full screen. Just a minute. You also check on YouTube Live. Okay.
स्क्रीन शेयर करके बस खाली दिखाएगा।
Yes, sir. It's working properly.
आवाज और कैमरा सब यही से
10 मिनट हो बोलो सर। हेलो
ओके हाँ दोनों में एक ही
प्रोफेसर सनी, हेलो।
तो यहाँ पे ऑडियो चैनल स्क्रीन पे
वो वहाँ से और यहाँ आगे दे दिया, दे दी। खाली चेंज हो रहा है, बोल रहा है उसका दोनों खाली इसको प्रेजेंट बोलना दो चीज़
तो समझ जाओगे।
बाहर से बोलूँगा
Uh, Thank you once again for joining us back after the break. It is my pleasure to introduce our next speaker, Dr. Shyam Sundar Mandyam sir, Vice President at the Indian Society for Non-Destructive Testing, Chennai. Dr. Mandyam is a highly accomplished innovator, researcher, and technologist with over 36 years of experience in the multidisciplinary field of non-destructive evaluation of materials, components, and structures. Sir is a co-founder, director, and consultant for multiple organizations including Palaki, NDT, InnoMantra, and Welltech. He has positively served as principal scientist at GE Research and IGCAR and hold certification as a Six Sigma Black Belt, TRIZ Level 3 and ASNT Level. His work spans various industries such as aerospace, automotive, power, renewable, oil and gas, defense, and nuclear sectors. Sir is a passionate about driving advancements in NDE 4.0 and has been pivotal in developing and implementing innovative technology solutions to address industrial challenges. Today, Sir will be delivering a talk on non-destructive evaluation and inspection of composites, trends and advances. His insights will provide valuable perspectives on the latest advancements and trends in NDE technology. We welcome you, sir.
Okay, thank you. I'll try to finish it. Very good evening to all of you and welcome back after the post-tea session. I'm going to speak on this topic, NDE and inspection of composites. Something different from what you've heard since morning, but I believe very essential in case you want to make sure that the quality of composite and the integrity of composites is maintained. At the outset, let me thank the organizers and especially Dr. Singh and Dr. Badeka, who invited me to participate and give this talk in this event. So thank you very much for that once again. As you can see, there are a long list of organizations below, which is all where I am part of. And as I go, I'll let you know in which organization I work on which technology. This is also an invitation to all of you because we've been talking since morning about collaborations. All of these are either startups or MSMEs or established organizations. So we would happily welcome academia and other research institutes and everybody to participate because we are working on some of the most latest technologies. Sorry. Okay, so obviously I'm standing here with total industrial experience of close to 40 years, and this did not happen unless I had the solid foundation. So I always like to acknowledge all my organizations, my school where I did my bachelor's, my PhD, and the two major organizations, Indira Gandhi Center, Kalpakkam, and GE Research, Bangalore, where I worked for a total of 37 years. Not working again. Okay. Okay, so in the interest of time, I'm going to be a little fast. It's going to give you a high-level overview of all the technologies which are in place today, and we are working with that. Industry is very vast, lots of different industries, lots of different materials, composites being one very important one. And I don't have to go into any of these. The huge number of application of composites, and hence you need to also have to obviously develop the inspection technologies to do. Again, not getting into the details, lots of this was talked about. But whatever be the material, it will eventually fail. And that is the biggest challenge which we all need to address. Engineering failures will keep happening, be it metals, be it plastics, be it composites, be it rubber, ceramics, take any material. In spite of all the advancements we have done, yes, there is still so much to do. And hence, in order to prevent such failures, it's important that we have proper technologies to do all the things. So what are the major causes of failure here? It's basically all the flaws or the defects, the material properties itself, and the loading and the environment. And if we have a method to characterize all that, we can actually get into very good materials. So our motto is, don't let bad things happen to good materials. Composite is such a wonderful and good material. We should not let bad things happen to it. And how do you do it? You can do it through the use of non-destructive valuation. Again, not getting into the details, but basically technologies which are aware, many of you are also familiar with it. It is a cradle-to-grave technology because it starts from the raw materials when the mining is happening till end of life, till you throw the part and scrap it. We use NDE at every single stage, materials processing, fabrication, product assembly, structure, even when it's also installed. And there are hundreds of NDT methods. We are not going to get into any specifics here. But then choosing an NDE method is not easy. You need to understand what you're inspecting, what is the material, what is the properties to some extent, what kind of flaws do you expect during the processing. Do you have access to the place where you want to inspect? If you take a large tank, you have access to the entire part of the tank, both ID and OD, when you're manufacturing it. But the moment it's installed, you have access only to OD, except if you clean the tank. And so, again, lots of different defects have been talked about, not getting into the details, but composite specific, anything during manufacturing is all about porosity, contamination, wavy fibers, ply, mislocated ply, improper cure, and the whole lot. And then many other manifest itself during in-service. Okay, so the type of defects we are trying to look for extends across this entire scale, okay, right from nano to micro to micro to... So the entire scale, you can see the kind of defects. If you talk about, voids, porosity, inclusions, it starts at nanoscale, but extends up to the macro scale. If you talk about something like more like matrix cracking, maybe it's in the micro and the meso scale. And if you go to something very particle imperfections in the nano composites, it's at the nano scale. So you're talking about a whole range of scales for which we need to develop the technology. And hence it becomes very important that we have a range of technologies. Why not one technology? Because it cannot do the job. So you have this entire range as the damage evolution happens in composites. You have this whole, and this is not the entire list, there's many more, which can do depending on at what stage you want. Because if you, like I guess the professor from IIT Gandhinagar mentioned about crack growth, etc. You're wanting to do it at the very, very micro scale, you have some method. As it goes to macro, probably some other methods can do it. And these are just samples of how causes of failures are there, the interlaminar porosity, in-plane waves, out-of-plane waves, matrix cracking, and so on and so forth. And so it becomes important to use NDE in two phases. One, at the quality control stage, to make sure that your quality of the composites you have laid up into whatever component is fully assured to the extent possible, because there are limitations in every ND method. And the second is, once you put it into service, you still need to do what is called an in-service inspection and make sure that you are making sure that there is no new defect which has formed, or if there was an existing defect, it's not growing. And so there is a whole list of techniques, as you can see, not again getting into the details, but some have limited applications, some have applications which are proven, and so you again need to use a combination of them. Again, this is just a sample table, this is not the exhaustive list. So what is the advances, which is what we wanted to really talk about, is all about newer ND inspection techniques which are coming, about modification of existing techniques in the way they get used, about hardware advances, sensor advances, software advances, okay, lots of signal image processing and data analysis by which you can get much more information from the data you have collected through the inspection, and of course, a lot of automation, semi-automation to fully automated with robots, drones, and all kinds of things which we can do today. Of course, nothing is today complete without suitable application of AI or ML in the automation of data analysis or any other things which it may be. And so if you just quickly talk about ultrasound, conventional ultrasound, lots of applications, very good for composites, one of the widely used, but it has its limitations. And that's when we came up with newer techniques called the phased area ultrasound, which is now so powerful that it can really do a lot of extra inspection at very low time. And you can do a lot of coverage. So again, just a sample shot here of what is called as time of flight diffraction. There are some which may not be applicable to composites, for example, the EMAT and so on, because it needs an electromagnetic thing, but it's still there. So this is how the conventional and phased area ultrasound, where you had to have several transducers to do cover a large thickness. Today, with the beam steering facility of PAUT, as we call it, beam steering and focusing, I can inspect a thick composite very easily. So here is a sample image of a phased area ultrasound of typically thick composite structures. You have things like roller probes, which you can just move around on the composite sample and get excellent images of whatever you're looking for. Here is an example of a wind blade where phased area ultrasound testing is being done on composites. Okay, so there are several applications, and you are probably the best judge of that, where you are not allowed to contaminate the surface. Typically, an ultrasound inspection needs a couplant, or you need water to be squirted on that. But there are so many aerospace and other applications where it is sensitive. I cannot put it in water. I cannot apply a couplant. And there you have the solution of what is called a non-contact or air-coupled ultrasound. And so again, lots of development in that. You can get fantastic images like you see, and you can do a non-contact ultrasound inspection of your entire composite structure. Here is an example of a CFRP pipe with an adhesion joint, and in the bottom you can see that wherever there is good adhesion is in blue color, wherever adhesion is poor is in orange color. So very clearly demarcating what it is likely to see. Moving on from ultrasonic to electromagnetic, which is the most popular method called eddy current testing. Eddy current has its limitation from composite standpoint that it can be done only on electrically conductive materials. And so only CFRP can be done. GFRP, you cannot use eddy current. But for that, you have other methods. So here is an example of CFRP, eddy current method, and you can see the small, crack initiated here about 5 millimeter long. Can be clearly imaged from both sides of the plate. Okay, and so going on, as you go in electromagnetic spectrum, you go higher up the frequency. Eddy currents work up to a few megahertz. You go into microwave, we go into several gigahertz. Okay, and so if you go into the gigahertz, you have something called microwave. So you impinge microwave on a composite body or a sample, and then you can get microwave-based images, which are extremely good for composite and ceramics and coatings and paints and many other things. And this is the good property. It penetrates insulators and dielectric materials. So again, a microwave cannot be used for CFRP. It can be very well used for GFRP and all other non-conductive ceramic coatings, etc. Non-contact, non-ionizing, unlike X-ray, it's non-ionizing sort of fast real-time, no couplant, and you can do a fantastic, and it's based on something called the relative permittivity of the material. So you can detect all this with microwave, lack of fusion, butt fusion, electrofusion. You have ASTM standards already also for that. Foreign material inclusions, voids, disponds, moisture or any other contamination. Microwave very excellent at detecting moisture and so on and so forth. So here are just samples. I don't want to get into the details, but microwave technology is available, can be applied on the field, on pipes, on weld joints, on anything with composites or FRP or HDP and any other things, and you can really get excellent images from the classifying all the defects and so on. More examples, if you usually have a composite wrapped pipes, that again can be inspected, even the corrosion on the pipe can be inspected from the composite layer outside by using this microwave technology, and lots of examples. So here is an example of how wind blade, using both far field and near field microwave, we can do a very good imaging by which we can even find a very, very small delamination, as you can see the image below. This was done by fusing data from near field microwave ND and far field microwave ND. And these are more examples of how microwave, you can see thickness measurement this is very powerful for thickness measurements. You can see how the wall loss, if there is a composite tank, you want to find out wall loss, anything which is happening because a liquid has been stored inside, you can really find it. You can also find wall loss, and this is just a calibration block. This is again an example of corrosion happening beneath the fiberglass or wrap on a steel pipe. So it can penetrate and very detect. Microwave will do 100% reflection from any metallic surface. So that is good and bad both in some cases. Here is more example of how a pipe wrap with artificial defects, you're able to detect all of them. Here, there is a rounded indication which is was created manually, and many other indications in this image which was actually carrying some liquid pipe. Here is an example of an FRP tank where a repair was done, and this is the repair of the inside of the FRP tank. And here is a microwave scan of the FRP tank from outside, which was done. And you can see very clearly all that, including that white holes where after repair, the liquid started penetrating further. Here is an helicopter blade thing where many times the backing paper gets left and which can become a big cause of delamination. And again, microwave has been able to do this very, very effectively. So here is again some more images, skip in the interest of time. Okay. And then we move on further up the electromagnetic spectrum and we go into terahertz, which is like 1000 gigahertz and above. Okay. And there again, it has almost all the properties of microwave with still higher resolution. So there are applications which you need like 10 micron, plus minus 10 micron wall thickness measurement. Terahertz is the answer. When you want, say, something like plus minus 50 to 100 microns, maybe microwave is the answer. So here again, terahertz is nothing but another form of radiation. Important thing, non-ionizing. So unlike X-ray, it does not harm the human body, and so you can use it very, very effectively. And it has a huge number of applications. I won't go into that, but composites and coatings are one of the biggest users of terahertz. NASA, when it had its first accident with Columbia, the thermal tile fell off. Terahertz was the technology. From that day, they have been using to ensure that the foam is, characterization is done using terahertz. So that's the same, technology here. These are just some examples of, composite inspection, delaminations and different things, comparison between different things. Terahertz was not on the list for long years, but in the last 5 to 7 years, you can see terahertz also on the list. And this number of yellows are slowly becoming greener and greener. So it has better power and all. So you can really do a fantastic imaging of any structure you want, though a little slow, but very powerful. And in GFRP samples, this is again something, a GFRP sample, you can see the image of certain delaminations which have been seen. Some more defects and cracks in GFRPs, internal voids, GFRP. So virtually, anything, you just need to have a calibration and then you can decide what is your ability to pick up. Moving further, that was all about electromagnetic in that domain. Then we can talk about infrared imaging. Again, a very, very powerful non-contact technology where the surface heat mapping is what gives you an indication of presence or absence of a defect. And so, fantastic thermal cameras today available, very high resolution down to 0.1 and 0.01 degrees centigrade, which means very fine and finer defects can be actually used. And it has huge number of different applications, as you can see. Again, not getting into the technical details of this, but within infrared, there are so many technologies which can be used just to do the heating and then natural cooling and collecting the images. And then you can see again, CFRP sheet with impact damage, honeycomb panel with delaminations, and a whole lot of things. So infrared again is compared to, I would say, microwave or terahertz is much more mature, but it has again its own limitations. And as I showed you in the first table, we have to work with multiple technologies. Again, infrared imaging, some more images here which you can see at different time shots as the cooling happens on the panel. You can take those time shots and really as you go to 146 seconds, as you can see, all the 3 defects are very, very clearly seen. So there are lots of developments which have happened. We can always talk about it offline whenever who is interested. Moving to X-ray. Again, X-ray has come a long way. You always used to do film-based X-rays, but we have now moved to what is called as computed radiography and digital radiography, where using flat panel you can image instantly. These are unfortunately not examples of composites, but this is the kind of image you'll get through a digital X-ray and instant, just like your the photo you take with your cell phone is what this does and gives you an image. And here is some image of a micro CT slide showing internal fatigue in a CFRP coupon, and that is a mobile CT of a fiber composite shell, okay, of a vertical tail plane. So both conventional 2D X-ray and 3D CD is being used extensively for composite materials. Again, some more examples in the interest of time. Skipping that, laser shearography, another very, very strong method for composites. Okay, it's based on the principle of the shift in the planes, and it needs an applied stress. It could be a thermal stress, it could be an acoustic stress, or it could be vacuum. If you apply any of them, the change on the surface of the material manifests itself as something called a shearogram, and we are able to detect these kinds of defects as you can see here. Everything from porosity to wrinkled fibers to impact damage, and many other things can be detected. And this is a technology which is already used extensively. ISRO uses it quite a bit. Of course, the wind blade industry is also using, as you can see here. It's a compact equipment. You can go to the field and you can actually do on the wind blade measurements and all this. And I can vouch for this because we have done that while we were at GE. Moving on, digital image correlation, another big popular method for the composite industry to find out whole field strains. Okay, when you want to really figure out the very sensitive change, and the strain values, you can do this by spraying a paint on that, and then by speckle paint on that, and then figuring out the image correlation between before and after loading, which is very sensitive and can give you a full view strain mapping of your object. So again, just another, we saw one table earlier. Now you can see this has got a lot more methods, including shearography, DIC, and all that. So developments have taken place, and today we have choice of technologies which you can use for inspecting your composite parts. From there, we move to something called, this is all inspection. Now, what we are looking at is inspection happens at regular intervals, which means you have to either, when the plant is shut down or any other place, at regular intervals it happens. But you want, today the aerospace structures and many other structures, including the wind blades, would like to have a continuous monitoring. And that is what we call as SHM or structural health monitoring, where you embed the sensors. It could be a fiber Bragg grating FBGs, or it could be a piezoelectric sensor. And you can, again, continuously monitor that over a long period of time. And so, what are the SHM techniques? You can see here, lots of different things, elastic waves, electricity and magnetism, and all of them can be used but currently the most popular are FBG and piezo. These two are the most popular sensors which are today already being used. You may not find a whole lot of practical use cases, people who have tried it out, but there are several people, because this is such a fantastic tool that at any given time I will know the health of my component, be it an aircraft wing or any other structure. If I had the SHM inbuilt, I can monitor it continuously, or at every time the flight lands and so on, and really find out whether it has accumulated any excessive strain and so on. So, just like those were a set of technologies which have become so advanced in so many different ways, and I have just covered the tip of the iceberg given the time constraint, but there's so much in each one of them which you can go deeper and find out how to do it. But what is also happening is the digitalization which is happening around the industry 4.0 is also catching on with the composite industry in its own way. Everything from, today we have robots which have ultrasound and terahertz, both, and then you're doing a full wing scanning, etc. You can put virtually any sensor which I talked of earlier, almost all, if not some, which you can do and do completely robotize the inspection of large areas and where large volume is involved. And of course, that also helps you to get more data. The moment you have more data, you can also extract more information. And then eventually you may want to build something called the digital twin of the structure, which you can continuously monitor and look at it. So be it a wind blade, be it any other part, almost all of these are in some form or the other. You can see that picture there where drones are getting increasingly used to inspect the composite blades on top of the wind turbine. Okay, bringing a blade down is a very expensive affair, and you just want to quickly have a visual check or an infrared image to see whether it's good or not. You can fly the drone, get the image, and then figure out if there is an issue, bring the blade down, or if you can have the operator climb up and do the repair locally, he can do that. But that's the thing. So robotics in the case of factory inspection and drones in case of field inspection is something which is catching up. Lots of different scanners, because we are dealing with complex shapes, aerofoil shapes and all that. If you want to do a good inspection, you really have to have all kinds of different scanners which can take care of these complex shapes. And this is just an example of how AI was implemented on a phased array UT image to actually automate the entire defect detection process from gap to lab, embedded defects and wrinkle. So this was something, one example. There are several such examples of how AI has applied. And AI becomes more and more helpful when we are going to more and more advanced techniques, because we do not have the operators and the skill to run many of these kind of advanced techniques, especially including phased array ultrasound. And so if you take the help of AI for at least what we call as ADR or ADA, automatic data analysis or automatic defect recognition, then you can also do this. So this is one of the powers of digitalization which is there. So in short, ND can be for so many different things in the composite industry, right from the design of composites, okay, where you can measure the elastic moduli, so also brought up in one of the discussions, and the design for inspection using simulation tools. Whether can I inspect that object at all? How do I know? So, you can really do a design of composite, because today you have to focus on design for inspectability. Like today morning, there was a discussion on design for environment. Equally important is design for inspectability. You make a nice, good component and I cannot inspect, gone. How do I know when it's going to break and fail? So design for inspectability also comes from here, design of composites. Process monitoring, you can do the entire cure monitoring and many other applications through many, completely non-destructive in nature. Okay, you can do that flow density, temperature, etc. I mean, lots of sensors, lots of things are there. ND for fabricated parts and in-service inspection, which is what we talked about. Okay, we can use wide area sensors, like I told you, phased array ultrasound and many things, which can cover larger area. So even if you have a large structure, you can do it in very shortened time. And hidden region inspection, etc. Structural health monitoring, we already talked about that for damage monitoring and damage prognosis. So combine these with the finite element models on the strength of composites, etc., and you can do a damage predictive analytics of that. So with that, I would like to thank you. I know I did it very fast in the interest of time and many things. What I just wanted to end was to say that, like I mentioned, most of the technologies, almost I would say every technology which I talked about, I have personally worked with them in the last 40 years in some way or the other. Currently, we are developing the air-coupled ultrasound as part of the startup called Aziriri, which is in the IIT Madras Research Park. We are developed the terahertz technology, which is a part of the TerraLumen solutions based out of Chennai, and that is going. And again, just for your information, TerraLumen is India's first terahertz company, and exactly 1 week from now, on the 17th of August, we are launching our first product in Chennai. So that is a thing. And then, of course, if anybody wants to get connected, talk more about all the technologies, what it can do for you, please get connected with me on LinkedIn. Thank you very much.
Thank you, sir. So any questions from the audience?
So if you do during the this is called process monitoring. See, everything, there is a process. If you can detect any flaws or faults much before the final component form, because once the final component is formed, you cannot do anything. Okay, you have to, in case of metal, we just at least melt it. In case of composite. So here we can monitor the process of curing itself. As curing is happening, we can see what is happening and then make decisions on whether you want to continue with the process or change it.
What is the way to look into that? Because we have a closed environment, chamber is closed, our parts is closed, it is under vacuum bagging, all the conditions are closed, we cannot visually inspect it. How the ND will help us to investigate that something is happening in curing which is deteriorating of the product property and so on.
Yeah, so sometimes when if we do not have the high temperature sensor which can be put inside the furnace at autoclave at the temperature at which you are doing, then it becomes difficult for that particular process. But in general, it can be done. Each case has to be studied specifically, and we have to determine whether cure monitoring can be done for that or not after knowing the full details of the process, temperature, viscosity, flow, and everything else. And for each of them, we already have sensors which are developed, say, at IIT Madras, who can really monitor everything and give you all the information. Somebody there. Yeah.
So
I have a question. So basically, I have been working with this acoustic emission sensors and PJT patches, right? So the thing, like one of the challenge which I am facing right now is, let's say, as you mentioned, we wish to cover a long distance pipeline, or you can say like when we wish to cover huge structures, right? So usually this acoustic waves, right, they suffer from attenuation, right? And as well as, let's say when we acquire this data using some data acquisition or something, that sort of system, so there is huge amount of surrounding noise. Right? So I just want to know that how industries are actually tackling this challenge, specifically if we talk of long distance pipelines or maybe let's say some huge composite structures. So do we have any solution to avoid that?
You mean that you're talking about noise?
Noise as well as, let's say, the attenuation of the waves with distance. For example, let's say if I talk of pipeline, the AE sensors, the maximum they work perfectly at a distance of, let's say, 2 to 3 meters from the effect location, right? Then beyond that, they start diminishing. Basically, their strength is lost, right?
So we today have crawlers which can actually do a pipeline scanning, on which you can mount these things. You know, we have had for wind blade, I recollect several years ago itself, we had mounted it on a full track, and as of course it was on the ground, the wind blade was there, and we entirely moved the infrared camera and imaged the entire adhesive joint between the two halves and all that. So I think this is more, in my opinion, more of a mechanical challenge of how to design your scanners to get best optimal maybe speed and coverage. Other than that, I think the sensor will do its job, is what I believe.
Usually the sensors which I am using, they are directly mounted onto the pipeline surface.
Oh, okay.
Crawlers, in a way, like
okay.
they are good when you use.
Yeah, so I mean, so that is, there is really no solution to that, because if you have an embedded sensor, it can only monitor that area and where it has its influence, right? So you will have to place more sensors at regular intervals. That is the one. So that is where you can use or try to use an alternative technology which probably can solve your problem. I gave you a list of at least 6 to 7 technologies, and there are at least another 6 to 7 more, which are all mature, close to maturity and so on, which may be able to solve your problem. So rather than fixing your solution which you are approaching, maybe you need to take a step back, in my opinion, and see what is it that I am doing, and can an alternative technology do what I am looking for. But the moment you put a sensor on, nothing. You can't do that. You just need so many sensors, which is impractical. Or you can do a condition monitoring of that surface or pipe using acoustic emission, which
having certain limitation, like
exactly. So we have to work through those solutions to find the right technology, which can happy to help in whatever way you get connected.
Thank you.
Now I would like to invite Professor Shyam Gurav sir to felicitate sir. Okay, so our next speaker is, it is pleasure to introduce Dr. Sunny Zafar, who will be speaking on manufacturing and recycling of advanced structural composites using microwave energy. Dr. Zafar research interests include microwave materials processing, surface engineering, experimental tribology, advanced welding and manufacturing processes, materials characterization, and the mechanical behavior of materials. Sir earned his PhD in mechanical engineering from IIT Roorkee in 2016, where his thesis focused on the development of nanostructure wear-resistant surfaces through microwave cladding. He also holds an MTech in Mechanical Engineering with a specialization in Welding Engineering from IIT Roorkee and a BTech in Mechanical Engineering from Punjab Technical University. Sir talk will delve into the innovative use of microwave energy for the manufacturing and recycling of advanced structural composites, a topic that promises to offer valuable insights into modern materials processing techniques. So, sir will be joining online for this.
Yeah. So thank you so to deliver manufacturing and recycling of advanced composites using microwave energy. At the outset, I would like to thank the organizers of this important conference, especially Dr. Singh, who has been pursuing this conference since very long time. So I'm basically presently working in IIT Mandi as associate professor in the School of Mechanical and Materials Engineering. So before we go into the details of the topic, so I would like to have acknowledgements to my students who have worked extensively on these topics and my colleague Professor Venkat Krishnan, who has supported me a lot in like working on recycling part. So many of you may be knowing about IIT Mandi. I'll just take a minute to introduce to people who don't know about IIT Mandi. So IIT Mandi is one of the second generation IITs. So this IIT is located in the district of Mandi in Himachal Pradesh. And the campus of the institute is spread over 520 acres in these forested hills of Kaman Valley in near the Mandi town. So we have this very picturesque campus, and we have the campus situated at an approximate altitude of 3,000 feet, which is the only IIT into the mid Himalayas here in India. And from here, we are working on this area of designing and manufacturing composites for advanced structural applications. So in my talk today, I will be just going through this overview about composites, largely what is the application, and then how we are actually manufacturing the composites using microwave energy, and also how the microwave energy has been utilized to basically recycle the structural composites and how we have recovered back the fibers. So that will be the brief outline about my talk. So as we all know that composites, just a little bit of background, composite materials we know are consisting of two or more materials which combine macroscopically. And the combination of these two materials at a macroscopic level, it yields several useful properties, which are of course very unique to the combination. And composites, they offer a lot of advantages like high damping property, long service life, and several improved mechanical properties like stiffness, flexural strength, impact strength, corrosion resistance, and so on. So here we are talking about advanced structural composites, and we all know that in advanced structural composites, the choice of reinforcement is mostly restricted to glass fiber and carbon fibers. And if I talk about the matrix, so popularly epoxy and combination with any hardener is the choice of material as the matrix here. And utilizing the combination of these reinforcement and the matrix, and then applying heat or pressure using different means, we are able to generate several components as shown here in the slide. Now, these type of components, they find wide applications in several sectors, which include aerospace sector, not only commercial, but also military aircrafts. The renewable energy, especially the wind turbine or the wind energy, utilizes several composite materials to make the blades of these wind turbines, which are very huge blades. And as we are progressing in development of new materials and manufacturing processes, the size of the blades are even getting larger. So the other important component or the application of the composites is in the electric vehicles. So nowadays there is a lot of focus on electric mobility, and electric vehicles, they offer a promising solution to the electric mobility. And all the structural parts of the electric vehicle sooner or later will be made up of polymer composite materials, where they will offer lightweight, high strength, along with sufficient passenger safety. And the advantage of utilizing such materials in electric vehicles is that we can have longer battery range, and at the same time, the performance of the vehicle, structural performance of the vehicle is also not compromised. So with these important applications, futuristic applications, we see the basic manufacturing processes for composite materials. So essentially, the manufacturing processes for composite materials is revolving around what type of the matrix is being selected. So popularly in composites, we use both thermosets as well as thermoplastics. But for structural applications, it is the thermosets which are widely used. And we know because of their permanent crosslinks which are developed upon curing. So they are very good in several structural applications, as some of the applications I just highlighted. So here, in general, for making any composite, we are utilizing these 4 steps, which include impregnation, layup, consolidation, and solidification. So the innovation that we have provided here is in the consolidation and the consolidation step, because in general, any of the manufacturing technique that I just highlighted in the previous slide here, these all utilize heat or pressure in some form or the other. But the innovation that we have brought in here is in the heating part, especially in the consolidation stage, that when we provide heat, so in this case, we are providing heat using microwave energy. So now there are different ways to produce heat, and these are some of the known ways by which we can produce heat. But there is this microwave is also a very popular heating source. So as we know, microwaves are electromagnetic radiations with a frequency over 0.3 to 300 gigahertz. Originally, microwaves were invented for communication purpose. As you can see here, they were used mostly in radar and so on. But for industrial heating purpose, it is some of the frequencies are reserved for the industrial heating, which include 433 megahertz, 900 megahertz, and 2.45 gigahertz. In context of India, it is 2.45 gigahertz, which is allowed to function for the heating purpose. So you can take any microwave manufactured in India, be it domestic microwave or commercial microwave, the magnetron will be functioning at 2.45 gigahertz. I'll come to the meaning of this 2.45 gigahertz in the next few slides, and then this concept will be more clear. The wavelength of microwaves, it is in the range of 1 millimeter to 1 meter, and these are non-ionizing covalent polarized electromagnetic radiations, which can be readily transmitted, absorbed, or reflected, but it depends on what type of material they are being exposed to. So I will discuss some of the classifications in next few slides. And as it is an electromagnetic radiation, so it has both the electric and magnetic field orthogonal to each other. So in this regard, we can see the difference between heating profile with respect to conventional heating and microwave heating. So in conventional heating, as we know, the heat is transferred using conventional sources from the source which is surrounding the target. So there's a big circle indicates the target, and the surrounding these 4 circles, they indicate the source. So in this regard, we can say that heat transfer is dependent on the conventional modes of heat transfer, which is essentially conduction, convection, or radiation. Because of this, what happens, the surface of the material, it tends to be relatively at higher temperature compared to the core of the target material. But in microwave energy, actually there is no heat transfer, rather there is energy conversion. So now this energy conversion is dependent on the dielectric properties of the exposed material. So here the microwaves, which are indicated by these blue waves, come in contact with the material. Depending on the dielectric response of the material, this microwave incoming energy is converted into heat. And this conversion into heat is so rapid that it heats up the material very fast. And because of this, we have significantly observed that there is sometimes an inverse temperature profile. So what I mean by inverse temperature profile is that the core of the material is at much higher temperature compared to the surface, which is exactly opposite what we observe in conventional heating. So this unique heating capability of microwave, along with the speed at which it can heat, offers several advantages in material processing. And here is one use case for advanced structural composites that I am highlighting. So in microwave, we can say that it is energy conversion and it results into volumetric heating. This is another important characteristic of microwave, that it is the whole volume of the material that gets heated. It is very common, if any, like most of us, we use microwaves in kitchen for heating food. And we can observe that in a matter of 30 seconds, a food item at room temperature suddenly becomes so hot that we cannot even consume it. So from there, we can understand how fast microwave heating takes place. So then next question arises, what are the advantages of this microwave heating? So microwave heating is cost saving because it saves a lot of time and energy. The equipment cost relative to other equipment may be relatively lower. And the process also offers volumetric and selective heating. The process is also environment friendly as no emission etc. are there, and we can yield a very good quality properties in the materials which are processed. So we understand the mechanism of heat generation in microwave. So essentially in microwave, the heat is generated by either of these two mechanisms, which is polarization and conduction. So polarization basically involves short range displacement of charge. So in this case, all the dipoles which are present in any material, they try to align themselves with the incoming wave. So incoming wave is an alternating wave because it is an electromagnetic wave. And since this frequency at which polarization takes place is 2.45 gigahertz, so this results in approximately 5 million cycles of rotation per second in these dipole molecules. So this high number of rotations in the dipole molecules essentially generates a frictional heating inside the material, which is manifested in terms of heating, or we can say rise in temperature. On the other hand, we have ionic conduction, which is long range transport of charge. And in this case, the oscillation of ions takes place relatively at 915 megahertz, which is a lower frequency. But for sake of our discussion going forward, we will be focusing more on the polarization part, which occurs at 2.45 gigahertz. As I already mentioned, because this is the frequency which is reserved for industrial heating using microwave energy in India. So, as I mentioned earlier, microwaves are basically very selective to the materials they interact with. And this selectivity comes in from the dielectric response or dielectric properties of the material. Some materials, they have a very high dielectric loss factor. So in that case, the interaction is much higher. And in other materials, the dielectric loss factor may be much less. So based on this, interaction of the microwaves with different materials, so essentially materials can be classified in 4 types, which includes transparent materials, opaque materials, absorbing materials, and mixed absorbers. So transparent materials are basically those materials which do not interact with microwave. So microwave can just simply pass through these materials. So all the materials such as Teflon, quartz, ceramics, alumina, etc., they come in the category of the transparent materials. The second category of materials involve the opaque materials. In the opaque materials, we know all the bulk metals are opaque because they reflect microwaves. So as we know, in any domestic microwave also, it is not advised to put in any metallic objects such as spoon or fork because there is possibility of arcing which can damage the applicator. Third are the absorbing materials. So materials, for example, water, silicon carbide, charcoal, epoxy, all these come in the category of, you see, absorbing materials. So absorbing materials, basically they interact with the microwave, they absorb microwave, and consequently the heat generation is taking place. A very common example of absorbing material, water, it is present in almost all the food items. So that is why all our food items, they get heated in the microwave very quickly. The last category is the mixed absorber, where we have the multi-phase materials, for example, the composites, the polymer matrix composites, or metal matrix, or ceramic matrix. So in this regard, it is either the dielectric behavior of the, say, matrix or the reinforcement will decide in the end that how much heat will be generated. In some cases, it might be that the matrix is absorbing more microwave than the reinforcement, or it can be the vice versa case as well. So I'll just present some case study here, what work we have done in manufacturing of glass fiber composites. All the work has been done on a lab scale to present the demonstration, to demonstrate the capability of microwave energy to develop such composites. So glass fibers, as we know, they are also used in several structural applications. And for doing this work, we have utilized an industrial microwave applicator in our lab, which is coupled to a vacuum bagging system, coupled to this vacuum pump and so on. So for the sake of comparison, we have also developed similar composites using thermal heating or the conventional heating using a thermal oven. And of course, the same vacuum bagging arrangement was connected to the thermal imaging as well. Sorry, the thermal based setup as well. So in this regard, what we have done, we have demonstrated the use of micro energy to develop composites utilizing unidirectional E-glass fiber in a ply orientation, as mentioned here. So it was a symmetric ply orientation with almost 10 plies as reinforcement. The epoxy that we have chosen was bisphenol A with polyamine hardener, and it was mixed in the ratio of 100 to 32 as specified by the manufacturer of the epoxy. And we can see here that in microwave, what we have done is we have performed the manufacturing, or say curing here, because this is a thermoset, at different power levels starting 180 watt, 360, 540, 720, 900 and 1100. So at these various power levels, we could also get the cure cycle time, which was of course here measured in seconds. And the experiments were repeated almost 5 times in each case to get the repeatability of the data. The experiment was also conducted using thermal curing at 2000 watt, and here you can observe the cycle time was almost 8100 seconds. So the idea of introducing seconds is because in several cases in microwave, it is a few seconds, a few hundred seconds what it takes to get the job done. And now to understand the mechanism, how curing takes place when we expose such composites to microwave. So what we have done here is basically we have tried to utilize a vacuum bagging arrangement coupled to a mold which is made up of Teflon. So Teflon is chosen here as the mold, unlike metallic mold chosen in other manufacturing processes, because Teflon is basically microwave transparent. On top of it, we have put in the vacuum bagging arrangement. This is the industrial vacuum bagging arrangement as utilized in other manufacturing processes. In the similar arrangement, the epoxy is brought into as the vacuum is developed in the vacuum bagging arrangement. Now here epoxy is again unique because epoxy molecules are also polar molecules, and polar molecules are very good when they interact with microwaves. So as we know, epoxy is one of the popular matrix used in structural composites, as no byproducts are generated during the curing of epoxy, and it is widely used in several applications. So that was another motivation of utilizing epoxy in this case. And as the epoxy molecules, they interact with the microwave, the curing sets in because the hardener is already mixed in. And because of the volumetric heating or volumetric interaction characteristic of microwave, we could observe that curing can take place in this amount of time, as shown in this table here. So based on this, we also did some characterization of the composites which were developed in terms of the density, theoretical density and void volume fraction. So what we observed that at different microwave powers, that is 180, 360, 540, 720, 900 and 1100, the density was almost comparable to the theoretical density. Of course, every time the experimental density in any process is less than the theoretical density, it is because no manufacturing process is perfect, and there may be some incidences of being some voids or discontinuities inside the composite, which results in a lower experimental density compared to the theoretical density. The void volume fraction was also calculated using this data, and say at optimized microwave exposure, say at 540 watt, so a void volume fraction of almost 3% or less than 5% was observed. So this is similar to what was observed in thermal curing, but what the point I'm trying to make here is the cycle time what was there in thermal curing was very high. It was almost 8100 seconds, and in microwave, say at 540 watt, it was almost 720 seconds. So we can see this fast cycle time has resulted in not only better quality composites, but is also helped in saving a lot of time and energy. So other than this, the extent of curing was also estimated using glass transition temperature. And what we observed at 540 watt cured samples, the glass transition temperature was almost much higher, and glass transition temperature here is basically similar to what was observed in the uncured epoxy. So here is comparison of the cycle time, and we can say that with respect to the thermal curing, that is T2000 at optimized power at say 720 at microwave exposure 540 watt, it is almost 11 times less what is observed with the thermal curing. Even we investigated some of the mechanical properties of the developed composites in terms of tensile strength, ultimate tensile strength and flexural strength, and we observed that better tensile strength was observed at optimized microwave exposure of 540 watt, and it was significantly higher than what even was observed with thermal curing as a conventional manufacturing process. And similar trends were also observed in flexural strength testing. So next we estimated the energy consumption during the manufacturing process, which is of interest to many industries. So of course, this was done on a lab scale, but we installed the energy meter in series to the both the applicators, that is the microwave as well as the other thermal based applicator. So we calculated the energy consumption based on the both theoretically, that is multiplying the power and the cycle time, as well as the actual energy meter data. So here we can see that energy meter data with respect to microwave is not even crossing 1 kilowatt in our case, but it was almost 5 kilowatt for the same size of sample developed using thermal curing. So from here we can estimate that by utilizing microwave energy, we can not only save time but also save on a lot of energy costs, but at the same time we are generating composites with similar or maybe better mechanical properties. So the conclusion of the process that we have here proposed, which we call as vacuum assisted resin infusion microwave curing, has resulted in higher degree of cure. At the same time, mechanical performance was better, and cycle time was also reduced by and energy 11 times. Energy consumption was reduced by 33 times when we compared it with the thermal curing. So next I will talk about how we have used the microwave energy for recycling. So as I've discussed, there are several applications where composites are being used, and their use is going to get even more, because if you look at the compounded annual growth rate on utilization of composites, so maybe in the coming decade or maybe next 5-7 years, it is going to grow at maybe for 6% for carbon fiber and 7% for glass fiber and so on. And the sectors which are widely going to utilize the composites include aerospace, automobile, and wind turbine, as we have discussed earlier. Now, what happens that we are making a lot of products using composites, but what happens once these products they reach the end of their service life? So we are already struggling with dealing with plastic, simple plastic waste, single-use plastic waste, and in coming time the waste generated out of polymer composites is going to add more to that problem. So in terms of recycling, we already know that in metals, recycling is pretty straightforward. Like we collect all the scrap, we melt it, we subject it to some industrial casting process, and then we can reuse it. But what to do with composites? So if you look at estimates of 2050 from this research paper, so it is estimated that globally the carbon fiber waste of the order of 483 tons, glass fiber of 2.2 million tons, and approximately this much amount of waste is going to get generated in next 2 or 3 decades. So we need to do something to manage this waste. Presently, what is happening that we are although trying to minimize the waste by reducing the size, reusing it, reducing the waste, recycling process, and repair. But recycling of fiber reinforced plastics or composites is a tricky affair because of these multi-phase properties that we are talking. So we have a fiber, we have a matrix. So how to at least recover one of it? So that becomes quite challenging. And presently, recycling, what is being done, recycling of these type of components or these type of materials is presently done, but most of it goes into the landfills. And because of the landfills, there is huge environmental impact of these landfills, because they are also generating several greenhouse gases and so on. And we know, since these are made up of thermosets which are cross-linked, so they almost do not decompose in the environmental conditions. And they also release several harmful chemicals into the air, but also chemicals may be released in the groundwater and so on, which is going to have a negative health impact on the population. So in this regard, the recycling efforts in FRP have been done in the past, are also currently done using several means such as mechanical, where short fiber are generated by the recycling process on an industrial scale. In this case, basically we shred the composite part to develop these small pieces, but nevertheless we are not able to separate the fiber and the matrix. Thermal methods have also been used but they result in reduced mechanical and physical properties, and often installing such a facility is having quite heavy investment and has a long cycle time. So pyrolysis and all those processes, they come in the category of thermal based processes. Next are the chemical based recycling, where we have seen that setup cost they have high setup cost, and on a lab scale they may be able to generate good fibers, recycled fibers with clean surface and comparable properties. Then we have microwave pyrolysis. Some results have been utilized where we have energy efficient process with short cycle time. And combining these two, we have proposed the process of microwave assisted chemical recycling. So what we have done in our process, basically we have combined the microwave action and chemical action together in a hybridized process, which we call as microwave assisted chemical recycling. So in this process, again, we are utilizing microwave energy, but in this case, the chemicals which are used are derived from green chemistry approach, which include hydrogen peroxide and acetic acid. So what we observed once we subject the epoxy, the glass fiber based composites, the same glass fiber which we have manufactured in the previous case, the same samples when exposed to this combination of chemicals and then immersing it for 30 seconds at room temperature and then subjecting it to microwave, a domestic microwave for a few hundred seconds. So we could dissolve the epoxy out and we could recover the fibers back after cleaning it with acetone. So what we have done in this work, we have used microwave power of 700 watt for recycling and exposure time of 3 minutes. With the combination of this ratio of chemicals, that is the green derived from green chemistry approach, which is the hydrogen peroxide and acetic acid. So because here the acetic acid acts as a mild acid, organic acid, while the hydrogen peroxide, it is a strong oxidizing agent. Under the influence of microwave heating, so localized superheating occurs, which basically melt or dissolves the epoxy, and we can separate the fiber from there. So we also proposed this, plausible reaction, how the these chemicals under the influence of microwave, they are able to break the crosslinks and epoxy back. And this is already published in reputed journals, international journals. So we also looked at the decomposition efficiency in our case. So we looked at under specialized optimized conditions, decomposition efficiency of approximately 97% was achieved. And we also compared it with the virgin glass fibers, that is the unrecycled glass fibers. So similar type of the TGA results were obtained. So we also conducted the mechanical performance on single fiber tests. So like we extract the single fiber and then we conducted the mechanical test to get various insights into mechanical performance like ultimate tensile strength, Young's modulus, and strain to failure. So at optimized conditions, say RGF 4, 5, 6, we could obtain almost at par properties with the virgin glass fiber. So here comparison was done with the virgin glass fiber, and we conducted the recycling at several combinations which are already published in scientific literature. So we also conducted some scanning electron microscopy on the recycled fibers. So at unoptimized conditions, we observed that epoxy is still present on the surface of the fibers, but at optimized condition like RGF 4 and 5, so almost clean fibers with no damage were recycled back from the process of microwave assisted chemical recycling. So what I can conclude is that microwave assisted chemical recycling is starting a new paradigm in recycling the fiber reinforced plastics, and with all these attributes, it could be one of the promising processes in coming time. And in context of India, the recycling of FRP waste has to be taken up, as very little work is presently going on. We are already struggling with the single-use plastic, and if we utilize, some industry can utilize this type of process, it can help to create new jobs and promote sustainability, because not only we are recycling back the fibers because they are expensive. And what is not presented in the slides is that the same process has also been utilized and demonstrated to recycle carbon fibers with the same methodology. And carbon fibers are even of more interest to the industry to recycle because they are the most expensive fibers to manufacture. So all these benefits are there, and of course this is an innovative work which is a transdisciplinary work between a chemistry person and a mechanical engineer, and you can understand at IITs using this transdisciplinary approach we can solve real life problems. So the work we have done is not like, I cannot say it is a perfect work. We have done it on a lab scale. So as of now, there are still, the process is not implemented widely on a commercial scale, which has to be investigated further. The technology that we are utilizing is on a lab scale. So of course, the investment cost is not that high. But of course, if some industry wants to scale it up, there may be high investment cost, because for commercial scale, large scale microwave manufacturers are not available in India as of now. and there is very limited regulatory framework available which can be, create certain uncertainty with investors in coming times. But I'm sure by talking on these type of emerging topics, futuristic topics, we can of course overcome these type of limitations and improve the capability of the country to recycle fiber reinforced plastic waste. So this process has actually, we have already filed an Indian patent, and the patent has already been granted to us on this process. And this process actually had a lot of traction in the media when we first published in 2022. So almost two years back, we published this work in reputed international journals, and from there, several of the these media bodies approached us to just highlight it to the general public. So these are some of the references which other references being used in the current slides and have been used. And with that, I wind up my talk. If there are any questions, I'll be happy to answer. Thank you.
Thank you, sir. So any questions from the audience? Yeah, please. Would you like to ask? You can speak from there itself.
So like, you speak little louder.
A little louder.
I'm a first year physics major, so I have theoretical questions.
Yeah.
So you can go there.
Yeah, you can come here. So just a second, participant is coming.
No issues. I am sure. Yeah.
Good evening, sir. I'm a first year physics major, and so I have two theoretical questions. So the first question is, you said that in case of microwave heating, the materials get the inner core of material is more hotter than the surface. I want to ask why. And the second question is, why some materials like Teflon are microwave transparent? Thank you.
Yeah, I think these are quite good questions. So I will answer one by one. So the response to your first question is what happens in microwave heating. It is the core of the material or the volume of the material which first starts to interact with the microwave, and energy conversion takes place. So it is often observed theoretically that it is at the core because there are minimum heat losses. So because of that, there is high temperature at the core compared to the surface because of the energy conversion. And then coming to your second question, it is the atomic structure, the molecular structure of these certain materials which render it to transparent to microwave. So this is very simple to understand why glass is transparent to visible light and why ceramic is opaque to visible light. It is all on the atomic structure of these materials which render it favorable for microwave, or maybe in glass it may be favorable for visible light because they are interacting with electromagnetic radiation at different frequencies.
Can you please explain a little what type of structure does Teflon has to?
Teflon, if you understand, Teflon is basically a polymer, and it is basically having long chain molecules which are entangled together. So entangling of these long chain molecules basically renders very difficult for the molecules to basically vibrate in terms of interacting with the incoming wave. And this is also true for not only Teflon but several other plastics. But Teflon is also stable at high temperature. So these long entangled polymer chains, they don't allow the molecules to vibrate freely, because of which they don't experience rise in temperature.
Sure, sir. Thank you.
Yeah, please.
Yes, Sangvi. You measured or compared the toughness of microwave or.
Can you please repeat? I did not get your question.
You evaluate toughness of microwave composites.
Yeah. So toughness, we have we have done all the investigation on lab scale. So using an ISO impact test, we have evaluated the toughness. So although I have not presented any data on toughness, but we observed similar values what were there with thermal curing. So idea is that values are similar, but we are more highlighting the process capability in terms of the cure cycle time which it takes, and of course the energy consumed.
Thank you.
Want to ask?
Thank you, sir, for your enlightenment address, and I hope that all the participants have benefited with the lecture that you have delivered it. And we, from the organizer side, I would like to thank you for accepting our request. Thank you, sir. Thank you once again.
Thank you so much for having me.
Now, moving ahead, our next speaker is Professor Raghu Rajan Pandian sir from NIT Warangal, who will present on the development of carbon epoxy semi-cured composite laminates for applications in aircraft structures. Sir research interests include advanced polymer composites, liquid composite molding processes, material process modeling, and polymer nanocomposites. Sir is currently the PhD coordinator in the Department of Chemical Engineering at NIT Warangal. He is also involved in several key roles, including Professor in charge of the Chemical Engineering Colloquium and Mass Transfer Lab, and Treasurer of the Chemical Engineering Student Society and IICHE Student Chapter. His ongoing research projects include developing aerodynamically stable thermal protective systems using hybrid nanofilled carbon composites and 3D printable composite thermal sheets. With extensive experience in various research and consultancy projects, Sir work focuses on the development and optimization of composite materials for high performance application. His talk will provide valuable insights into the advancements in carbon epoxy composite laminates and their potential uses in aircraft structure. We welcome you, sir.
So, thank you, Professor. So, for your generous introduction. Thank you. So, I think I need to do dual role today as a tail ender watchman, or or first is tail ender watchman, or to pinch hitter, right? Yes. Yeah, I need to pinch it, right? I have to complete within speculated time. So my topic is development of carbon epoxy semi-cured composite laminates for applications in aircraft structures. So this is a part of work in developing one-shot thick section integrated composite, which is funded by extramural research scheme of DST. So here comes the definition of the problem. When you come to aerospace composite laminates, two restrictions are there, bottlenecks are there. One is we cannot manufacture a composite laminate having a thickness more than 12 mm. First one is. Next one is you have to have a pore volume less than 0.01% as per the Airbus standards. And generally, if you see in Airbus, we manufacture autoclave, this thermoset composite parts using autoclave molding. But the problem with autoclave molding is it is costly technique and it has part size limitation, because you can maximum manufacture a part size to the part size of the autoclave molding. Next one is it requires higher processing time and it has lesser production rate, and you need to have a skilled laborer and you need to have skilled designed tool to withstand pressure and temperature. So obviously, when you manufacture a composite laminate for aerospace structures, you should have a uniform resin fiber volume fractions, uniform product thickness, reduced porosity, surface properties, and dynamic load bearing capacity. So as I told earlier, it is a part of development of one-shot thick sectioned composite laminates. So this is development, how we are making that the thick section, one-shot thick section composite parts is by development of thin sectioned semi-cute composite laminate. Then we, using thin film adhesives, we co-cure thin section composite laminates and to manufacture the one-shot thick section composite laminates. So the main advantage of this I mean, not to change. The pointer is not there. Okay, fine, no problem. So if you see the bottom figure, so you can co-cure two different laminates. So which will be helpful in two ways. One is it can have dynamic loading, it can bear dynamic loading and it can bear a differential loading. So you can apply dynamic loading as well as differential loading. You can apply two different types of loading on both ends of the thick section integrated composite laminates. And once it is co-cured and it is made as one single component, you have to do the quality estimations. Okay, so this is the total methodology. First, to prepare the semi-cute composite laminates, first of all you have to read the thermal characterization of a resin through differential scanning calorimetry. From that you should obtain time temperature cure window for the resin. Then you have to develop the semi-cute prototypes, semi-cute composite prototypes through different molding techniques, and you have to use those semi-cute composite laminates, and with the use of thin film adhesives you have to co-cure and you have to make the one-shot thick section composite laminate. So I'll be dealing with the thermal characterization of resin in the later part. So when it comes to quality estimation, first of all you have to find out adhesive bond strength. So next one is for the semi-cute panel, which is of our interest. You should go with surface contaminations through XPS, and you should do porosity analysis using optical microscopy and X-ray tomography. Then you have to find out, like, I manufacture the semi-cute composite laminate and I can transport to somewhere else and I can produce the thick section composite laminates in situ. For that, I should know the storage capability. How can I store the semi-cute composite laminates? And I should find out the panel homogeneity through cure volume for cure degree of cure measurement as well as Favre volume fraction. So with respect to different dimension, you have to find out cure volume, cure degree of cure as well as volume fraction. That should be uniform with the distribution. Next one is you have to analyze the resin bleeding. So when you transport, obviously you may transport with the layers with a certain pressure. So you should know how much resin is getting bleed out when the laminate consistency is a semi-cute one. So as I told earlier, I have used RTM6 resin because it is for aerospace composite laminate. So when you go through any resin product data, the manufacturer will not give you any detail about the mechanism of curing. That means you're never going to get the data of time temperature cure. That means if I apply some kind of cure cycle, say 140 degree for 5 hours, what may be the degree of cure? So generally we may not need this data because we tend to cure the composite laminates 100%. Whatever data it is given prescribed by the supplier, we will be utilizing, and we say that the composite laminate is 100% cured, which may not be true. But in this case, I have to prepare the semi-cured composite laminate. I need to know the complete cure knowledge to the applied cure cycles. So for that, what you have to do is you have to apply differential scanning calorimetry method. At first, you have to perform the thermal characterization, dynamic thermal characterization through DSC. That means 10 degree per minute ramp. You have to do it from the room temperature to the storage temperature to the 400 degrees centigrade, maybe thermal degradation temperature of resin. So in that, what you can obtain is, since the resin curing is exothermic in nature, the heat evolution behavior is recorded as a function of time with respect to rise in the ramp. RAM temperature. So you will get, so at first you will get heat flow as a function of time at different temperatures. Next one, from that figure, you have to find out what is the onset temperature of curing at the peak temperature of curing, and you have to select at least 5 different intermediate temperatures to conduct the isothermal study. Generally, in composite curing, we used to perform at isothermal temperatures because we don't want differential cure evaluation within the part thickness. So that's why it is prescribed to cure the sample at isothermal temperatures. So to understand what may be the ideal temperatures, isothermal temperatures to cure my resin, you should perform the non-isothermal study and you should find out what is the onset curing temperature and the peak exothermal temperature, and you should perform in between 4 temperatures. There is one another truth behind it, that is that when I perform the temperature which is lesser than the onset temperature at DSC, it takes a lot of time to complete the curing reaction, so that the sample has to be retained within the sample holder of DSC for hours. But when I keep the temperature more than peak temperature, before the DSC machine senses the heat flow, substantial reaction might have been completed. So obviously you should select some temperature in between, at least 4 to 5 temperature between the onset cure temperature and the peak cure temperature. So once I perform the isothermal DXC experiments, you will get a plot of heat flow as a function of time at a different isothermal temperatures. So I can get a degree of cure from this plot by having partial area divided by total area. Total area will be giving you heat of evolution, total heat of evolution, and the partial area will be giving you the heat at the particular time. So partial area divided by total area will give you the degree of cure. Once I get the degree of cure as a function of time at a different isothermal temperatures, I have to take slope of every instantaneous time, and if I plot it, that will give you d alpha by dt, which is nothing but rate of cure. So rate of cure using classical curing kinetics equations, rate of cure is modeled as a function of temperature and degree of cure. That will give you the classical curing kinetics modeling. So from the curing kinetics modeling, you have to extrapolate the kinetic parameters from the lower end temperature to the higher end temperature, where the prescribed temperature zone is prescribed for your resin. You can extrapolate those parameters and you can produce time, temperature, cure window for any type of resin. Let me see how it is developed for RTM6 resin. So as I told, I have performed the isothermal curing studies at DSC at ramp of 10 degree per minute. So you can able to see 3 plots are there. So you can able to find out what is the onset temperature, what is the peak temperature, and you can able to see that the onset temperature is almost 160-170 degrees centigrade and the peak temperature is almost 240 degrees centigrade. So I can take a reading like isothermic curing temperatures can be conducted at 4 different temperatures, 180 degree, 200 degree, 220 degree and 240 degree. That is what performed in isothermal DSC experiments. You can able to see that 180, 200, 220 and 240 degree centigrade, and I got the heat evolution behavior. Once I get the heat flow curve, isothermal heat flow curve, so once I discretize partial area by total area, I can able to plot degree of cure. So after getting the degree of cure versus time for different isothermal temperature, again I can differentiate, I can get it d alpha by dt, which is rate of cure. That rate of cure is plotted as a function of degree of cure to fit into classical cure kinetics modeling. Here we fit into 2 different models. One is Kamal and Sarur model, which has 4 parameter model, and modified Kamal and Sarur model, which is 3 parameter model. Whichever lowest parameter model fitting too good, which will be taken as the best model. Here modified Kamal and Sarur model, d alpha by dt is equal to k alpha power m 1 minus alpha power 1 is taken as the ideal model, and it is exactly fitting, having more than correlation coefficient, it's coming more than 0.9. So with the kinetic parameters k, right, as a function of temperature, I can extrapolate kinetic parameters. What are the kinetic parameters? Arrhenius equation, that is frequency factor and the activation energy. Using those two factors, I can extrapolate, and I have defined the complete cure process window for the RTM6 resin. You can see it is defined from 120 degrees centigrade to 200 degrees centigrade, and time is like few hours. Like if I choose my cure cycle as 140 degrees centigrade for 3 hours, without performing my experiment, from this data I can extrapolate and I can say this is my degree of cure. So with only 4 different data, I can explore complete kinetics of RTM6 resin. So now, obviously, we have performed DSC for resin, but what we interested is that semi-cure of the composite panel. Since composite consists of carbon fiber and RTM6 resin, so we may expect that the carbon fiber may offer some resistance for the heat transfer and degree of cure. So that's why we have to check whatever cure evaluation behavior of the composite panel is to be compared with the cure evaluation behavior of the resin. So we have performed with respect to hot press process. So here we have used RTM6 resin, carbon fiber fabric of G0926 with 5H satin U, and matte architecture of 6 layers at 90 degree, 90 degree, 90 degree. These are the parameters took from Airbus. Then we have checked actually with respect to our previous plot. We thought like the cure cycles with 160 degrees centigrade, 140 degrees centigrade with different time interval will give us optimistic results related to semi-cured panel. So that's why we are going to give 160, 140 degrees centigrade with the time intervals we will be exposing in the hot press process, and we try to study what will be the degree of cure of the composite panel. So if you know the composite molding processes, actually there are two. One is RAM zone. RAM zones, if I have to go to 160 degrees centigrade, you cannot go to 160 degrees centigrade straight away. What we have to do is, you have to use a RAM from room temperature to 160 degrees centigrade. Then you have to put a platform of 160 degrees centigrade for isothermal temperature for given time. So here we have used ramp of 10 degree per minute from 100 degree to 160 degree. And at isothermal temperature, it stays for 160 degree for 1 hour. So we will keep this cure cycle and we try to find out what will be the cure of composite laminate. So if you compare the cure evaluation behavior of the RTM6 resin as well as the laminate, you can able to see that the RTM6 cure resin cure is lesser compared to the composite laminate. So obviously in the earlier stages I told that so carbon fiber can give you some kind of resistance for the heat transfer, and it is expected that the degree of cure should be lesser than the resin, but it is just opposite in compression molding. So what may be the reason? Because when you do the resin characterization in DSC, so whenever heat get evaluated in DSC, it is vented out by the nitrogen purge. So no heat gets stored inside the pan, in the pan, okay, DSC pan. Whereas in the compression molding, so obviously the sample is completely closed, right? It's with a metal mold. What will happen when the heat get evaluated? It get trapped inside itself. It get trapped. So when heat is getting trapped, since it is exothermic in nature, more heat is getting evolved and it is trapped inside. Actually, the temperature of the sample is much more higher than the applied temperature. So that's why the curing of composite laminate is higher than the resin cure. It is the case of 160 degrees centigrade. So when you go to 140 degrees centigrade, the same trend is getting observed. So another important thing is that I have to manufacture semi-cured composite laminate and I have to transport it. So there are two important parameters. One is degree of cure and the physical consistency of the laminate. So when I cure to lesser curing, certain cure like, so when I have a curing of 30% degree of cure, what will happen? It is very tacky in nature, it is very flexible. So this is very smaller sample, that's fine, you can able to extract it up. when you do it in a real RTM mold, when you extract, what will happen? Since it is flexible, the dimensionality may not be get retained. But when I go for higher degree of cure, for an example, more than 60, 70 degrees centigrade, it is more disadvantageous, because we said that to produce thick section composite laminate, we will be having thin adhesive film and we will be co-curing. So when this semi-cured composite laminates degree of cure is more higher, there won't be any interfacial curing. Interfacial bonding you may not expect with the thin film adhesive. So you should have a trade-off between degree of cure and the flexibility of the panel. So obviously, here the gelation is very, very important point. Obviously, you know what is resin gelation. So where it get converted from the gel state to the rigid solid state. So you should find out when this resin is getting to rigid solid state at what degree of cure. That you have to check. In both the cases, it is coming 40%. 40% degree of cure, it becomes rigid. So when you make a semi-cured composite laminate at more than 40 degree to 45 degree of cure, it is ideal, so that you can see that it has a minimum degree of cure and it has the physical consistency. It is not more flexible or tackiness. So obviously we have tried out with the RTM also. So this is not simply a RTM, this is vacuum enhanced resin transfer molding technology. This mold we have developed on our own. So we have a resin tank also, which is, because at room temperature RTM6 is rigid solid, right? So you have to have a preheating temperature 120 degrees centigrade. Before you inject the resin, you have to rise to 120 degrees centigrade so that the resin melt and it will have a flow consistency. So these are some of the mold parameters. Obviously, you have to use peel fly so that you can extract the panel from the mold. So it is designed for 60 mm to 600 millimeter to 300 millimeter dimension. So again for RTM, so first we have checked with hot press process. Next one is with respect to the RTM process. Same material we have used, but only the dimension has been varied, 600 millimeter into 300 millimeter. So mold release agent is Loctite free coat, which is supplied from Henkel, and peel ply is polyester and Dietex. These two brands were being used, and the thin film is used as epoxy adhesive FM 300. So these are very, very important parameters. This also we took the consult from the Airbus. So we tried out with the RTM process, and first of all, you know, as per the supplier, resin supplier cure cycle, 180 degree for 120 minutes. So for 2 hours, we kept it for 180 degrees centigrade. So we got the degree of cure is almost 99%, and we have done one more time. So to get the repeatability, so it has 8 layers. So again, we have gone for semi-cured composite laminate production. So first we have taken cure cycle of 140 degrees centigrade for 30 minutes. So we got degree of cure as 15% and panel thickness of 2.6 millimeter. And with second one is 140 degree for 60 minutes, you got degree of cure is 15 minutes. So 140 degree for 30 minutes got you 15%. And 140 degree for 60 minutes got you 21%. So again, for a different time factor, 140 degree, earlier 30 minutes, 60 minutes, 90 minutes and 120 minutes. And calculation here is 30% and 38% respectively. So you can see that cured state is semi-cured. So with the usage of peel ply also, because we have used different peel ply, this also may have certain hindrance for the heat transfer from the mold surface to the panel. So with no peel ply, you get a degree of cure for 160 degree 45 minutes, 53%. But with the polyester peel ply, you got 56%, and Dietex peel ply, you got 55%. So obviously, you can see that polyester is it is also as like what we have defined in hot press process. Same phenomena is happening here. That's why this degree of cure is little higher. So you have to obviously, as I told earlier, again we have to have a trade-off between the degree of cure and physical consistency. So this is the semi-cured panel cure evaluation. So obviously I didn't given a data like with the experimental result like what is the difference between the cure evaluation behavior of the resin as well as the panel. So we have found out one model which will tell you what will be the cure differences. So we have done lot of experiments and we compared the cure evaluation behavior of the resin as well as cure evaluation behavior of the panel at different thicknesses we have evaluated, and we have made a model such that it will predict you if you increase 5 to 10 degrees centigrade other than the designed cure cycle, obviously the cure differences between the laminate and the resin, neat resin differences can be reduced, which I mean that the composite panel will behave like the resin cure. So we have found out the model. We will tell you at what degree has to be increased. Say for an example, if I am applying 150 degrees centigrade for 30 minutes for the resin cure, for the resin curing, so what will be the cure cycle has to be applied to the composite panel such that you will get the ideal curing. Say 30% ideal curing, it will happen with the resin as well as it will happen with the composite laminate. So after that we have to go for the quality measurements. First one is cure evaluation and thickness variation and water ingestion. So water ingestion is very simple, like what will be the change in the weight. So next one is how the degree of cure varies with respect to room storage. Simple room storage, I am not going for cold storage. At normal room temperature, what will be the change in the degree of cure if I store it for 4 or 5 days. So you can see that it may be a smaller variation. So we can say that like there is always a thermal stress that is induced within the composite panel, which may add to rise in certain degree of cure. So generally because RTM6 resin is thermally activated resin, you doesn't need any curing aids. So you doesn't need initiator or accelerator to cure it. Whereas if you apply temperature more than 180 degrees centigrade, it will automatically starts cure. You cannot stop it after all. But you can reduce the rate of curing by reducing the temperature. So at every temperature, once it is thermally activated, some degree of the curing will be happening. So it may be the chance that there may be some residual heat there in the panel at room temperature, which will be the reasoning for the slight increase in the degree of cure. So this is again with respect to refrigeration. So refrigeration means it is to be at -5 degrees centigrade. So this is also very smaller difference only it is there. So what I can conclude is that whatever semi-cured panel you are manufacturing, you can store at either room temperature or at cold storage. So generally we do it at cold storage only. So to measure the homogeneity, panel homogeneity, so for 300 dimensionalized composite panel, so we have taken 3 samples. One is as mentioned 75 mm, 150 mm, 225 mm. There we have extracted the samples, and we have done 2 things. One is we have analyzed for degree of cure and fiber volume fraction. So from the table you can understand that we analyzed 2 different panels. With the panels at the mentioned dimensions, you can see that there is no appreciable change in the degree of cure as well as fiber volume fractions. So this is simple optical microscopy. When we could not able to afford for high-end pore volume analysis, you can go for optical microscopy. So if there is any macro pores, you can easily able to obtain from the optical microscopy. So this is simply composite fully cured as well as semi-cured. So generally what will happen is, so there may be change in the porous nature with respect to degree of cure also. So that's why we try to find out whether there is any pore volume change with respect to semi-cured and fully cured panels. So we have done with X-ray tomography also. So as we said, like it is to be less than 0.1 percentage pore volume. So it is 0.014 percentage, which is very much appreciable. So this is for 40% cured composite panel without peel ply. So you can able to see that whatever the red points are there, those are this thing pores. So what we are concluding here is that, so irrespective of going for autoclave molding, we have used vacuum enhanced resin transfer molding. So this is not simple resin transfer molding, there is vacuum enhanced resin transfer molding. Whereas in the injection port, you will have the injection pressure, but at the exit port, exit vents, you will have vacuum attached. So with that process, what we have achieved is we can able to manufacture so aerospace grade within RTM process itself. So since this is the very important parameter where you should have less than 0.1 percentage pore volume, we can able to achieve. So this is for 100% cured composite panel. This is also coming very less pore volume percentage. This is volume percentage actually. So for 60-degree cured composite, so we try to find out what will be the change in the pore volume percentage with at different cure level. So for 100% cure, again it is 0.006%. So there are certain observations. So obviously it is required to cure the composite panel to a minimum degree of cure, say at least 30% of curing. Otherwise, the extraction of panel from the mold becomes difficult. Extraction of under-cured panels using forcible means can lead to panel damage and alteration in panel dimensions. So obviously we know that the strictness in the dimensionality for aerospace grade composite panels. So then proper mold sealing and sealing thickness should be ensured. Obviously, if sealants are not matched properly, there will be bubbles entrapped. So obviously what will happen? That part has to be rejected. The next one is the composite panel cure may differ to the different trials of same cure cycle. If resin preheating, mold filling time differs. So you should standardize everything. So obviously if I conduct the same cure cycle, first time, second time, you can have a differential cure, composite panel cure, because there may be difference in resin preheating time. Hence, care should be taken to ensure the idealistic resin preheating and mold filling time at each trial. Also, uniform resin conditions have to be maintained during storage and preheating stages. Even the resin, neat resin also has to be cured at conditioned process. So that's all about my presentation. Here, I just wanted to say what I am doing at my lab. So I have 4 different projects, sponsored projects. One is of design of aerodynamically stable thermal protective systems using hybrid nano-filled phenolic carbon composite ablators. It is from core research grant. It is granted in 2024 this year. So this is still next 3 years it will be there. And next one is development of 3D printable composite thermal seals. This we are doing it for Advanced Systems Laboratory, DRDO. So they are the collaborator. And we have research grant of 30.9 lakhs. This is also again CRG core research grant from DST sir. And next one is, it is combination of experimental from simulation tool, development of simulation tool in predicting the ablation behavior at rocketry, that is re-entry problem. So for re-entry capsule, we have composite ablator. We can predict what will be the mass loss percentage at the surface, how the composite ablator behaves at the aerodynamic loading. So that is for, this is from Spark, Minister of Education, having 45.42 lakhs, and it is sanctioned in 2023. And recently again one more project got sanctioned, development of cerium oxide based dispersion for functional polymer coatings from IREL India Limited. And this is of 41.88 lakhs, and just 2 months back it got sanctioned. So these are the ongoing research projects currently. So just to have a view of my lab. So we work on, I have currently 8 PhD scholars working under me. So they are working under different heads. One is advanced polymer composites for mass transit system. We are developing components, and particularly right now we have mastery for the rocketry and space and rocketry composites. And we recently started working with advanced polymer coatings with the cerium oxide based, and also we are already started working on hydrogen barrier storage transmission coatings. Then 3D printing, just 2 years back, we have started with 3D printing of neat thermoset resins as well as nanofil thermoset resins. And my team has developed one COMSOL algorithm for optimization of curing as well as mold filling process. Actually, we have published a few papers based on this software developed by us, one team. It is in-house coded. So we will be waiting for some more process, some more experimental validation. After that, we will try to keep it as open source. That will be helpful for a lot of small scale industries. So these are certain, there are several facilities available. Very importantly, I want to say that we have 3D printing facilities for photo cure resins, neat thermoset resins, as well as nanofilled resins. And resin transfer molding is there, and we can have experimental setup. This is designed and developed by our team. Reinforcement mat permeability, which will give you KX, KY permeability data for any kind of fiber or any kind of test fluid. And we have another beautiful equipment, weathering chamber, that is simulated weathering chamber. We can simulate light intensity, the water spray, that is humidity and temperature within that simulated chamber. And we can find out the aging process in the composite material, either it is biocomposite or any composites. So that ends my presentation. I'll be happy to face any questions available. Thank you. The chamber can go to 100 degrees centigrade. Yes, not zero actually. It will be room temperature to 100 degrees centigrade.
Any other questions, please, from the audience? Thank you, Professor Raghu. May I now request Dr. Chaitanya Shah to please felicitate Professor Raghu. Sir, please. Sir. Thank you, Professor Raghu. Thank you, Dr. Chaitanya. It's my pleasure to introduce to our next speaker, Mr. Vijay Kumar and Mr. Prem from Space Society of Mechanical Engineers at SAC ISRO. They'll be delivering a talk on advancements and challenges in the development of lightweight structures for space applications. So Mr. Vijay and Mr. Prem Pal, they will bring a wealth of expertise in the field of space engineering and lightweight structures. I hand over them.
Thank you. I'd like to thank organizing committee and the university, SICA and SSME for giving me opportunity to share my experience on light valve structures, especially for space applications. So it is already too late, so I will try to finish within 10 minutes. Yeah. 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 So I will just briefly describe where this composite applications is happening. So if you see this presentation from the defense to space and ground segments of launch vehicles, satellites, reusable vehicles, satellite and payloads, vessels, pressure vessels, and energy applications, civil applications, sports equipments, marine applications, everywhere these composites are used. So in day-to-day business also, we can see everywhere these composites parts we are seeing, even from the toothbrush, morning session sir was telling, to in the kids this toy car. So everywhere it is composites is using. Yeah. So basically, what composites is? So it is a basically combination of two macroscopically items, fabric as well as resin systems, in which we are taking the best property out of both the things. So one component is making from the composite, so it is having the modulus property of the fiber and the load transfer property of the resin systems. So this is not the composites we are using the first time. So earlier days also we are using the composites. In Egypt times also they are using the composites. They are using in the mummies cases. They used in paper pulp for POPs, reinforced concretes, bricks of clay, reinforced with straw. All these things is an example of composites. The lightweight structures for space application, especially if you can see the amount of this investment is required for launching a single kg of payload. So if we are launching for a LEO mission, 1 kg if we are saving the mass, it is $8,000 we are saving it. Or if we are launching for a GEO mission, we are saving $27,000 per kg mass we are saving. So if you are going for lunar surface, it is 1.2 million per kg we are saving it. So similarly to Martian surface, 2.7 million per kg we are saving. So 1 kg mass if we are saving, we can save this much amount of money. So after all the money is our taxpayer money, government money. So we should actually try to focus how we can optimize our structures. So we have seen people who are making and designing the structures having a lot of margins. So we should concentrate on lowering the margins, just enough to survive our load cases. So why composites? This slide itself shows that it is a tolerable property. It is having very high specific stiffness, very high specific strength, and low density, high energy absorption capabilities, high suitability, and for space application, the last 3 points are very important. Low coefficient of thermal expansion, dimensional stability in wide temperature excursion, because in space we can see the temperature for plus side it is up to 200 and negative side is minus 250. So with these conditions it has to survive. So you can see the last one graph, the best optimum property we are getting from the CFRP composite. Even zero door material if you are seeing, in negative cycle it is not working. Here also deformations is very high. So we have to go for a CFRP composites for highly dimensionally stable structures. So it is not like that the composite is having only advantage, it is having certain disadvantages also. So you can see these are the disadvantages, and we should choose the composite material accordingly. Everywhere we cannot use it. See, the same composite material if you are using for deep space communication, up to KU band CFRP it is well reflecting, it is communicating. But if you are going for more than that KU band, that is more than 18 GHz frequency, it won't work. We have to go for a metallization. Either we have to use for a copper cladding or we have to use for a sputtering method so that it can communicate. So up to KU band it is work fine, it will work CFRP, but above that it won't work. We have to go for a metallization. So we have to choose the material accordingly. So end use is very important, where we are using it. This is one of the examples from Airbus, Boeing and Airbus. Everywhere they are using the composites. And you can see this Boeing slides, all this blue material is composites. So this is 2016 data. So now they have almost converted 70% of the material into composites. So and percentage share of the composites, you can see this is the percentage share of composites. This data is up to 2010. So everywhere you can see the composites market is there. These are the basics process which we are using for fabrication of composites. Which thing I highlighted in green color, basically this processes we are using for fabrication of the components for aerospace applications. Autoclave molding, filament winding, this autoclave molding for structural applications, filament winding we are using it for pressure vessel applications. Additive manufacturing slowly we are inducting, but that qualification still is going on, it is not fully qualified. So these are the methods we are using it. On coming to the launcher, we have already converted so many components into light wire composite structures. If you see from the top, the pellet fairings, isograde PLA, this pressure vessels, nozzles, then throat liners, interstages, everything that payload fairing, payload adapters, everything we have converted into composites. Now this top side launch vehicle Mark III, which is our now biggest launch vehicle, and its capacity is 4 ton to the payload for GTO orbit. So that payload fairing is made of fully composites, that is called OZI composite fairings. In composites also, earlier we are using Kevlar, gas bottles, but now we have converted Kevlar to carbon also. So that way also mass saving we have done it. So for space applications, basically we categorize these composites into majorly 3 categories. One is structural composites, which are mainly used for making structural elements like PLAs, reflectors, solar panels, antenna reflectors, Sadacone mechanism, yoke. This is yoke which is used for mounting the solar array drive assemblies. Second is filament wind composites. These products we are using for pressure vessels where very high pressures operating is required. There we are using the filament wound pressure vessels. Then third one is additive composites, where a high temperature application is required. There we are using additive composites. This is one of the case study. For any composites manufacturing, this first design and simulation is very important. So what we do from the design, we take the how it will work. So performance we are evaluating. What is the time is required for readiness of that product, that is time to market, and what is the cost involved in that work. So we are all this accessing from the analysis. Then development risk, that what is the risk involved for developing certain type of material. So we are using these 3 from this simulations part. So these 3 space component design, if you see the last 3 points, design for realization, launch loads, on orbit load conditions. These are the cases which we are designing for any component for our space structures. This all things is possible thanks to FEA tool. This is Patron, Nastron, Abacus, NX, Siemens, NSYS. These are the tools that we are using it for the simulating. So in the space applications, any product which we are making it is qualification, and this process flow is very stringent. So we have to go for all these processes, and we have to give the checkpoints every stages, so that we should not violate any norms. We should not accept any other material which is going to be defect after assembly. So we are respecting in between this process flow. So, coming to the characterization of the materials for space applications, we have I've shown only a few qualifications as for raw materials and product per se, but list is very large. So all these tests we are doing it before accepting of any materials. Tensile, compressive, shear, analysis, these are for the prepacked materials. Flexural, lab shear strength for adhesive material, flat-wise tensile test, peel test, flat-wise for sandwich materials, peel test we are using for the coating materials. Then environmental test. This is the one of the tests that we have to do for on-orbit conditions like outgassing. This material should not outgas in the outer space condition, in deep vacuum conditions. So this test we have to performing by total mass loss, TML, CVCM, and WBR tests. Then we have to test for CTE. So all these spacecraft structures, these components are very highly stable. So we have to go for a CTE measurement. So the CTE measurement should be near to 0. So we are using such type of material which is having the CTE is very least. Then CME. CME also is a very stringent test, so that any deformation should not happen due to the moisture. Then TZ is one of the important tests. From product level, we see this, these are the tests that we are doing it as a product qualification. NDT at every stages, thermal baking we are doing it, thermal vacuum cycling we are doing it, vibrations, sine, randoms, then quasi-static load conditions, acoustics we are doing it, appendages test we are doing it, and geology test we are doing it. This is as a product level we are doing it. This is the advanced technology fusion actually our other centers are using. This is basically when doubly curved surface are there, complex curved surface are there where we cannot use directly manual layup. So what we are doing it, we are cutting it in a prepare cutting machine and then we are laying up with respect to this laser projection guide machine. So what is the advantage of this technology? This better accuracy we are achieving. It is up to 0.1 degree, within 0.1 degree we can align the fibers. Then fast layup process, no misalignment, fully automated process. So this is the major actually advancement in our resource centers. This is one of the method co-curing technology that also we are using it for making these lower thickness products like reflectors, solar panels. We are using these co-curing techniques. What happens in these techniques? Both the top skin and bottom skin of a sandwich structure we are curing simultaneously with the core. In this number of parts is reduced, curing cycle is optimized, process lead time is optimized, and pre-stress we are minimizing it. So this is the one of the process that we are following at our resource centers. Coming to the one more process that is actually nowhere people are using it. This is the reticulation process. This is basically areal mass density of the film adhesive we are reducing it. So if you see a panel, solar panel size is almost it has gone up to meters, means 3 to 4 meters, and width will be around 2 meters. So that much area, if you use the film adhesive and the core cell size is very large. So what will happen is this most 90% of the adhesive will be unused. That is lying between the core. So what we are using, we are removing the unused adhesive and only the adhesive which is lying on the core shell area, that only we are retaining it. The process is called reticulations. So again one more advancement we are doing it in carbon-carbon area. See, that is the spacecraft recovery experiments we have done in 2007. Actually, this was one of the major goal we have achieved. But that time, that much technology was not there. That social networking was not there. That's why it was not published too much. It was spacecraft recovery experiments. This satellite we have already cup cone flare shape. We have sent to the space, and it has done the macrogravity experiment for 7 days, and then it has returned back to our Earth. So if you see this round portion, that one, top one, that is made from carbon phenolics. Later we have in SR2 missions, we have converted it into carbon-carbon. So all this landing gears, everything we are making it in carbon-carbon. This not ISRO is making, this is from aerospace industries are making. Coming to the future advancement in manufacturing, these are the scope of improvement. We can go for automation so that we can reduce the tooling costs, improve part performance, lightweighting, damage tolerances, fail-safe design we can go for. In quality assurance we should be targeting for. Product repeatability we should be ensuring. Process standardization we should be going for. And scalability, this is one of the most important topic. Coming to the from the raw material per se, this textile performance, 3D fiber reinforcement, braiding, etc. that we should be using for structural composites. Automated tape laying, fiber placement, that also will be targeting. And liquid molding technology, especially for non-autoclave like RTM, vary process, we should be targeting for SPS component. Now, generally we are using for autoclave curing process. It is very costly. So we should be targeting for such type of adhesive system which can be cured without application of autoclave. Then new sandwich technology like which can give us the acoustic damping. So if you see the figure like right one, that is the structure is 5 to 6 meter diameter and it is free from the acoustic damping. So also this resin system which they are used in this particular product is flexible kind of nature. So it can be foldable and it can be used during the launch condition and then it can be later deployed in on-orbit conditions. Then usage of smart self-healing materials. So that also we should concentrate on self-healing materials. So any minor damage it happens, it should heal itself. This is basically this lattice type structures. We call it isolated structures. We are using in this. We just below the cryo stage. We are using this type of lattice structure, and product also we are using this coilable structures, so that efficiently we can save the mass. Now, this new concepts are trending nowadays is doping. So, in composites, we should be targeting for doping also. See, CNT is having the property which we are looking for, but alone CNT we cannot use it. So, we have to use it within our carbon fiber. So, this doping, if we are introducing, we are getting the property which we will be requiring for these applications. Then joining techniques. This also I was telling earlier also. Now whatever the film adhesives nowadays in market it is available. It is curable in high temperature conditions, temperature conditions. That is not available. It is costly affair. So we are targeting to develop such a type of film adhesive which can be cured at a lower temperature. Then new research we should be focusing on damage tolerances and repair. And the last, whatever these composites we are using it, we should be able to recycle it. So these are the challenges during the recycling we are facing it. Long versus short fibers, glass fiber versus carbon fiber, high cost is involving. So these are the recycling process people are using it. Chemical, eliminations, pyrolysis, mechanical shredding, grinding, extrusion, whitewashing, and thermal incineration. This is a process basically worldwide people are using. And one Tech in USA is there. Actually, they are having an agreement between Boeing and Airbus for recycling of aircraft components. So what they are using it, they are using their property catalyst, heat and pressure with composites. So byproduct it is coming as a adhesives and fiber. That adhesive they are using for wooden industries for joining of the wooden products, and fibers they are recycling it. So this is a pilot scale reactor actually. Full scale they are going on. Development is going on, and this is the incineration process which widely used in our research centers for decomposing of the composites. These are the few references. Thank you.
Any questions from audience? Thank you. In that case, thank you, Mr. Vijay. May I now request Professor Patel to please felicitate Mr. Vijay. Thank you, Mr. Vijay. So with this, we have reached the end of today's fruitful, learningful sessions, and we now look forward tomorrow morning to continue with the conference and a lot of more presentations which will lead to our insights and more of knowledge in the subject of composites. So enjoy your evening and we'll meet tomorrow morning. Thank you. Have a great night. Okay, I request group as in, sir, all or the presenters? Okay, all the dignitaries present in the conference room are requested to please join here. Leave your luggage there, please come this side for a group photograph. All of you, please. Sir, I think it would be better that majority comes up because he too requires space, cameraman.
Recondition.